von meinem Technikteam, damit unser Livestream starten kann. Oh, es geht schon los. Okay, meine Damen und Herren, es wird spannend. Ich freue mich sehr, dass ich erneut die Data Week moderieren darf. Und wir haben ganz, ganz viel vor. Aber bevor wir darüber sprechen, müssen wir erstmal eine grundlegende Frage klären. Und zwar sind wir ja hier, weil wir alle wissen, Daten können die Welt verändern. Und deswegen kommen ganz, ganz viele Leute, Experten, Kreative und Zukunftsgestalter in dieser Woche hier zusammen, um neue Ideen zu entwickeln, sich zu vernetzen und ihren Horizont zu erweitern. Mein Name ist Linda Drescher und ich weiß, ich muss hier noch weiterklicken. Ich hoffe, dass es jetzt funktioniert. Oh, es funktioniert nicht. Mal gucken. Oh, jetzt sind wir zu weit. Ich weiß immer, wie die Professoren sich fühlen am Anfang. Die stehen dann immer vor der Klasse und denken sich, warum funktioniert das Ding nicht? Ja, ich habe nämlich extra eine Folie bekommen. Das ist mein Name, Linda Drescher, und ich freue mich sehr, in diesem Jahr wieder dabei sein zu dürfen. Was haben wir denn alles vor? Klick. Da sehen Sie es. Es wurde ganz kurz einmal erläutert, was alles passiert in dieser Data Week Woche. Zum einen werden wir uns jegliche Art von Daten anschauen, also strukturierte, unstrukturierte, was es alles so gibt. Ich werde auch einiges dazulernen in dieser Woche, das sage ich Ihnen. Und wir sind nicht nur in digitalen Identitäten unterwegs, im Semantic Web oder beschäftigen uns mit digitalen Zwillingen. Nein, wir werden auch ganz weltweit die Betrachtungen aufschlagen. Das heißt nicht nur hier regional oder unsere Kommune, die wir kennen, sondern wir werden weltweite Betrachtungen anlegen. Und ich finde den Spruch ganz unten ganz hübsch. Da wissen Sie genau, was Sie erwartet. Eine Reise durch die menschliche, künstliche Intelligenz und allem, was dazwischen liegt. Und was dazwischen liegt, das ist wahrscheinlich auch spannend, oder Sandra? Ja, denn da möchte ich nämlich ganz kurz auch noch mal was zu Sandra sagen. Ich freue mich immer, ich kann nicht moderieren, ohne dass Sandra an meiner Seite ist. Die bringe ich überall mit hin. Sandra wird ganz wundervoll, für die, die keine gute Handschrift haben, die ganze Data Week mit an meiner Seite sein und ganz wundervoll zeichnen, wo die Essenz lag, ne, in den Sessions. Sag noch mal ganz kurz, worauf es bei dir ankommt. Was wird hier auf dem Papier passieren?
Das, was ich verstehe, also von den Tagen. Also ich habe mich natürlich vorbereitet, aber so ein Bild ist immer dafür da, nochmal so eine Draufsicht zu kriegen, eine kurze, knappe Zusammenfassung, und kommen Sie auch gerne zu mir nach vorne, fotografieren Sie das, reden Sie mit mir. Genau, wenn es vielleicht irgendeinen spannenden Punkt gibt, der hier noch nicht drauf ist. Ja, das würde ich jetzt erstmal so lassen und wünsche dir auch und allen anderen einen sehr schönen Tag.
Schön, dass du da bist. Genau, kommen Sie gerne vor, nutzen Sie die Pause, um das, was Sandra hier vorhin zusammenfasst, sich nochmal anzugucken. Sie dürfen auch fotografieren, das ist überhaupt gar kein Problem. So, und ich weiß, dass ich jetzt wieder switchen werde. Da können Sie nämlich sehen, was wir alles an Programmpunkten haben. Also, es wird ein Innovationsforum geben. Kunst der Daten wird eine ganz wichtige Rolle spielen. Es ist ja auch die Data Week. Wir haben verschiedene Meetups, Roadshows im Programm. Den Leipzig Semantic Web Tag am 12.06., den Think-A-Thon und Jugend-Hackt Hack Day. Da muss ich unbedingt hin, Jugend-Hackt Hack Day. Da kann ich wahrscheinlich noch jede Menge lernen, obwohl ich wahrscheinlich nicht mehr ganz zur Jugend zähle, aber das ist Ansichtssache. So, und wir gucken jetzt weiter, was wir heute erleben, denn Sie sind ja heute da. Sie können übrigens auch alle Informationen noch auf der Website finden, also Sie müssen sich das jetzt hier nicht merken, es ist nur zur Übersicht, damit Sie Bescheid wissen. Und ja, also da können Sie mal ganz kurz schauen, was wir heute vorhaben. Eine ganz, ganz wichtige Info, nutzen Sie unbedingt die neue Metaplanwand. Der ein oder andere hat es vielleicht schon gesehen am Eingang. Ich suche, ich biete. Vielleicht können da auch die ein oder anderen Dating-Angebote abgegeben werden. Wir werden schauen, wozu diese Data Week noch führt. Also nutzen Sie die fleißig zum Vernetzen. Das ist eine andere Art, vielleicht für den einen oder anderen, der ein bisschen schüchterner ist im Netzwerken, ist ja nicht jedermanns Sache. Nutzen Sie die Metaplanwand. Und eine ganz wichtige Info, Frau Mitterhuber vom Bundesministerium für Wohnen, Stadtentwicklung und Bauwesen wird morgen ihre Keynote halten. Also auch ein sehr spannender Programmpunkt. Ich kenne sie auch persönlich von den Smart City Dialogen und das ist auf jeden Fall ein aufschlussreiches Event. So, und dann gucken wir mal, wie es weitergeht. Es geht schon weiter. Aber bevor das Organisationsteam hier zu mir vorkommen darf, möchte ich nochmal für alle die Info geben, dass Sie haben es ja wahrscheinlich auch gesehen, es wird live translated und Sie haben die Möglichkeit, den QR-Code, jetzt muss ich an Alex nochmal verweisen, wenn Sie jetzt zum Beispiel nur englischsprachig sind oder Englisch nicht so ganz so gut verstehen, weil wir haben ja einen wilden Mix aus allen Sprachvariationen, dann können Sie gerne diesen QR-Code scannen und sich im Livestream diese Sessions in der jeweiligen Sprache, entweder auf Deutsch oder auf Englisch, nochmal anschauen. So, da sehen Sie den QR-Code nochmal, alle gescannt, die ihn scannen wollten, jetzt kommen die Handys raus, ich gebe Ihnen ein bisschen Zeit, gar kein Problem. Ja, Martin, machen die das auch? Du musst jetzt gleich hier vorkommen. So, und nun, ich habe Ihnen schon angekündigt, freue ich mich sehr, Professor Dr. Michael Martin hier vorne zu begrüßen und Ingolf Römer, die jetzt das Organisationsteam vorstellen werden und die Data Week offiziell eröffnen. So, bitteschön, die Herren.
Check, check.
Ja, auch von meiner Seite aus ein fantastisches Hallo, einen wunderbaren guten Tag. Wie schon angekündigt, ich bin der Michael Martin, der zweite Michael heute, der hier vorne steht. Und ich bin Professor für Datenmanagement und an der TU Chemnitz und war früher am Institut für angewandte Informatik, wie mein Kollege Ingolf Römer. Und unter den Aspekten bin ich da sehr dankbar, die 4. Data Week wieder kurz begrüßen zu dürfen. Und ganz kurz zum Hintergrund. Wir sind vor ein paar Jahren mit der Idee angetreten, ich habe es vor uns schon mal kurz jemandem erzählt, deswegen muss ich es nochmal wiederholen, ein Format aufzubauen, bei dem es uns möglich ist, die Wissenschaft, die Stadtgesellschaft, die Industrie zusammenzubringen und um über datengetriebene Lösungen, Innovationen, Ideen und so weiter und so fort diskutieren zu können, diese vorzustellen und so weiter und so fort. Das hat sehr gut funktioniert. Wir sind in der 4. Data Week und wir haben jedes Jahr mehr Zulauf. Also dieses Jahr sind wir mit über 500 Anmeldungen dabei und jetzt zum Start der Woche, da wird vielleicht auch noch ein bisschen was passieren. Es gibt noch ein paar Side-Events, die auch einiges an Kundschaft, an Interessenten haben, die sich da beteiligen. Genau. Ganz kurz aber zu der eigentlichen Aufgabe, die wir beide haben, das Organisationsteam vorzustellen. Da gehe ich jetzt mal auf die nächste Slide. So, wenn Sie ins Programm schauen, sehen Sie eine ganze Menge an Formaten. Ja, wir haben Vorträge, wir haben Sessions, wir haben Podiumsdiskussionen, wir haben Hackathons oder einen Hackathon und so weiter und so fort. Und man kann sich vorstellen, dass jedes dieser Formate natürlich eine Menge an Vorbereitungszeit braucht. So, und das ist keine Einzelaktion, das sind eine ganze Menge an Menschen, die damit zu tun haben. Und ich kann sie gar nicht alle aufzählen. Einige waren schon heute hier vorne. Die Moderatoren darf man dabei auch nicht vergessen. Und die bildgebende Maßnahme hier, die bildgebende, Entschuldigung, hallo Sandra, ich grüße dich. Sandra. Genau. Und was ich eigentlich sagen möchte ist, Sie sehen hier vorne an der Slide das Kernteam derer, die sich hier fast ein ganzes Jahr lang jetzt engagiert haben, diese Data Week aufzubauen. Und wir sind natürlich sehr daran interessiert, auch Ihr Feedback zu bekommen, Ihre Anmerkungen, Hinweise. Wir wollen diese Data Week auch in den nächsten Jahren fortsetzen, ne? Und da leben wir natürlich auch von Ihren Informationen. Ganz kurz noch, das Kernteam besteht hier auch wieder aus dem Dreiklang Wissenschaft, Wirtschaft und Verwaltung, also sprich die Stadt Leipzig, das Institut für angewandte Informatik und die Essenza GmbH sind hier beteiligt gewesen, die Data Week im Kern zu gestalten. So, und damit würde ich jetzt meinen Talk beenden und an den Ingolf übergeben.
Ja, herzlichen Dank. Also auch im Namen des Vorstandes des INFA, der Geschäftsführung, ein ganz herzliches Hallo und willkommen auf der Data Week, liebe Partner, liebe Wissenschaftler, liebe städtische Kollegen, liebe Kollegen aus der Wissenschaft und aus der Wirtschaft, liebe Besucher der Data Week. Die Data Week ist inzwischen ein ganz fester Bestandteil hier in Leipzig und das macht uns stolz, gemeinsam mit der Stadt und der Wirtschaft die Data Week jetzt schon zum 4. Mal auszurichten. Und das ist wirklich eine besondere Ehre. Leipzig wächst, Leipzig digitalisiert sich Der Bund hat es erkannt, es geht nicht ohne Digitalisierung weiter und die Geschwindigkeit wird steigen. Und es ist ganz wichtig, so eine Woche zu haben, in der Innovationen einen Platz finden, ein Marktplatz entsteht, in dem man sich austauschen kann und neue Visionen erschaffen kann. Und man hat es schon auf der Eingangsfolie der Agenda gesehen, also Hackathons, das ist viel Praxis. Es geht nicht mehr nur ums Papier, sondern um Lösungen und das ist ganz wichtig. Leipzig ist eine zukunftsorientierte Stadt und aus Wissenschaftssicht können wir nur sagen, für das INFI und auch für die Universität, es gibt kaum ein Team, was nicht ganz eng mit der Stadt zusammenarbeitet und das kann man auch mit starker Brust sagen, wir arbeiten gemeinsam daran, hier als Wissenschaftscommunity den Wirtschaftsstandort und auch den Lebensmittelpunkt mitzugestalten und zukunftsfähig zu machen. Und auch ganz besonderer Dank natürlich an die Universität Leipzig, ja, unser wissenschaftliches Zuhause, aber auch unser stärkster Partner in der Gestaltung von Innovationen, von Digitalisierungsmöglichkeiten. Der Wert der Daten vor 4 Jahren war das für uns im INFI oder auch in der Informatik-Community schon allen klar. Aber inzwischen ist es im Prinzip auch auf Verwaltungsebene angekommen, dass das nicht mehr ohne diesen Wert geht. Und die Nutzung von KI bringt darauf nochmal eine ganz andere Sicht. Und wir sehen es auch, die Community, eine sehr junge Community, packt an und gestaltet unsere Zukunft mit. Herzlichen Dank dafür. Ich wünsche allen, auch im Namen des Vorstandes, natürlich eine sehr erkenntnisreiche Woche mit viel Austausch. Es gibt ja viele Formate, die auch in der Data Week ihren Platz finden und natürlich auch unsere Sponsoren wollen wir natürlich danken, insbesondere ohne die geht es nicht. Und die glauben an die Data Week und es ist ganz wichtig, die auch für die Zukunft hier in der Stadt Leipzig zu haben und weiterzuentwickeln. Herzlichen Dank von unserer Seite.
So, ich habe mein eigenes Mikro, aber vielen Dank, Michael. Vielen Dank für euer Engagement. So, und nun kommen wir zu einer Dame, mit der wir letztes Jahr das Smart City Lab eröffnen durften. Und ich bin ganz gespannt, mit ihr ins Gespräch zu kommen, wie es denn sich entwickelt hat. Und jetzt kommen wir aber erstmal zu den Grußworten. Dr. Beate Ginzel, willkommen.
Guten Morgen. Ich freue mich sehr, hier wieder sein zu dürfen, wieder die 4. Data Week eröffnen zu können. Sehr geehrte Frau Rektorin, sehr geehrter Phil, Oberbürgermeister von Lüderitz, Phil Balau, aus Namibia angereist, gestern Nacht, wird uns hier durch die Woche begleiten. Deswegen möchte ich gerne sozusagen extra begrüßen. Es wurde schon ganz viel genannt. Ich hatte mir auch sehr vorgenommen, mich nochmal unbedingt bei den Sponsoren zu bedanken, weil auch wenn das Organisationsteam, was Sie gerade gesehen haben, hier wahnsinnig viel Kraft reinsteckt. Sie können sich vorstellen, dass hier seit Monaten das Programm gestrickt wurde, auch quasi Programmpunkte versucht wurde, sehr aufeinander abzustimmen. Wir versuchen diese Vielfalt auch in dem Programm abzubilden, was gerade schon vom InFi-Team sozusagen genannt wurde. Also diese Vielfalt der Data Week deckt sich ab aus den Schwerpunkten, die wir in der Stadtentwicklung haben, wir als Stadtverwaltung Leipzig haben und letzten Endes auch aus unseren Kooperationen und den Forschungsschwerpunkten des Instituts für angewandte Informatik, des GATS und der Universität generell. Und ich kann jetzt nur noch mal ich komme gerade quasi aus den letzten Vorbereitungen für eine sehr wichtige Keynote heute Nachmittag. Wir werden heute Nachmittag eine Festveranstaltung haben mit eingeladenen Partnern aus der Wirtschaft, aber auch der Wissenschaft zur Verleihung des Labels Klimaneutrale und smarte Städte. Und wir freuen uns auch da sehr, hier mit Hochschuleinrichtungen in engem Austausch zu sein. Aber warum ich das jetzt erwähne, wir merken, dass wir als Stadt und als die Unternehmen alle wahnsinnig viel Kraft investieren, auch Geld investieren in die Maßnahmen auf dem Weg zur Klimaneutralität, aber wir Schwierigkeiten haben, überhaupt zu bilanzieren. Hier brauchen wir beispielsweise wieder die Wissenschaft, uns dabei zu unterstützen. Das heißt, diese Kooperation, die gerade schon sozusagen auch betont wurden, genau die finden statt entlang dieser Herausforderungen, entlang dieser Transformationsprozesse. Und da sind wir wahnsinnig froh, hier vor Ort gute Kontakte zu haben, schon langjährig aufgebaute Kooperationen mit den Hochschuleinrichtungen zu haben und auch eine große Community mit dem Wirtschaftsstandort, mit den Unternehmen hier in der Stadt. Und das spiegelt sich letzten Endes hier auch in dem Programm der Data Week wieder, in der Anzahl der Sponsoren, in der Anzahl von Unternehmen, die hier Workshops und Sessions anbieten und gleichzeitig eben auch in dem Programm. Und das ist eigentlich die Botschaft, die ich gerne mit meinem Grußwort senden möchte. Einen großen Dank. Wir kommen als Stadt, als zukunftsausgerichtete Stadt, kommen wir nur voran, indem wir die Dinge gemeinsam bearbeiten, indem wir sie lokal denken, aber eben auch europäisch und international. Deswegen freue ich mich auch über unsere internationalen Gäste und möchte Sie alle herzlich willkommen heißen und wünsche Ihnen eine spannende, inspirierende Data Week, wo Sie hoffentlich auch wieder neue Kontakte knüpfen können und heiße Sie herzlich willkommen. Dankeschön.
Vielen Dank. So, und Sie merken, Multitasking ist nicht nur mein Ding. Nebenbei muss ich noch die Folien drücken, aber wir kriegen das hin. Ich freue mich sehr, nun Professor Dr. Eva Ines Obergfeld vorn begrüßen zu dürfen. Und jetzt kriegen wir das aber hin. So, bitteschön.
Danke, Frau Drescher. Ja, meine sehr geehrten Damen und Herren, liebe Gäste, liebe Partner, liebe alle, ich begrüße Sie ebenfalls sehr, sehr herzlich im Namen der Universität Leipzig zur Eröffnung der Data Week Leipzig. Als Rektorin der Universität Leipzig freut es mich natürlich sehr, hier zu sehen, wie wesentlich und auch sichtbar der Beitrag der Universität zu dieser Data Week ist. Sei es über das KI-Kompetenzzentrum SCATS AI und unser Institut INFI als Organisatoren, sei es über unsere Wissenschaftlerinnen und Wissenschaftler, lieber Herr Kollege Mahecha, der gleich die Keynote halten wird, oder sei es durch die Studierenden, sowie unsere Absolventinnen und Absolventen, die nun in den teilnehmenden Unternehmen und Organisationen auch wirken. Danke Ihnen allen. Ihr Engagement macht Leipzig zu einem Ort, an dem der digitale Wandel verantwortungsvoll, das möchte ich unterstreichen, verantwortungsvoll und zukunftsorientiert gestaltet wird. Wir haben es schon gehört, die Data Week Leipzig will den Austausch und das Netzwerk auf regionaler und überregionaler Ebene gezielt stärken. Sie soll eine Plattform sein, sie soll Raum schaffen für Begegnung und Innovation. Und diese Veranstaltungen wie heute tragen natürlich ganz maßgeblich dazu bei, dass diese Vernetzung stattfindet. Und sie setzt dabei, die Data Week Leipzig, auf enge Zusammenarbeit zwischen Wissenschaft und Wirtschaft, zwischen Wissenschaft, Wirtschaft und öffentlicher Hand. Und das geht Hand in Hand, wie wir sehen, nicht erst seit heute oder gestern, sondern schon seit geraumer Zeit. Und darüber bin ich sehr, sehr froh. Veranstaltungen wie diese sind von, wie ich meine, wirklich nicht zu überschätzender Bedeutung für den Aufbau nachhaltiger Partnerschaften. Universitäre Transferformate, Gründungsförderungen sowie Transferinstitute wie eben unser An-Institut für angewandte Informatik spielen dabei natürlich eine zentrale Rolle. Und zwar eine zentrale Rolle als Brücke. Als Brücke, wenn es denn notwendig wäre, als Brücke zwischen wissenschaftlicher Exzellenz und wirtschaftlicher Anwendung. Es wird immer so der Gegensatz aufgemacht zwischen Grundlagenforschung, das sind die, die irgendwas machen, was man nachher nicht gebrauchen kann, ich überspitze es mal, und der angewandten Forschung. Nein, so ist es nicht. Grundlagenforschung, angewandte Forschung und wirtschaftliche Verwertung oder auch, ich würde es sogar noch weiterziehen, gesellschaftliche Verwertung geht Hand in Hand, das ist nicht zu trennen. Das ist eins. Und das, glaube ich, zeigt auch, kann auch diese Data Week und das, was alles dahinter steht, was auch zwischen den Data Week Terminen jeweils stattfindet, zeigen. Zahlreiche Akteure aus Wirtschaft, Wissenschaft und Verwaltung engagieren sich heute in den unterschiedlichsten Bereichen der Digitalisierung, ob es in der Stadtentwicklung ist oder Gesundheitsforschung oder in der Mobilität, im Bildungswesen. Da gibt es weitere Beispiele. Und die Vielzahl von Landes-, Bundes-, EU-geförderten Projekten, also auf allen Ebenen, zeugt letztendlich von der Vielfalt und der Relevanz dieses Engagements. Also das ist nicht etwas, was sich irgendjemand im Kämmerchen überlegt hat und sonst niemand interessiert, sondern es wird von allen Seiten gewünscht, anerkannt, mit Geld versehen und mit Interesse versehen. Danke, dass Sie da sind. Als Universität Leipzig bringen wir uns in diese Prozesse mit unserer gesamten fachlichen Breite ein. Mit fundierter Expertise in der künstlichen Intelligenz, in den Datenwissenschaften, in Digital Humanities, aber auch mit ethischer und gesellschaftlicher Reflexion, Stichwort Geisteswissenschaften, die irgendwo mit dabei sind. Und deshalb liegt für uns ein besonderer Fokus auf der Bildung und der Förderung des wissenschaftlichen Nachwuchses, aber man könnte auch etwas treffender sagen, der Wissenschaftlerinnen und Wissenschaftler in frühen Karrierestufen. Nachwuchs klingt so, als seien die irgendwie noch nicht ganz volljährig. Also diejenigen, und ich zähle im Grunde genommen, ganz genau genommen, zähle ich eigentlich den Student, die Studentin im ersten Semester dazu. Das ist ja der oder die zukünftige Wissenschaftlerin und Wissenschaftler im Bereich Data Science oder in anderen Bereichen. Die sind ebenfalls in unserem Fokus. Und deshalb wollen wir auch, dass Studierende aktiv in die Data Week sich einbringen und deswegen sind sie dort einzubinden, als Teilnehmende, als Mitgestaltende, als Diskutierende mit ihren kritischen Stimmen, mit ihren kritischen Fragen. All das ist, denke ich, eine gute Ressource, um das Paket rund zu machen. Die Ausbildung in Datenkompetenz ist heute unverzichtbar. Nicht nur für Informatikerinnen und Informatiker, sondern für alle Fachrichtungen. Ich glaube, da keine Disziplin kommt ohne Datenkompetenz aus. Also Data Literacy muss letztlich eine Grundlage sein. Die Universität übernimmt hier Verantwortung für die Qualifizierung junger Talente und für den Transfer von Wissen in die Praxis. Ich könnte Ihnen jetzt Zahlen nennen, wie viele Absolventen wir haben, wie viele Erstsemester jeweils in der Informatik. Ich glaube, da kommt ständig neuer Nachschub an jungen Talenten hier in diese Community. Das Spektrum reicht, wenn wir uns Studiengänge anschauen, vom Informatik-Lehramt, auch wichtig, damit die Kids in der Schule ebenfalls in Berührung kommen. Also von Informatik-Lehramt über Bioinformatik, über Digital Humanities, hatte ich schon genannt, bis hin zum forschungsorientierten Masterstudiengang Data Science. Alle mit einer starken Verbindung zu aktuellen wissenschaftlichen Fragestellungen, also sozusagen am Puls der wissenschaftlichen Forschung, der aktuellen Forschung und aber auch mit praxisorientierter Methodenausbildung. Das ist wichtig, wie zum Beispiel, möchte ich auch besonders hervorheben, den neuen Masterstudiengang Earth System Data Science und Remote Sensing. Zudem ist die akademische Weiterbildung natürlich noch ein Thema. Sie ist letztlich ein zentraler Pfeiler für verantwortungsvolle, reflektierte KI-Forschung und Anwendung. Und Sie wissen es, Daten sind heute nicht nur, wir haben es vorhin schon gehört, technische Objekte oder irgendwie was Technisches, was alle anderen, die nicht technisch unterwegs sind, nicht interessieren, sondern sie sind die Schlüsselressource für wissenschaftliche Erkenntnisse, für insgesamt gesellschaftlichen Fortschritt. Daten als das Öl des 21. Jahrhunderts zu bezeichnen, ist doch eigentlich schon ein Gemeinplatz, oder? Daten helfen uns, komplexe Zusammenhänge zu verstehen, fundierte Entscheidungen zu treffen, also evidenzbasierte, datenbasierte Entscheidungen zu treffen und daraus zukunftsfähige Lösungen zu entwickeln. Das ist, glaube ich, insgesamt ein Allgemeinplatz, muss es auch sein. Die großen Fragen unserer Zeit, ob Gesundheit, Mobilität, Klimawandel oder Bildung, lassen sich nicht im Alleingang lösen. Es braucht hier insgesamt darüber hinaus gemeinsame Anstrengungen, Kooperation. Alleine können wir das nicht mehr. Wir können auch nicht aus einer Disziplin heraus diese Fragen lösen, sondern immer nur aus dem Konzert der vielen Stimmen, der vielen Disziplinen, der vielen Expertisen. Und wir sehen, wie fruchtbar solche Kooperationen sein können, sei es in gemeinsamen Projekten mit regionalen Unternehmen, in Verbünden wie SCATS AI Leipzig, in einem der 5 Kompetenzzentren für künstliche Intelligenz, fest verankert an unserer Universität. Und Ergebnis wie auch Grundlage für weitere Kooperationen ist zum Beispiel auch das entstehende KI-Rechenzentrum. Wir nennen es liebevoll Kürzel. Ein gemeinschaftliches Großprojekt mit dem Universitätsrechenzentrum. Dieses Rechenzentrum wird nicht nur den universitätsinternen Projekten dienen, klar, dafür wollen wir es auch, sondern es ist ausdrücklich als Ressource gedacht für die Region, für Forschung, für Transfer, für Innovation mit hohen Rechenkapazitäten. Das ist ja sozusagen der Knackpunkt. Wir brauchen die Compute Power, und zwar eine große. Die Verbesserung datenwissenschaftlicher Infrastruktur ist deshalb das Thema. Und das ist ein besonderer Beitrag, wie ich meine, ein sichtbarer Beitrag des Kürzel, auch für den Strukturwandel der Region, nicht nur für die wissenschaftliche Expertise. Und ich gebe noch ein weiteres herausragendes Beispiel für disziplinenübergreifende, datengetriebene Forschung, und das ist das Projekt KI-MED, das KI-gestützte Netzwerk zur personalisierten Medizin am Universitätsklinikum Leipzig. Hier zeigt sich, wie man Daten ganz konkret zum Nutzen von Patientinnen und Patienten einsetzen kann, in Form einer personalisierten Medizin. Also ich meine, das ist ein Leuchtturmprojekt, das medizinische Forschung, klinische Praxis und letztlich Datenwissenschaft in beispielhafter Weise verbindet. Und natürlich kann ich heute kein Grußwort halten, ohne von unserem eingeworbenen Exzellenzcluster LICAM, Leipzig Center of Metabolism, zu sprechen, das im Bereich der Zivilisationskrankheiten und Medizinforschung einzigartig, es gibt andere medizinische Cluster, ja, in Deutschland, aber das ist eins, das einzigartig verknüpft ist mit der klinischen Praxis. So gibt es das nirgendwo in Deutschland. Und es ist mit den Datenwissenschaften kombiniert. Da sind wir sehr happy, dass das im nächsten Jahr ab 1.1.26 startet. Und ich denke, es wird auch einen großen Impuls für Leipzig und die Wissenschaftsregionen hier in Mitteldeutschland und Sachsen haben. Ja, meine sehr geehrten Damen und Herren, es ist eigentlich schon zu lang für ein Grußwort, richtig? Kommen wir so langsam zum Ende. Alle diese Projekte und weitere Projekte, die ich jetzt nicht aufzähle, unterstreichen es. Leipzig ist ein Ort, an dem datengetriebene Forschung nicht nur in Sonntagsreden gedacht oder imaginiert wird, sondern hier wird es wirklich gelebt. Hier findet das statt. Ein Ort, an dem diese datengetriebene Forschung umgesetzt wird, jeden Tag. Interdisziplinär, kooperativ und anwendungsorientiert. Wir wollen diese Stärke weiter ausbauen durch strategische Partnerschaften, durch gezielte Förderung der Wissenschaftlerinnen und Wissenschaftler in jungen Karrierephasen und durch Investitionen in Infrastruktur. An der Stelle freuen wir uns, wenn, liebe Frau Dr. Mahecha, Sie sind als Landtagsmitglied, spreche ich Sie jetzt einfach auch an, freuen wir uns, wenn der Freistaat weiterhin investiert in diese Forschung. Und ich sehe Nicken, wenn ich Richtung Organisatoren schaue hier, aber wir brauchen das weiter. Wir können nicht das, was so wunderbar wächst und gedeiht, dann über Sparpläne kaputt sparen. Steht nicht in meinem Grußwort hier, konnte ich mir nicht auf die Zunge beißen, um es nicht zu sagen. So, also wir brauchen da weiter Investitionen. Und wir stärken dieses Thema durch Dialogformate wie diese Data Science Data Week und ich wünsche Ihnen eine ertragreiche Diskussion. Nehmen Sie viele, sei es aus dem Speed Dating oder aus den Vorträgen hier und den Keynotes und den Gesprächen in der Kaffeepause, nehmen Sie viel für Ihre Arbeit mit und ich freue mich, wenn wir an der Stelle jedes Jahr weiter zusammenwachsen. Vielen Dank.
Vielen Dank für diese Grußworte. Und ich würde sagen, wir starten direkt durch. Er kommt schon nach vorn, ganz schnell. Du bist total bereit, das freut mich sehr. Wir befinden uns in einer Zeit, wo wir unglaublich viele Daten zur Verfügung haben und, by the way, auch noch eine Klimakrise. Und wie können wir das denn jetzt verbinden, nachhaltige Lösungen zu entwickeln und die Datenmengen dafür zu nutzen? Und ich freue mich sehr, dass Professor Dr. Miguel Mahecha, habe ich das richtig gesagt? Nein. Wie sagt man es richtig?
Mahecha.
Ich habe extra ChatGPT gestern benutzt, meine Damen und Herren, und die KI hat mich im Stich gelassen. Verdammt. Ich wünsche uns einen wertvollen Input. Viel Freude.
Vielen Dank. Die KI hat deswegen versagt, weil der Name ist so selten, dass die KI das nicht lernen kann. Und zu diesem Punkt komme ich auch später nochmal. KI braucht viele Daten und in bestimmten Bereichen, zum Beispiel Klimaextremen, haben wir nicht genug Daten, um wirklich lernen zu können. Und das gleiche Problem ist Ihnen auch mit meinem Namen gestern passiert. Also, ja, herzlich willkommen, ganz herzlichen Dank, dass ich hier sprechen darf zu unserer Forschung. Es geht um Umwelt- und Erdsystemforschung. Ich habe es jetzt auf Deutsch vorbereitet, aber mit der Übersetzung hoffe ich, dass es auch für alle in Ordnung ist. Die Arbeit, die ich hier zeigen werde, kommt nicht nur von mir, sondern auch von vielen Studierenden und von vielen Doktoranden und Doktorandinnen. Die werden dann jeweils auch gezeigt, aber das wollte ich nochmal vorab betonen. Wichtig ist mir auch zu sagen, alle Forschung, die wir hier machen, machen wir eigentlich im Verbund. Zum Beispiel mit dem Deutschen Zentrum für integrative Biodiversitätsforschung, dem IDIF, dem Zentrum für skalierbare Datenanalytik und KI, dem SCATS AI und dem Zentrum für Umweltforschung, dem OFZ. Gut. Die Frau Rektorin hat es am Anfang schon gesagt, es geht ja hier auch darum, dass wir eine neue Generation von Studierenden entwickeln. Und das wollte ich am Anfang schon als Teaser auch hier noch in den Raum werfen. Wir haben auch einen neuen Masterstudiengang in der Universität Leipzig etabliert, Earth System Data Science and Remote Sensing, in dem es darum geht, Umweltprobleme zu erforschen, zu bearbeiten oder Leute auszubilden, damit umzugehen, die verschiedenen Hintergrund haben können, wie Sie hier sehen. Das ist so der typische Hintergrund eines Bewerberjahres und Sie sehen auch die Internationalität, die wir hier reinbringen. Und die Idee ist hier, dass wir Personen, die ausgebildet sind oder grundständig ausgebildet sind, zum Beispiel in der Informatik, mit Personen zusammenbringen, die zum Beispiel in der Ökologie ausgebildet sind oder anderen Umweltwissenschaften, um gemeinsam eine neue Art der Forschung betreiben zu können in der Zukunft. Nämlich vorbereitet zu sein, fachlich, aber auch sozusagen von der Methodik her, um Umweltprobleme lösen zu können. Und das Programm kommt sehr gut an, wir sind mehrfach überzeichnet und macht wahnsinnig Spaß. Und ich möchte eigentlich auch hier alle einladen, das kennenzulernen und uns zu besuchen oder auch vielleicht daran zu denken, welche Praktikumsplätze man Studierenden anbieten kann oder wo man eventuell auch Absolventen rekrutieren kann. Gut, jetzt komme ich zum eigentlichen Thema des Vortrages. Es geht um unser Erdsystem und unsere Umwelt und Sie alle wissen, dass wir hier vor großen Problemen stehen, hier illustriert mit einem Thermometer und diesem Pflaster, was andere Probleme darstellt. Das Ganze ist sehr dramatisch, aber es gibt einen Vorteil, und zwar, dass dieses Erdsystem von vielen Sensoren durchgehend beobachtet wird. Und die Frage ist, was können wir eigentlich aus dieser Sensorik heraus lernen, was können wir mit KI-Methoden machen, um das Problem, vor dem wir stehen, besser zu verstehen und vielleicht auch Handlungsempfehlungen ableiten zu können. Darum soll es heute gehen. Dennoch, ich nehme mir die ersten 5 Minuten Zeit, um ein bisschen auf die Probleme hinzuweisen, die wir haben. Ein Begriff, der immer wieder fällt hier, ist, wir sprechen hier von der Great Acceleration, der großen Beschleunigung, getrieben durch die menschliche Expansion, die Erhöhung unserer Wirtschaftskraft. Das sind alles sozusagen menschengemachte Veränderungen, die dazu führen, dass wir die Parameter, die das Erdsystem treiben, ändern. Und mit Parametern meine ich sowas wie die CO2-Konzentration in der Atmosphäre oder andere Treibhausgase. Oder zum Beispiel auch den Zustand der Ozeane oder die Transformation der Erdoberfläche. Das sind alles Folgewirkungen, die man direkt darauf zurückführen kann. Wenn das jetzt nur eine Änderung des Systems wäre, wäre es vielleicht in Ordnung. Das Problem ist, dass alle davon abgeleiteten Größen davon einfach beeinflusst sind und der vielleicht bekannteste Effekt ist sicherlich der Klimawandel. Und Sie alle kennen das 1,5 Grad Ziel. Letztes Jahr war 1,5 Grad über der Referenzperiode. Aber das ist ein globaler Mittelwert, den wir eigentlich versuchen einzuhalten, um noch eine lebenswerte Zukunft zu haben. De facto bedeutet das auch, dass zum Beispiel unsere Landsysteme sehr viel mehr sich erwärmen als unsere Ozeane. Also das hat mit der Pufferkapazität der Ozeane zusammen. Also wenn wir diese globalen Mitteltemperaturen mal aufteilen in Land und Ozean, dann sehen wir, dass wir über Land schon Temperaturerhöhungen im Mittel weit über die 2 Grad haben, aktuell. Und dieser Trend setzt sich im Moment eigentlich ungebremst fort. In Deutschland ist der Erwärmungstrend sogar noch stärker. Das liegt an der Kontinentallage, die wir haben. Stärker als der globale Mittel. Das kann man hier sehen aus dieser Darstellung des Deutschen Wetterdienstes. Also unser Trend hier, der ist schon noch etwas stärker. Und auch hier könnte man sagen, 1,5 Grad, 2 Grad, 3 Grad im Mittel ist jetzt irgendwie nicht so dramatisch. Aber das Problem ist, dass das sozusagen auch wieder nur ein jährliches Mittel ist und sich nicht auf die Varianz bezieht. Ja. Die Variabilität nimmt auch zu, das heißt auch unsere Klimaextreme nehmen hier zu. Ein Effekt ist zum Beispiel, dass Dürren verstärkt auftreten und Sie sehen hier den Dürremonitor des UFZ, unseres Partners, und einfach mal eine Karte von Deutschland von 1952 bis heute jeweils dargestellt mit der Intensität der jährlichen Dürre. Und wir sehen einfach eine sehr starke Häufung in den letzten Jahren. Und das ist eben ein Trend, den wir auch in Klimamodellen sehen und den wir auch global beobachten können. Das Phänomen hier dargestellt für Dürren können Sie auch für Hitzewellen und andere Klimaextreme, wie zum Beispiel Starkniederschläge, beobachten. Auch wenn wir uns speziell in diesen Ereignissen genauer umgucken, also jedes Ereignis ist im Prinzip so eine Anomalie in unserem Klimasystem, das sehen Sie mal hier dargestellt. Also stellen Sie sich vor, Sie gucken auf die Erde wie auf so einen Film, das zeige ich Ihnen gleich auch nochmal als Film wirklich, dann hat man so ein Video und da drin passieren Anomalien der Temperatur. Das ist hier dargestellt. Das sind so wie, ja, was man vielleicht als Tumor bei einem Gehirnskern sehen würde. Und wir können die Größe dieser Anomalien quantifizieren und dann einen Trend darüber legen. Und wir sehen hier auch, der ist absolut eindeutig, da gibt es nichts zu deuten, der nimmt einfach zu. Das heißt, wir müssen uns darauf einstellen, dass das wahrscheinlich auch in Zukunft so bleibt. Die Frage ist eigentlich, was bedeutet das für uns? Und die Sorge, die uns umtreibt als Umweltwissenschaftler, ist, dass viele davon abhängige Systeme darunter leiden oder damit umgehen müssen. Und ein Ökosystem, was in Deutschland besonders relevant ist, ist der Wald. 30% unserer Oberfläche wird von Wald bedeckt und viele von unseren auch wirtschaftlichen Aktivitäten sind in gewisser Weise davon abhängig. Und der Waldzustandsbericht von 23 zeigt zum Beispiel ganz klar, dass alle weit verbreiteten Arten hohe Schadensmuster aufzeichnen. Jeder 4. Baum ist anscheinend krank. Das sind Inventuren, die von klassischen Förstern eigentlich erhoben werden und dann zusammengetragen werden. Auf europäischer Ebene zeichnet sich das Bild nochmal ähnlich ab. Es gibt hier eine Studie, die in Nature rauskommen wird die nächsten Tage, wo mal die Daten zusammengetragen wurden über die Kapazität der Wälder, CO2 zu speichern. Und hier zeigt man in verschiedenen Zeitschienen, dass die Kapazität einfach beständig abnimmt über die letzten Jahre, wo man Inventuren gemacht hat. Das heißt, die Möglichkeit, dass CO2, was wir emittiert haben, in der Atmosphäre von Wäldern wieder aufgenommen wird und gespeichert wird, diese Fähigkeit von Wäldern, die geht langsam runter. Das ist insofern ein Problem, weil auch auf EU-Ebene, dort ist sogar die Waldbedeckung höher als in Deutschland, 40%, wird die Kohlenstoffsenke des Waldes mit eingerechnet in alle unsere Projektionen und Zielvorstellungen. Also die Idee ist ja, dass Europa klimaneutral werden will, aber in dieser Rechnung mit den aktuellen Szenarien sozusagen ist mit einberechnet, dass der Wald eine bedeutende Kohlenstoffsenke ist. Und wir können zumindest aus den aktuellen Zahlen sagen, dass der deutsche Wald für diese Funktion zum Beispiel ausfällt. Ja, und das stellt natürlich auch die entsprechenden politischen Ziele so ein bisschen in Frage, ob die noch zu halten sind oder ob wir vielleicht anders agieren müssen an dieser Stelle. Dieses Problem ist weltweit von Relevanz. Also wir beobachten das in Deutschland ganz stark, aber eben auch an anderen Standorten. Es gibt hier eine Metastudie von Herrn Hartmann, der gezeigt hat, dass verschiedene Studien immer wieder zum gleichen Punkt kommen. Die Mortalität der Bäume ist überproportional hoch, überall, wo Studien der Art gemacht wurden. So, das ist letztendlich eine Konsequenz der Trockenheiten, die dazu auch führt, dass Bäume anfälliger sind vor Schädlinge, Borkenkäfer in Deutschland ein großes Problem. Wir haben auch das Problem, dass viele von diesen Trockenheiten zum Beispiel in Sequenz aufgetreten sind. Das hatte ich ja vorhin gezeigt im Dürremonitor. Das heißt, die Natur hat auch keine Möglichkeit, sich zu regenerieren nach so einem Extremereignis, sondern geht sozusagen immer geschwächt ins nächste Jahr und hat dann ein Problem. Aber das alles ist nur mit Klima erklärt bisher. Ein anderer Trend, den wir hier sehen, ist, dass wir auch eine gewisse Homogenisierung unserer Umwelt haben. Das bedeutet auch einen Verlust der Biodiversität. Und wie wirkt sich Biodiversität auf die Kapazität von Ökosystemen, Klimaextremen zu widerstehen? Ich habe das mal hier in so einem kleinen Cartoon dargestellt. Wir haben hier unten eine Monokultur und oben einen relativ diversen Mischwald. Das gelbe, orange Bild im Hintergrund soll darstellen, dass wir hier eine Hitzewelle und Dürreereignis haben. Und diese Linie hier zeigt die Nettoprimärproduktion, also wie viel CO2 geht dann tatsächlich da rein. Und wir sehen hier, dass in einer Monokultur kann es sein, dass wir am Anfang vielleicht ein produktiveres System haben. Wenn aber genau diese Art sensibel auf dieses Klimaextrem reagiert und darunter leidet, dann nimmt diese Produktivität natürlich ab. Und die Regeneration ist schwierig, weil die Mortalität zunimmt. Wenn wir nun viele Arten haben, in denen einige sensibel reagieren und andere relativ resistent sind, dann ist vielleicht initial die Produktivität nicht so hoch, aber auch die Erholungsrate ist höher. Das macht diesen Wald einfach stabiler. Das ist der gleiche Grund, warum Sie, wenn Sie als Privatinvestor Ihr Geld anlegen wollen, eher einen ETF kaufen, der breit gestreut ist. Ja, dann verdienen Sie vielleicht nicht so viel, aber Sie sind auch relativ krisenfest. In der Natur ist es genau das gleiche Prinzip. Was daran immer vergessen wird, Diversität hier ist gedacht, wie puffert das eigentlich den Impact ab. Aber ein anderer Effekt ist der, dass es auch eine Rückkopplung gibt. Ein Wald, der seine Vitalität verliert, seine Produktivität verliert, hat auch weniger Verdunstungsleistung. Und Verdunstung führt zum Kühlen der Umgebung. Wir nennen das eine Transformation der Energieflüsse der Oberfläche. Also es wird in dem Fall weniger latente Wärme erzeugt. Das heißt, die Umgebung erwärmt sich stärker. Das heißt, es kann sogar dazu führen, dass ein sterbender Wald eine Hitzewelle verstärkt. Das sind so Feedback-Mechanismen, die man auch mit bedenken muss, die auch zeigen, dass diese verschiedenen Krisen, die wir derzeitig haben, Hand in Hand gehen. Also es ist eigentlich relativ gut, die auch gemeinsam zu denken und gemeinsame Schutzkonzepte zu entwickeln. Dass wir mit dieser Einschätzung nicht alleine stehen, möchte ich an dieser Folie noch zeigen. Das World Economic Forum gibt jedes Jahr einen Report raus über die weltweiten Risiken, wie sie die eben von Experten einschätzen, und zwar auf verschiedenen Zeithorizonten. Und auf diesen 10-Jahres-Zeithorizont wird für eine gesamtgesellschaftliche Resilienz als größtes Risiko die Zunahme der extremen Wetterereignisse dargestellt und als zweites der Verlust von Biodiversität. Das heißt, wir sehen hier, dass selbst unter, ich würde mal sagen, vielleicht eher konservativeren Kreisen die Frage, welches Risiko wir hier in den Umweltbereich haben, extrem ernst genommen wird und zumindest auf langen Skalen Beachtung findet. Soweit zum Hintergrund. Die Frage ist nun, wie können wir damit umgehen, was können wir machen als Umweltforscher und Umweltforscherinnen? Und neue Sensorik, neue KI und Data Science geben in der Tat wenigstens Lösungen dafür, das Problem besser zu quantifizieren. Sie sehen hier zum Beispiel ein Bild von der ESA, ein Video von der ESA, wie die neuen Wächter-Satelliten, die Sentinels, das Erdsystem beständig monitoren. Und das sind so unsere Standard-Tools, die wir auch benutzen. Und ich möchte Ihnen so ein bisschen zeigen, was wir damit machen, wie wir damit versuchen, weiterzukommen. Die neuen Möglichkeiten, die wir haben, die liegen darin, dass wir, wie gesagt, das Erdsystem aus verschiedenen Sensoren beobachten können. Aber das bedeutet auch, dass wir verschiedene Skalen abdecken können. Ja, das ist der Satellit, der grob misst, aber global. Wir haben Flugzeuge und Drohnen, die relativ hoch aufgelöste Daten messen, aber meistens nicht die gleiche Deckung haben und auch nicht die gleiche Wiederkehrrate. Wir haben Sensoren in verschiedenen Ökosystemen. Wir haben aber auch Citizen Sciences, also Personen, die sozusagen über zum Beispiel Handy-Applikationen bestimmte Daten erfassen und diese zur Verfügung stellen. Die Frage ist, wie bringen wir diese ganzen Daten zusammen? Wie können wir diese Daten gemeinsam nutzen? Was wir alles sehen können, auf globaler Ebene möchte ich in diesem Video zeigen, was wir gemeinsam mit der Europäischen Raumfahrtagentur vor einigen Jahren erzeugt haben. Und das ist Folgendes. Wir sehen einen Film der Erde und Sie sehen jetzt, dass wir verschiedene Satelliten haben, die gemeinsam mit Basisstationen Datenprodukte generieren können, um verschiedene Prozesse zu beobachten. Zum Beispiel Bodenfeuchte, Primärproduktion, Niederschlag, der Anteil der Wolken, also auch Daten, die Sie teilweise aus der Wettervorhersage kennen. Aber die Zusammenschau dieser Daten, die ist es eigentlich, die es uns erlaubt, nahezu in Echtzeit einen Eindruck des Erdsystems als Ganzes immer wieder zu bekommen. Was wir hier in Leipzig machen mit unseren verschiedenen Kooperationspartnern, ist diese Daten auch zueinander sprechen zu lassen. Weil das Problem ist, dass jeder von diesen Datenströmen für sich alleine steht. Aber viele kommen in verschiedenen Formaten, sind an unterschiedlichen Orten gespeichert, sie sind nicht synchronisiert. Und ein Ansatz, den wir hier verfolgen, ist der sogenannte Data Cube Approach, wo wir zumindest gleiche grundlegende Grids haben, auf denen die gleichen Auflösungen in Raum und Zeit zur Verfügung stehen, sodass es ganz einfach ist, mit diesen Daten umzugehen. Wo es eben auch darum geht, dass diese Daten, deren Größe natürlich sehr, sehr groß ist, in der Cloud zur Verfügung stehen, sodass man auch nicht mal das gesamte Portfolio runterladen muss, wie man das früher mal gedacht hat, sondern on the fly analysieren kann. Und dann ist es eben ganz wichtig, dass wir hier immer die zeitliche Dynamik im Blick behalten und nicht nur die Karten. Also das geht weg über die klassischen Geoinformationssysteme, wo man sehr statisch denkt, sondern es geht immer darum, Trends und Anomalien in Raum und Zeit zu erfassen. Nochmal ganz schön, ich finde, ich lasse es mal kurz laufen, weil mich das selber so gut gefällt. Was wir jetzt mal machen, ist, wir nehmen ein paar von diesen Variablen heraus. Das sind 4 Stück, die wir relevant halten, um ein Klimaextrem zu beschreiben. Das wird man jetzt sehen. Also Sie sehen jetzt praktisch die Filme sozusagen als Flächen hintereinander. Jetzt nehmen wir Primärproduktion, ein Wärmestrom, Verdunstung und die Oberflächentemperatur der Landschaft und transformieren jeden von diesen Data Cubes in eine sogenannte Anomalie. Das ist ein Wert, der die Abweichung von dem Erwartungswert darstellt. Ja, also rot ist negativ und blau ist positiv. Und dann, für die Experten unter Ihnen, gehen wir über eine Art Dimensionsreduktion im latenten Raum dazu, die gemeinsame Anomalie zu detektieren und versuchen hier diese von mir schon angesprochenen kleinen Tumore in diesem Raumzeitgebilde zu identifizieren und dann auch zu charakterisieren. Sie sehen praktisch hier einen Score von ganz transparent bis ganz dunkelrot, der darstellt, wie anormal ist ein bestimmter Moment in Raum und Zeit. Und dann müssen Sie natürlich einen Schwellenwert finden, der für Sie relevant ist und können diesen Blob charakterisieren. Was Sie jetzt hier gleich sehen, ist eines der größten Extremereignisse, das die nördliche Hemisphäre in den letzten Dekaden gesehen hat, und zwar die russische Hitzewelle 2010. Die zeichnet sich hier oben etwas ab, die eine ganze Menge auch gesellschaftliche Implikationen hatte, von Ernteausfällen, Waldbränden bis hin zu Smogbelastungen und eine dramatisch erhöhte Sterblichkeit auch unter den entsprechenden urbanen Bevölkerungen. Das sind die Ereignisse, mit denen wir meistens arbeiten. Also, unsere Datengrundlage ist gegeben. Allerdings, und das werde ich gleich zeigen, ist die Datengrundlage, obwohl sie so vielfältig erscheint und so groß, doch noch knapp für bestimmte Phänomene. Der zweite Punkt ist, die Daten allein geben erstmal relativ wenig hin, das haben Sie gerade schon gesehen. Sie müssen eine ganze Menge Analytik reinstecken, um daraus wirklich Informationen zu extrahieren, die dann in gesellschaftliches Wissen oder Handeln transformiert werden kann. Und dass dieser Schritt hier relativ komplex ist, das möchte ich eigentlich im restlichen Vortrag kurz zeigen. Wir gehen mal kurz wieder zurück nach Deutschland zum sogenannten Baumsterben 2.0. Und hier würde ich sagen, haben wir zu wenige Daten, um das Problem wirklich exakt zu erfassen. Was wollen wir wissen? Wir wollen wissen, wie viele Bäume sind tatsächlich gestorben, in welchem Jahr. Wo sind genau diese Bäume? Welche Arten sind betroffen? Wie viel weniger CO2 wird auch regional gespeichert? Das sind Fragen, die wir möglichst genau quantifizieren können und daraus zum Beispiel auch Richtlinien für besseres Management in der Zukunft ableiten zu können. Das Problem, was wir haben hier, ist folgendes. Wir wollen eine komplette Abdeckung von Deutschland, besser noch von ganz Europa oder idealerweise der ganzen Welt erreichen. Aber ein Satellit guter Qualität, der heute unsere Wälder beobachtet, der sieht sowas hier. Grüner, weniger grün. Wir sehen 10 Meter Auflösung, wir sehen das alle paar Tage, das ist zwar schön, aber letztendlich, wie viele Bäume da drin tot sind, sehen wir nicht. Hier unten ist ein Drohnenbild, was ich gestern mit meinem Sohn aufgenommen habe. Da sieht man was. 4 Zentimeter Auflösung, ja, da sehen Sie jeden einzelnen Baum. Das ist eine wunderbare Momentaufnahme, aber die ist natürlich nur lokal vorhanden. Sie ist nicht global vorhanden. Und die Frage ist, wie können wir diese Skala überbrücken? Nochmal hier illustriert. Das ist, was ein Satellit vielleicht sehen würde, ungefähr. Und was wir leider nicht haben, weil wir sozusagen aus Drohnenperspektive nur wenige Daten haben. Zum Glück haben wir hier an der Universität Leipzig eine ganze Reihe talentierter junger Studierende und Doktorierende und die arbeiten genau an diesem Problem. Das ist eine Masterarbeit hier von Jakobus Möhring, der sich zum Ziel gemacht hat, erstmal aus den ganzen Drohnendaten jeden einzelnen toten Baum mit einer KI zu detektieren. Und er hat Informatik studiert und ist dann zu unseren Umweltwissenschaften gekommen, um sein Wissen dort anzuwenden und hat extrem gute Ergebnisse geliefert. Mittlerweile können wir auch hier zum Beispiel vor komplexen Hintergründen, zum Beispiel Geröllhalten, sehr gut detektieren, was ein toter Baum eigentlich ist und was nicht. Wir können das zum Beispiel hier auch im Auwald sehen, wo es nicht darum geht, ganze Kronen zu sehen, sondern auch Teile von Kronen, die sterben. Das sogenannte Eschentriebsterben kann man sehr genau erfassen und dann auch das Integral davon ausrechnen, wie viele Bäume sind davon betroffen. Wir können das hier, das ist zum Beispiel der Wald genau hinter meinem Haus, nochmal sehen, wo wir ganz viel Waldsterben haben. Und die Frage ist hier aber nochmal, wie überbrücken wir die Skala? Wie kommen wir von dieser Skala auf eine globale? Der Workflow, den wir hier entwickelt haben, ist folgender. Wir sammeln diese Drohnenaufnahmen. In jeder Drohnenaufnahme wird eine KI angewendet, die exakt die toten Triebe identifiziert. Aus diesem Bild können wir sozusagen ein Grid bilden, was der Auflösung des Satelliten entspricht und den Anteil der gestorbenen Bäume darin quantifizieren. Mit einer weiteren KI können wir aus den Satellitenbildern vorhersagen, was wir eigentlich hier sehen wollen. Also das ist die tatsächliche Messung, das ist die Vorhersage. Ich würde mal sagen, das ist schon ziemlich gut. Klar, da ist noch Verbesserungspotenzial, aber wir sind auf gutem Weg. Und eine erste Studie dazu wurde gemacht von meinem Kollegen Thea Kattenbaum, der bei uns lange Jahre war, der jetzt Professor in Freiburg geworden ist und der den Waldzustandsbericht von Deutschland sozusagen nochmal repliziert hat mit genau so einer Art von Methode. Man kann eben zeigen, dass für den Zeitraum 2018 bis 2021 sogar noch mehr, fast doppelt so viel bestehendes Totholz nachgewiesen werden konnte, wie bodengestützte Inventuren, sprich der Waldzustandsbericht. Ja, also hier sehen wir, dass solche Methoden eventuell Mehrwert haben, weil sie genauere Daten liefern, die man vom Grund auf einfach nicht liefern kann. Und sie sind auch insofern gut, weil sie total objektiviert sind. Also wir können den Fehler exakt bestimmen, den Messfehler. Und wir wissen, dass in jeder Region Deutschlands, unabhängig vom Bundesland, die gleiche Messmethode dann zum Einsatz kommen kann. Wo geht diese Reise hin? Wir wollen diese Idee weiterverfolgen. Wir haben dankenswerterweise wieder jetzt Förderung bekommen von der Europäischen Raumfahrtagentur dafür, vorher auch vom DLR und haben die Fachcommunity aufgerufen, ihre Daten zur Verfügung zu stellen. Auf einer Website der trees.earth kann jeder seine Drohnendaten hochladen und die Reaktion war absolut überwältigend. Jeder, der irgendwie damit arbeitet, lädt einfach seine Daten hoch. Institute haben teilweise ihre komplette Bestände hochgeladen. Wir kommen also in Tausende von Daten. Und die Idee ist, dass wir jetzt jedes einzelne Bild genau nach dieser Pipeline prozessieren, also in jedem von diesem Bild identifizieren, was ist der Anteil von toten Bäumen, um dann 2026 hoffentlich eine Karte aller europäischen toten Bäume zu erstellen und vielleicht 2028 eine weltweite Inventur zu erreichen. Das sind so unsere Hoffnungen, woran wir gerade arbeiten. Wir machen natürlich selber auch mit. Ja, also wir haben hier im Auwald nochmal gemessen, da sieht man, was hier gerade los ist, das sieht nicht gut aus. Sie sehen das übrigens nicht so genau, wenn Sie durch den Wald selber laufen. Ja, selbst wenn Sie nach oben laufen, das Drohnenbild gibt Ihnen oft einen ganz anderen Eindruck. Sie werden geblendet von der grünen Biomasse. Sie übersehen eigentlich den Anteil der toten Sterbe. Da müssen Sie mal drauf achten, wenn Sie das nächste Mal im Wald sind. Gut. Sterblichkeit ist ein Ding. Aber es ist so ein bisschen wie beim Menschen. Ich glaube, für einen Arzt ist es relativ einfach zu entscheiden, ob jemand lebt oder nicht lebt. Aber die Vitalitätsparameter abzuschätzen, ist ein bisschen schwieriger. Was funktioniert das nicht? Und das geht uns mit der Umwelt genauso. Ja, wir können diese Sterblichkeit gut sehen in den Drohnenbildern, aber ob ein Wald einfach nur etwas weniger produktiv ist, ist etwas schwieriger. Das heißt, die Frage ist hier, wie viel mehr oder weniger CO2 wird denn konkret aufgenommen oder abgegeben? Wie viel Wasser wird verdunstet oder nicht? Das sind Parameter, die wir nur an wenigen Stationen messen können. Und hier ist die Frage, wie wir hier in die Fläche kommen. zeige ich Ihnen nochmal hier ein weiteres Video, was wir mit der ESA zusammen gemacht haben. Es geht jetzt also um die Frage, wie die Bruttoprimärproduktion, das ist, jetzt sage ich mal einfach synonym für Photosyntheserate, wie die sich verändert über die Zeit. Und Sie sehen hier eine Animation der weltweiten Photosyntheserate und Sie sehen eine wunderschöne grüne Welle, wie sie sozusagen über den Weltkugel schwappt jedes Jahr und einmal ergrünt und einmal wieder erbleicht. Und das sind genau die Daten, die wir eigentlich verstehen wollen und die wir auch vorhersagen wollen. Die Satellitendaten geben uns da auch nur ein sehr grobes Bild dafür. Sehr viel genauer sind Messungen über den Bestand selber. Also es sind kleine Sensoren, die über den Wald angebracht sind, die beständig diesen CO2-Fluss messen. Und wir haben zum Beispiel einen von diesen Türmen im Nationalpark Hainich stehen, also beziehungsweise die Uni Göttingen betreibt den, aber wir werten den mit aus. Und hier habe ich zum Beispiel die Doktorarbeit von David Montero, aber auch die Studentin Anna von Blon, die dort arbeiten. Und sie versuchen zu verstehen, wie sich diese Vitalitätsparameter, die wir hier in grauen Punkten messen können, verändern, während wir ein Klimaextrem haben. Sie sehen hier in rosa eingezeichnet die Ereignisse, die wir als besonders extrem eingeordnet haben. Hier ist der Hainichwald. Und Sie sehen hier diese Kurve, die sehr schön ist, die bricht im Jahr 2018 dramatisch ein. Also die Spitze ist weniger hoch und es geht rapide runter, ja, versus die anderen Jahre, die normal sind. Und wir wollen jetzt dieses Ereignis eigentlich vorhersagen. Und die Methoden, mit denen wir arbeiten, sind die gleichen Methoden, die Sie aus ChatGPT und so weiter kennen, nur angewendet auf solche Probleme, wo wir statt Wörter Zeit reinlernen. Statt einer Sequenz von Buchstaben wird jetzt eine Sequenz von Zahlenwerten gelernt und auf die Zukunft angewendet. Und Sie sehen, ja, da gibt es noch was zu tun und wir arbeiten hart daran, das besser zu machen, aber im Grunde sind wir gar nicht so schlecht. Das funktioniert ganz gut für einzige Standorte, aber wenn wir zu wenige Trainingsdaten haben, dann geht das immer schief. Und das ist unser Problem. Ja, bei langen Zeitreihen okay, aber für Orte, die wir noch nicht gesehen haben, funktioniert das nicht. Und da arbeiten wir auch daran. Wir versuchen, neue Daten zu generieren in hoher Auflösung an Orten, wo Extremereignisse stattgefunden haben in der Vergangenheit. Auch hier hatten wir ein schönes Projekt mit der Europäischen Raumfahrtagentur und vor allem Chao Nanchi hat da sehr hart dran gearbeitet. Was wir hier machen, ist, dass wir aus globalen Daten immer dort, wo ein Extremereignis von diesem, Sie erinnern sich, die Tumore stattgefunden haben, reingucken und mit möglichst hoch aufgelösten Satelliten kleine Data Cubes raussammeln und diese dann speziell in eine Datenbank packen, auf denen wir dann KI trainieren können, um eine bessere Vorhersage von der Produktivität zu erreichen. Okay, das ist so ein bisschen unsere Arbeit. Sie sehen, also wir haben hier ein Problem, weil wir für manche Phänomene zu wenige Daten haben und deswegen die Fachcommunity brauchen, um unsere Datensätze anzureichern. Sie sehen auch, es ist sehr schwierig zu lernen, wenn die Ereignisse extrem sind und nur selten vorkommen, weswegen wir alle möglichen Tricks anwenden, um diese Datenmengen zu erhöhen. Und jetzt möchte ich noch ein weiteres Punkt darstellen und da geht auch in Richtung, was Sie gesagt haben, am Ende müssen wir interdisziplinär arbeiten, sonst funktioniert gar nichts. Und das ist das Desaster, was wir an der Oder gesehen haben vor 3 Jahren. Sie erinnern sich vielleicht, aus Radio oder Fernsehen wurde ein massives Fischsterben berichtet. Mitten in den Sommerferien. Ich war da gerade zufällig in Polen, um Ferien zu machen und habe diese Nachricht gehalten, bin natürlich hingefahren, habe mir das angeschaut, es war wirklich dramatisch. Und der Punkt war da, zu diesem Zeitpunkt wusste niemand genau, was los ist. Also es war relativ unklar, wo das herkam in den ersten paar Tagen danach. Wir haben uns dann zusammengetan mit tatsächlich Freundinnen, Leute, die wir kannten, Bekannten, um zu gucken, was wir machen konnten, weil die Idee war, wenn es tatsächlich, und das war der erste Verdacht, mit einer Algenblüte zusammenhängt, dann können wir es vielleicht aus dem Raumfahrt oder aus Satellitendaten ableiten. Wir haben da auch hier mit einer Firma zusammengearbeitet, Brockmann Consult, mit denen wir sowieso ganz viele Projekte zusammen machen. Und an der Stelle haben alle unbezahlt mitgearbeitet, um dieses Problem zu lösen. Und das war das erste Bild, was dann auch tatsächlich in der Zeit und so weiter veröffentlicht wurde, weil es so noch nicht dargegeben war. Wir sehen hier ein Bild dieses Flussverlaufs aus den Sentinel-2-Daten, den sogenannten Wächter-Satelliten, von denen ich vorher dieses Umlaufbild gezeigt hatte. Und Sie sehen hier farbkodiert den Chlorophyllanteil, wie wir den abschätzen aus diesen Daten. Wichtig ist, die Abschätzung, der Satellit zieht kein Chlorophyll, da ist auch eine KI dahinter, so eine Art neuronales Netz, die lernt, wie man die spektrale Information in Chlorophyll übersetzt. Und Sie sehen hier, wie diese Algenblüte einsetzt und sich dann einmal den gesamten Flussverlauf herunterschlängelt. Ich fand das ziemlich beeindruckend, das ist nochmal ein anderes Bild von einer von dem gleichen Phänomen, also wie das dann zeitlich sich diese Welle eben aufbaut, konnten wir hier ganz schön zeigen. Und am Ende konnten wir dann aufklären in der Zusammenarbeit, was die Ursachen tatsächlich waren. Ja, also es war eine Hitzewelle, die dazu geführt hat, dass wir grundsätzlich einen niedrigen Wasserspiegel haben, dadurch reduzierte Fließgeschwindigkeiten, erhöhtere Temperaturen, bei konstanter Einleitung von Verschmutzung, Salzen letztendlich, die zu einer erhöhten Salzkonzentration geführt haben, die das Wachstum begünstigt hat. Am Anfang gab es ja auch dieses große Fingerzeig, wer ist eigentlich schuld hier? Aber es war einfach der Zusammenfluss verschiedener ungünstiger Ereignisse, die dann zu dieser Katastrophe geführt haben. Und das größte Problem, was wir eigentlich hatten, um diesen Chart am Ende zu malen, war, dass wir viele Daten am Anfang gar nicht bekommen hatten. Ja, das hat nur funktioniert, weil wir uns alle kannten einigermaßen. Aber über die offiziellen Kanäle, über die Datenrequests hat es nicht funktioniert. Und das ist auch so ein Punkt, den ich hier nochmal machen möchte. Wir leben in einer datenreichen Zeit, aber wir leben auch in der Zeit des Föderalismus, der nach wie vor dazu führt, dass jeder sein eigenes Süppchen kocht und die Daten leider nicht so kuratiert, dass wir alle barrierefrei, instantan darauf zugreifen können, was wir aber in solchen Fällen müssen. Ja, auch die Zusammenarbeit zwischen deutschen und polnischen Behörden sozusagen war okay, aber sozusagen für uns als Forscher nicht brechbar. Wir konnten das nicht einfach abgreifen. An dieser Stelle einfach mein Appell auch in die Diskussion dieser Woche, wie können wir eigentlich Daten wirklich frei, offen und fair machen, auch nachvollziehbar gestalten, sodass, wenn so eine Katastrophe nochmal vorkommt, wir sofort reagieren können. Ja, und nicht 2 Jahre brauchen, bis wir alle Datenquellen zusammen haben. Man stellt sich vor, sowas wäre eine Katastrophe, die wirklich auch viel mehr Menschenleben noch beeinträchtigt hätte. Und uns wären die Hände gebunden, nur weil wir nicht an die Daten rankommen. Undenkbar. Also, interdisziplinäre Forschung ist hier entscheidend, aber Datenverfügbarkeit eben auch. Also, ich komme so ein bisschen langsam zum Ende. Wie sieht unsere Forschung aus? Ich hatte ja diese Wissenspyramide, Datenwissenspyramide mal gezeigt am Anfang. Ich hoffe, ich konnte zeigen, dass das ein bisschen komplexer ist. Denn was wir eigentlich hier in diesem Bereich dazwischen machen müssen, ist eine ganze Menge von detaillierten Arbeitsschritten. Wir müssen uns neue Datenquellen erschließen. Wir müssen die verschiedenen Datenströme koordinieren. Wir müssen analytische Methoden haben, um dieser großen Datenmengen auch Herr zu werden. Wir brauchen Data Science Methoden verschiedener Art, um diese Daten zu interpretieren und dann kombiniert mit Fachwissen sinnvolle Interpretationen erstellen zu können. Wenn wir an diesem Punkt angekommen sind, dann übergeben wir das ganze Wissen der Gesellschaft letztendlich, die daraus ihre Handlungsempfehlungen hoffentlich abzuleiten weiß. Ein letzter Punkt noch. Eine Sache, die uns in letzter Zeit immer mehr umtreibt, ist, dass viele von diesen Diskussionen so ein bisschen abstrakt sind. Wir wissen zwar, was wir meinen, aber oft fehlt uns auch so eine Intuition für die Daten, die wir haben, weil manche von den Daten können wir nicht anschauen. Aber es gibt eine ganze Menge Daten, die schön visualisierbar sind und das hilft sehr viel. Eine Doktorarbeit von Maximilian Zöchting ist folgende, hier initial finanziert von der Nationalen Forschungsdateninfrastruktur und jetzt von der ESA weiterfinanziert, ist die Idee, dass wir solche Datenströme interaktiv erfahrbar machen. Und wenn Sie ein Smartphone dabei haben, dann können Sie kurz auf lexcube.org gehen jetzt und sich einfach mal 1 Terabyte Daten von so einem Satelliten anschauen. Das funktioniert ohne Probleme. Die Idee ist die, dass man diese raumzeitlichen Daten, also die kann man anfassen, die kann man drehen, von oben unten angucken. Sie können sich verschiedenste Satelliten auswählen oder andere Datenprodukte. Und der nächste Schritt, den wir gerade machen in meinem Team, auch von Maximilian Zöchting hier eigentlich mehr oder weniger in Alleinarbeit gemacht, ist, diese Daten auch physikalisch erlebbar zu machen. Also er macht das wirklich komplett alleine. Ich muss mal die Lorbeeren abgeben. Das ist also eine spektakuläre Arbeit. Und was wir gerade in Auftrag von der ESA auch wieder machen, ist Folgendes. Wir bauen einen Data Cube, der physikalisch steht, hier in unserer wunderschönen alten geophysikalischen Bibliothek noch. Der wird aber bald ausgestellt bei der ESA, in der wir sozusagen über Touchscreens so einen ganzen Data Cube anfassen können, in 3D angucken können und dann reinzoomen können und verstehen können, wo zum Beispiel eine Anomalie stattfindet oder nicht. Ja. Und ja, man kann solche Anomalien finden über alle möglichen Outlier-Detection-Methoden oder was auch immer sozusagen, aber man sieht es meistens noch viel schneller. Das ist zum Beispiel eine Anwendung und wir sehen auch Fehler in Daten, die zum Beispiel systematischer Natur sind, sehr viel schneller auf so einer Visualisierung, als wir sie erfassen können. Also wenn zum Beispiel eine leichte Verschiebung in eine Richtung geht, sowas sieht man einfach sofort und das finden wir ganz gut, hier auch in der Zusammenarbeit mit der Informatik, dass wir solche Methoden hier entwickeln können und vielleicht auch erlebbar machen können. Also ich denke auch, das hat einen großen didaktischen Wert, also man kann sich einfach besser vorstellen, was so eine zeitliche Verlauf ist, wenn man mal reinguckt, wo wurde ich eigentlich geboren, wie war eigentlich die Weltkarte und dann kann ich weiter zoomen und so weiter. So, wo geht die Reise hin? Wir wollen mit unseren Methoden versuchen, Muster zu lernen, die wir brauchen, zum Beispiel hier die Anteil der toten Bäume. Aber das Wichtige ist eigentlich, dass wir versuchen, die Skalen, die zwischen verschiedenen Sensoren liegen, zu überwinden und damit eigentlich Aufklärung von Prozessen zu erreichen in viel höheren Auflösungen. Trotz aller Datenverfügbarkeit und den ganzen Hype um Big Data, glaube ich, sehen wir große Datenlücken in der Umweltforschung. Also hier müssen wir die Netzwerke noch ausbauen. Wir müssen Daten freier teilen. Wir müssen den Fair-Daten unbedingt gehorchen. Und diese Daten müssen dann eben auch verfügbar sein. Das ist ein ganz wichtiger Punkt. Wir glauben, dass Daten auch erfahrbar sein müssen, in gewisser Weise für alle. Ja, deswegen nicht nur in irgendwelchen Clouds rumliegen, sondern eben auch anfassbar sein. Deswegen diese Arbeit an der Visualisierung. Und am Ende hoffen wir damit, KI-Anwendungen auch generiert zu haben, die im Zeitalter der Desinformation genau das Gegenteil bewirken, nämlich eine bessere und informiertere Gesellschaft, die versteht, vor welchen Herausforderungen wir gerade stehen. Vielen Dank für die Aufmerksamkeit.
Wow, man sieht, was da für ein kreatives Team dahinter steht. Ganz viele Menschen, die über den Tellerrand schauen und die Probleme von heute angehen, um neue Lösungen zu finden. Vielen, vielen Dank an der Stelle. Und jetzt sind Sie dran, auch Sie, die da online zuschauen und entspannt irgendwie im Bett rumlümmeln. Nee. Sie dürfen auch Fragen stellen, vielleicht das vorab zur Info. Wir haben da so Mikros aufgebaut. Es wäre super, wenn der oder diejenige, der eine Frage hat, direkt ans Mikro geht und dann bitte einmal direkt reinsprechen, damit alle im Stream es auch hören können. Und da steht schon der erste Freiwillige auf. Wir überbrücken den langen Gang. Geschafft. Perfekt.
Guten Morgen erstmal. Vielen Dank für die tollen Bilder und den sehr schönen Vortrag. Ich bin Karatke vom Deutschen Biomasseforschungszentrum. Ich habe eine Frage zu Ihrer Aussage, dass Sie mit Ihrem KI-Produkt Schäden an Baumkronen modelliert haben als Vorhersage. Und Ihre Aussage war dann, die Schäden sind größer als die lokal beobachteten. Sie haben dann die Aussage getroffen, sozusagen Ihr Ergebnis ist das Richtige und die lokalen Beobachtungen sind vermutlich zu gering. Normalerweise würde man ja annehmen, dass ein Modell evaluiert wird durch lokale Beobachtungen und nicht umgekehrt. Wie ist es denn zu der Entscheidung gekommen, was davon der bessere Wert ist?
Ich hoffe, ich habe nicht gesagt, was besser ist. Wenn ich es gesagt habe, dann war das falsch. Also ich habe eigentlich nur gesagt, dass die Methode, die wir haben, die sozusagen automatisiert, die Bäume detektiert, trainiert auf natürlich annotierten Bildern, also da gibt es eine ganz große Trainingsdatenbank, die dann skaliert auf das gesamte Land, dass die einfach zu anderen Ergebnissen kommt als die Inventur, und zwar zu höheren Ergebnissen. So. Ich will jetzt nicht sagen, dass die Bauminventur falsch ist, das stimmt, ja, sondern ich möchte einfach sagen, da gibt es eine Diskrepanz, eine Fehlerrate, die dramatisch ist. Das könnte aber sein, dass die Schäden im Moment in den aktuellen Inventuren unterschätzt sind, wenn wir richtig liegen. Ja, das ist zumindest ein Aufruf, das alles nochmal zu hinterfragen und weiterzugehen.
Okay, die Ursache.
Aber danke für diesen kritischen Hinweis, das ist sehr, sehr sinnvoll.
Vielen Dank.
Vielen Dank. Weitere Fragen? Trauen Sie sich? Wir streamen zwar live, aber trauen Sie sich trotzdem? Gibt es weitere Fragen? Ich habe sonst auch... da, perfekt. Wir müssen mal aufpassen, dass die Kamera frei steht, weil sonst sieht der Stream nicht, wer fragt. So, ich glaube, es funktioniert. Ja.
Vielen Dank für den sehr interessanten Vortrag. Es ging nochmal um das Thema Datenlücken. Wie geht man denn damit um, dass zum Beispiel, wenn wir jetzt Richtung USA schauen, noch viele Forschungsprojekte eingestampft werden und dass man den Datenschatz, der dort ist, irgendwie auch sichert? Da gab es ja ein paar Vorfälle, gerade auch was Umweltdaten angeht vielleicht. Gibt es da irgendwie eine Strategie oder Erfahrung?
Also Datenlücken ist eigentlich unser tägliches Geschäft schon immer. Einfach deswegen, weil in vielen Regionen der Welt keine Daten verfügbar sind. Also es gibt immer auch das Problem, dass sozusagen die meisten Sensoren der Umweltforschung sind irgendwie in Europa, USA und China zur Verfügung, vielleicht auch noch Indien. Ja, wenn wir auf die südliche Hemisphäre sehen, haben wir schon immer das Problem, dass wir nur wenige Daten haben. Eine Strategie war immer die, dass zum Beispiel Sensoren so aufgebaut werden, dass die möglichst in unterschiedlichen Ökosystemen und Klimaregionen bauen. Auch wenn es wenige Sensoren sind, haben sie wenigstens den Data Space einigermaßen erfasst, sodass dann auch eine Interpolation über Lückenfüllmethoden besser funktioniert. Das mit USA und der derzeitigen Situation ist eine ganz spezielle Herausforderung, vor der wir nicht wissen, was genau passiert. Also wir sind ja so ein bisschen in Kontakt mit den Kollegen. Wir wissen, es gibt alle möglichen Rettungsinitiativen, dass auch Universitäten Datenströme übernehmen. Oft werden die ja auch gespiegelt verfügbar gemacht werden. Es zeichnet sich eine mittlere Katastrophe ab, das ist richtig, wir können die Dimension aber im Moment eigentlich nicht abschätzen.
So ist der Stand, ja. Betrifft viele Bereiche aktuell tatsächlich von den USA ausgehend. Da kommt noch eine. Ja, sehr gut. Ich habe sonst auch ganz viele Fragen auf meinem Zettel. Mal sehen, ob ich die noch stellen kann.
Genau, danke auch nochmal von mir. Im Rahmen der Klimamission für Leipzig sind wir auch dabei zu bilanzieren, die Treibhausgasbilanz der Stadt. Und da ist natürlich eine Frage von den Grünflächen. Wie viel emittiert oder speichern eigentlich die Leipziger Grünflächen? Ist der Auwald in einem heißen Jahr, weil der eigentlich speichert, dann eine Quelle oder nicht? Und auch natürlich die Bäume. Können Sie das jetzt auf einer jährlichen Basis eigentlich sagen? Können Sie da mit Ihren Daten eine Bilanz machen? Können wir Sie da fragen?
Also wenn man eine konkrete Bilanz machen will, exakt über den CO2-Speicherkapazität eines Systems, dann braucht man eigentlich an diesem Standort einen bestimmten Sensor, der genau den Austausch von CO2 nach oben und unten alle halbe Stunde misst. Dann könnte man das. So einen Sensor gibt es in Leipzig im Auwald tatsächlich nicht. Sozusagen. Was man machen kann, ist, dass man über Datenprodukte, die an anderen Standorten trainiert sind, mit den Satellitendaten vor Ort eine Abschätzung macht. Das geht schon, aber die Ungenauigkeit ist relativ hoch. Was man nicht machen kann, ist, dass man einfach nur über die stehende tote Biomasse dazu kommt, direkt abzuschätzen, wie viel weniger CO2 man aufnimmt und speichert oder nicht, weil das Ganze so ein bisschen funktioniert wie Ihr Konto. Ja, die Frage ist, was Sie einzahlen und auszahlen. Man kann relativ genau sehen, was man einzahlt, also die Photosynthese, Primärproduktion, aber Sie können nicht sehen, was Sie ausgeben, nämlich die CO2-Ausgasung aus Böden und in Totholz. Und das macht es immer so ein bisschen schwierig, das exakt für einen Standort so genau zu sagen.
Okay, danke.
Aktuell keine weiteren Fragen. Doch, da kommt noch eine Frage. So.
Vielen Dank für den spannenden Vortrag. Ich hätte noch eine Frage, die mich umtreibt. Bäume haben ja auch eine natürliche Mortalität. Und wir müssen ja unterscheiden sozusagen zwischen dem natürlichen Prozess des Absterbens und dem Prozess des induzierten Absterbens, der möglicherweise auf ein Extremereignis zurückführt. Wie machen Sie das? Dankeschön.
Genau. Also hier geht es eigentlich, wenn man sich die deutschen Waldinventuren anguckt, sozusagen, dann sieht man einfach einen ganz großen Spike, der 2018 anfängt, der um viele Prozentpunkte höher ist. Letztendlich ist die Idee die, dass wir genau das Gleiche machen, wie was wir bei der Mortalität von Menschen machen, dass wir auf eine Exzessmortalität versuchen zu gehen. Also sagen, was ist die Sterblichkeit, die über der normalen Rate liegt?
Okay, jetzt kommt die erste Frage von mir. In unserer Bevölkerung sind ja viele Menschen, die sich sehr engagieren und sehr interessiert daran sind, Lösungen zu finden für bestehende Probleme. Inwiefern kann man denn die Zivilgesellschaft einbinden durch Apps oder irgendeine andere Art von Möglichkeit, um mehr Daten zu generieren?
Also es gibt wunderbare Apps, die helfen zum Beispiel den Zustand der Biodiversität besser zu erfassen. Ja, eine, mit der wir viel arbeiten, ist Flora Incognita aus Ilmenau und vom Max-Planck-Institut für Biogeochemie in Jena, mit der man zum Beispiel einzelne Pflanzenarten sehr, sehr präzise bestimmen kann, mittlerweile auf der Genauigkeit eines guten Botanikers. Wir benutzen das auch in der Lehre, aber viele Menschen haben diese App einfach aus Neugierde gespeichert und wenn man in den Einstellungen eben seine Daten zur Verfügung stellt, das heißt, also zulässt, dass zum Beispiel der Standort für wissenschaftliche Zwecke ausgewertet wird, dann tragen diese Daten dazu bei, dass wir den Zustand der Biodiversität besser erfassen können. Das ist ein wichtiger Beitrag. Und wir haben zum Beispiel ein Paper von vor 3 Jahren, in dem wir gezeigt haben, dass eine Kartierung der Biodiversität von Deutschland mit solchen Karten natürlich räumlich heterogener ist als eine Inventur, aber durchaus zu den gleichen Ergebnissen kommt. Ja, also wir sehen natürlich dann solche Biases, dass in großen Städten, in Ballungsgebieten sehr viel mehr Datenabdeckung möglich ist als auf dem Land, was die Inventuren natürlich vermeiden, weil das gezielt gemacht wird. Aber trotzdem ist es ein guter Beitrag, einfach auch deswegen, weil über dieses Crowdsourcing wahnsinnig schnell große Flächen erfasst werden. Während eine professionelle Inventur nur alle Dekaden eigentlich vollständig ist, sodass man ganz langsame Änderungen und ganz langsame Trends sieht. Und unsere Hoffnung ist eigentlich die, dass wir über solche Applikationen ganz schnelle Änderungen erfassen können. Auch Änderungen zum Beispiel in der Phänologie, also wann beginnen Pflanzen zu blühen, ja, weil sich diese Blühzeiten auch verschieben durch den Klimawandel.
Der Zeitwert ist natürlich auch ein Einflussfaktor. Und wie lange sind denn für Sie Daten, die Sie generieren, aktuell, um wirklich dann auch erkenntnisreiche Aussagen treffen zu können?
Also bei jeder Art von Trendabschätzung ist der Zeitraum entscheidend, je länger, desto besser. Bei Klimadaten haben wir den Vorteil, dass eigentlich konsistente Messungen seit weit über 100 Jahren jetzt vorliegen. Auch da wird das Messnetz natürlich dichter und besser und die Sensoren genauer. Aber wenn es jetzt genau um die Erfassung des Zustands der Biosphäre geht, dann ist das nicht der Fall. Also wir haben erste Satelliten seit ungefähr 1980 bis heute. Das ist so meine Lebensspanne ungefähr, die man da abdeckt. Aber da gibt es immer wieder Sensoren, die dann erneuert wurden. Das ist keine richtig schöne Zeitreihe. Und das Problem ist, wenn wir das global erfassen möchten, dann brauchen wir eigentlich Satelliten, die konsistent langfristig messen. Ja, und da kommen wir tatsächlich ein bisschen an unsere Grenzen. Da geht es nur über Fusion von verschiedenen Datenströmen und Modelle. Modelle, die kalibriert sind an solchen Daten, die zum Beispiel dann auch die Vergangenheit rekonstruieren, sind ein ganz wichtiges Tool.
Ich gucke nochmal rum, kurz, ob sich noch jemand... Ja, Michael.
Ja, hallo und auch herzlichen Dank von meiner Seite aus für den wirklich tollen Vortrag. Sie haben vor uns einen ganz wichtigen Appell geführt zur Veröffentlichung der Daten, um schneller reagieren zu können. Habe ich das richtig verstanden, dass Sie sofort, nachdem Sie die Analysen an der Oder gestaltet haben, die Daten veröffentlicht haben mit Ihren Kollegen, oder gab es da Hürden, das dann auch tatsächlich zu tun?
Ja, unser Problem war eigentlich vor allem, dass wir selbst nicht so gut, also die Daten, die wir genutzt haben, zum Beispiel diese Satellitendaten, die sind verfügbar, die können wir nutzen. Wir konnten die bestehenden Modelle weiter nutzen. Das Problem, was wir hatten, wir konnten sie nicht co-interpretieren mit zum Beispiel den hydrologischen Daten, weil die Abflusszeitreihen zwar nach Gesetz zur Verfügung gestellt werden müssen, aber das ist ein ziemlich komplexer Prozess, muss man beantragen. Dann kriegt man die Daten auch, es ist ja schon gut, aber es ist nicht automatisierbar. Das heißt, Sie kriegen nicht einfach mal eben alle Wasserpegel eines Flusses in der nächsten Stunde. Aber in solchen Momenten ist es eben wichtig. Ja, und für noch komplexere Messungen, also Chlorophyllgehalte oder sowas, ist es noch viel schwieriger. Ja, Sie kriegen die Daten tatsächlich so, wenn Sie sich die Graphen angucken, aber dass Sie die wirklich analysieren können, das ist die Schwierigkeit. Also, dass wir die API haben, damit wir damit umgehen können, da hapert es so ein bisschen.
Das heißt, da gibt es also noch viel zu tun und
ja,
Effizienz gesteigert werden.
Absolut, ja. Und ich meine, andersrum gesagt, alles, was wir generieren und erheben, sowohl in Software als auch Daten, ist immer frei. Das, denke ich, gehört sich so.
Danke.
Weitere Fragen aktuell? Ja, von der anderen Seite nochmal.
Hallo, danke für den Vortrag. Ich hätte noch mal eine Frage, gerade zu den anschließenden, dass die Daten quasi nicht da waren. Was hätte es denn praktisch geändert, wenn die Daten da gewesen wären? Also klar, Sie hätten Ihre Auswertung schneller machen können und auch besser machen können. Aber gibt es denn jetzt aus Ihrer Studie heraus einen aktiven Handlungsvorschlag, den man quasi hätte umsetzen können? Und falls ja, wie hätte der ausgesehen, dass quasi auch eine Politik über Ländergrenzen hinaus den quasi effizient und schnell umsetzen könnte, ohne dass es quasi einen Diskurs über, ist das wirklich Klimawandel oder nicht, überhaupt wieder aufkommt?
Also ich glaube, an diesem Beispiel, also ich war jetzt an diesen Debatten selber nicht so genau beteiligt, aber was ich gesehen habe, ist, dass es sehr schnell sehr starke Schuldzuweisungen zum Beispiel gab. Ja, es wurden bestimmte Industrien vorverurteilt, weil sie zu viel eingeleitet hätten und so weiter, ohne dass man es wirklich wusste. Ja, und an dieser Stelle sozusagen ist Polemik im Spiel, die nie gut tut, so eine Debatte. Je schneller diese Aufklärung erfolgt wäre, desto weniger Schaden wäre vielleicht auch angerichtet worden, im vielleicht auch bilateralen Verhältnis der Beteiligten. Und so, glaube ich, geht das jederzeit in verschiedenen Dimensionen. Ja. Also wenn wir die Daten verfügbar haben, sinnvoll auswerten und objektive Informationen geben, erst dann können wir eigentlich in der Debatte wirklich sinnvoll beginnen. Was wir sehen, ist, dass die Debatten sofort beginnen, ohne solche Analysen abzuwarten. Aber wenn wir tatsächlich 2 Jahre brauchen, um sowas zu veröffentlichen, auch wegen solchen Hürden, dann ist es halt schwierig.
Und daran eine Anschlussfrage, wie schnell wäre für Sie denn schnell? Also ich kann mir vorstellen, so eine Auswertung dauert halt, auch wenn wir das schnell machen in der Wissenschaft, aber trotzdem Wochen und nicht nur Tage. Was wäre denn Ihr quasi, oder wie schnell hätten Sie denn Ergebnisse publizieren können in der Zeit? Wenn jetzt, geben wir vor, wir hätten quasi alle Daten sofort verfügbar.
Also, das ist jetzt so ein bisschen, weiß ich nicht genau. Also da hängen so viele Leute dran. Also das war also auch viel Analytik dabei, die sehr aufwendig war. Also wir hätten schon 2-3 Monate gebraucht. Also wir können das dann nicht morgen sagen. Ne?
Danke.
Ja, eine weitere Frage. Jetzt werden Sie mutig alle. Merken Sie das?
Good morning. I'm going to speak English. How are you, everyone? Good. So I'm so happy to be here in Leipzig. Especially, I can feel that I am data engineer from Canada. I feel the good respect for nature, for art, ethical AI. So that's fantastic. That's lovely. And my question for you. So, actually, my background is more engineering, but I like to watch about National Geographic, and I hear about there is a network of tree communication, and they can communicate with each other, and if there is a danger, they can predict something. So I'm not sure it's possible to detect some data from like a humidity level, color of leaves, polyphenol level, pH, and maybe we can catch from them. I believe that trees are really smart. Thank you.
So thank you very much for the question. I mean, there is a lot of networks ongoing. We have networks on phenology. We have networks from the remote sensing side, from the drone side, as you have seen, the trees.earth website is one of them. Most of those networks actually are operated, let's say, at a continental scale. So we have European networks, we have US networks that have, however, meta networks, the data are shared. So this works pretty well, but it doesn't really solve the problem that the data are still sparse in space and time. So, however, without that, we would be totally lost. The trees.earth thing is particularly interesting because this is really not organized. It's just a website where you can start sharing your data, and people just do it. And we were completely overwhelmed by the response. So you see like an almost full coverage of Congo. You see data contribution from Ecuador, from Colombia, from wherever. And people just see this initiative, and we have a paper where the first 2 pages are just authors of people who have contributed their data, and they're all just happy to do that because they see the value in the added value in joining efforts. And this is a mentality that I really appreciate, and I think we have to embrace more strongly.
Wie schafft man es denn, diese Daten, die man sammelt, zu verifizieren? Schwere, große Frage, ich weiß, aber vielleicht kann man das ein bisschen unterbrechen. Welche sind nützliche Daten und welche nun dann doch nicht?
Die Frage wurde auch von einem Kollegen vom Biomassezentrum so ein bisschen gestellt. Also es gibt ja verschiedene Levels, an denen man Daten verifizieren kann. Also wenn man zum Beispiel so eine KI trainiert, die lernt, was ist der Anteil der toten Bäume, dann hat man natürlich davor ein Bild per Hand annotiert. Ja, und dann sitzen viele Studierende da und malen diese Bäume per Hand ab und sagen, das ist ein toter Baum, das sehe ich. Und dann versucht man den Fehler zu minimieren gegenüber diesen Daten. Bei anderen eher globalen Datenprodukten geht das nicht so einfach. Und speziell, wenn wir auf Satellitendatenebene gehen, haben wir immer das Problem, dass ganz viele Störfaktoren in der Atmosphäre zum Beispiel eine Rolle spielen, wo wir uns auch auf Expertise anderer Gruppen verlassen müssen, die sagen, die beste Korrektur für diesen Sensor und dieses Band ist, das und das zu machen. Ja, und dann muss man eben sozusagen evidenzbasiert mit anderen Leuten zusammenarbeiten.
Interdisziplinär.
Auf jeden Fall.
Wo wir wieder beim Thema wären, Daten teilen. Da steht noch jemand auf. Sie haben noch eine Frage. Der Weg ist wirklich lang, ne? Bis zum Mikro. Tut uns leid.
Morgen und herzlichen Dank nochmal für den Vortrag.
Ein bisschen näher bitte, kurz ans Mikro, damit auch im Livestream alle hören. Dankeschön.
Besser? Besser. Gut. Meine Frage ist eigentlich, ich sag mal, das war ja eigentlich eine Analyse der Situation danach. Gibt es eigentlich jetzt auch mit KI und so weiter und so fort, denke ich mal, sehr intensiv. Wird das aber auch dahingehend genutzt, dass man das im Prinzip in Zukunft für eine Vorhersage nutzen kann, dass man im Prinzip eine globale oder ich sag mal jetzt deutschlandweite Überwachung der Gewässer und Flüsse dazu nutzen kann, um solche Extremsituationen schon im Vorfeld zu erkennen und auch, ich sag mal im Endeffekt auch Gegenmaßnahmen, Warnungen entsprechend auszusprechen.
Also wir versuchen uns dran, aber es ist nicht ganz einfach. Also wir versuchen zum Beispiel diese Datenwürfel, die Sie gesehen haben, vorherzusagen. Also wir nehmen Methoden, die in der Lage sind, raumzeitliche Daten vorherzusagen, wie so ein Video, und versuchen das aus Klimadaten vorherzusagen. Aber es ist nicht ganz einfach, weil natürlich die Frage ist, was bringt die Zukunft? Da kommen wir immer schnell in einen Bereich von Bedingungen, die wir so noch nicht gesehen haben. Und das ist wie das Problem, eine KI kann nur das lernen, was es schon gesehen hat. Wenn wir davon ausgehen, dass wir einfach weiter CO2 emittieren, dann werden wir bald in einer Welt leben, wo die CO2-Konzentration höher ist als alles, was wir zumindest in unseren Daten jemals gesehen haben. Das ist schwer zu lernen. Also wir versuchen das, Aber denken Sie an Wettervorhersagen, die funktionieren vielleicht 13, keine Ahnung, bis zu 14 Tagen ganz okay. Saisonale Vorhersagen, wie wird der nächste Sommer, sind schon richtig schwierig. Aber das wäre ja erstmal überhaupt die Voraussetzung, dass wir dann sagen können, wie reagiert die Umwelt darauf. Ja, und das in der Welt, die wir noch nicht gesehen haben, ist relativ schwer. Wir versuchen es, erste Ansätze sind gar nicht so schlecht, aber ich möchte mich nicht zu weit aus dem Fenster lehnen, dass das in naher Zukunft möglich ist.
Vielen, vielen Dank. Wir haben wertvolle Erkenntnisse schon zu Beginn dieser Data Week jetzt von Ihnen bekommen können. Es geht um Daten teilen und vielleicht sollte man das, wie Sie das auch schon gesagt hatten, noch mehr in dieser Woche diskutieren. Vielen, vielen Dank für Ihre Expertise, Professor Dr. Mahecha. Mahecha. Ich werde lernen, ich verspreche es Ihnen. Vielen, vielen Dank. So, und wer ist bereit für ein kleines Päuschen? Ihr dürft die Hände heben. Fühlt euch frei. Ich habe eine ganz, ganz gute Mitteilung, denn nun werden wir in eine kleine Mittagspause übergehen bis 12:30 Uhr. Nutzt die Zeit für die Metaplanwand. Ne? Also da müssen ganz viele Zettelchen gefüllt werden. Kommt hier vor zu Sandra, schaut nochmal, was hier bereits entstanden ist und dann freuen wir uns auf die weiteren Sessions. Vielen, vielen Dank, dass Sie da sind. wieder umschalten. Perfect. So now we want to switch in English, and I'm really happy to welcome the team from the Helmholtz Center for Environment Research. And we will begin with Dr. Zhang Peng, and we will talk about how remote sensing technology is used to study and protect our environment. And yeah, we will start, and important information, you will have an option for have a discussion after 60 minutes. So if you have some questions, please write it down, and we can ask the speakers after 60 minutes. Thank you.
Yeah. Thank you for the introduction, and hello everyone. My name is Jian Peng. I'm from the remote sensing department at the UFZ, and today, together with my colleagues, Amelina Garcia, Daniel Doctor, and also Maximilian Lange, we are very happy to show you how can we monitor our Earth system from the eyes of satellites, and how the space-based data can be used to better understand the changes in water and vegetation on the Earth. It's still there. I guess it's not harmonized there. Okay, now it's working. Yeah. So before I dive into the satellite data, let's first think about our Earth system. So our Earth is made up of different parts, including air, land, water, and life. And these parts are interconnected. So one small change in one part can also cause changes in other parts. So for example, if we have no rainfall, and the rivers will shrink, and plants will dry off, and the soil will become hard. So that's why we look at the Earth as a system. And this can help us better understand things like droughts, floods, and other climate extremes, and how nature reacts. And how do we monitor our Earth system? We actually use a so-called multi-scale observation system or platforms. So we can use this platform to obtain information from different levels. So for example, I guess use the mouse, maybe it's better. So for example, for local scale, we can use the ground-based sensors to measure such as soil moisture, temperature, wind speed. And we also have the airborne sensors on board the planes and the drones to get a regional view of the system. And of course, we have the satellites in the space can provide a bigger picture of our Earth from this very high perspective. And together with this different platform information, we can better understand how our Earth system changed in the past, and also provide information for our Earth system models. That's why I'm always saying collecting data is only part of the story. So to know how the Earth system behaves and how it might change in the past, in the future, we also use models, in particular the Earth system models, which are based on physical laws and mathematics, and this also input data. So in this slide, on the left, you can see the very famous blue marble image, and taken from the Apollo 17 by the astronauts in the Apollo 17 on its way to the moon. And on the right side, it's actually a model simulation at the same time. And if you look at these two pictures, they are very similar, which shows that our model can already capture very well the key process in the Earth system. But if you look closely, you can still see the noticeable difference for the clouds, for example. And this difference further suggests that our models are not perfect enough. We still need to improve the models. And that's why the satellite images become very important, because this data can serve as the reference or benchmark to further improve and evaluate our model frameworks. And where are the data from, actually? So they are kind of collected by a wide range of Earth observation missions, which means the satellites launched by different space agencies, such as NASA from the USA and ESA from Europe. And each individual satellite is designed to observe certain parts of the Earth system. For example, some can measure the vegetation parameters and soil conditions, and others can measure the atmospheric properties such as aerosols, clouds, and wind speed, and even the ocean conditions, including ocean temperature, ocean color, the ocean wind, and the ocean waves. There are even other satellites can measure the total water storage even beneath the ground, which is called GRACE satellite. And it actually senses the tiny shift in the gravity to somehow estimate the water storage in our Earth system. And the good thing is for most of the data from these different missions are open and free, which can allow researchers around the world to understand how the environment changed and even provide support for policy makings. So now we know where our data from, and let's look at how can we turn the satellite image into meaningful information. So satellites cannot directly measure land surface parameters such as forest cover, soil temperature, soil moisture. Satellites can only measure the reflected sunlight or the thermal radiation. And together with algorithms and models, we can further retrieve the surface parameters from these satellite signals. And then this map is one example of the ESA land cover map. And different colors shows the different land cover types, such as forests, grasslands, croplands, wetlands, cities, or open water, etc. And this kind of information is very crucial to track the change of land use, biodiversity loss, and even understand how the ecosystem respond to different climate extremes, including droughts and heat waves. Now we know we can actually retrieve these parameters from remote sensing data. And another example I want to also share with you is we can also use data from satellite to estimate soil moisture. So how dry and wet the soil is. And again, so satellites cannot measure the soil moisture, but we can use microwave remote sensing, which can penetrate the clouds. And together with the radiation transfer model, we can somehow estimate the moisture in the top centimeters of the soil. And this map is one example we recently produced from our team, this global scale 1 kilometer resolution soil moisture from the active microwave remote sensing. And it's the first global scale high resolution soil moisture dataset from the SAR data. And we are currently using these products to evaluate and improve our hydrological modeling simulation for the whole Europe. Now that we know we can use remote sensing to measure different parameters like land cover types and also soil moisture from the two examples, they can also estimate other parameters like plants, properties, soil condition, etc. And these data are actually come with different resolution. For example, in time, the data are obtained from hours to several weeks. And from space, this data can come with meters resolution to tens of kilometers. So this large variety can actually meet the application requirements for different places and different fields. And for example, the global products can help us better understand the climate trends and the variability, while the data products with more detailed information with high resolution can further support monitoring the crop health and even for the city planning or the city heat island. Let's take soil moisture again as the example to show how can soil moisture be used for different applications in different fields. And again, soil moisture is a very important variable for land-atmosphere interactions. It can further influence our weather forecasting, our hydrological modeling, and even the disaster management. And so the one major application is the numerical weather prediction, because soil moisture can influence the evapotranspiration and also the energy exchange. So the accurate information about soil moisture can further help our weather models to provide more reliable forecasts. On the other hand, in hydrology, if the soil is already wet, then the new heavy precipitation or the new storm can easily induce floods, so which is very important for the flood early warning systems. And on the other direction, if the soil moisture is low, and of course, the soil moisture can be a proxy for detecting the drought conditions. And this map somehow shows how we use soil moisture to monitor the different conditions of the droughts, also the drought severity, the drought durations, and even drought frequencies. And such information is very important for agriculture, water management. And also, soil moisture are very widely used for the climate studies. So we can use soil moisture to better understand how the global warming influences our water cycle changes and also the land surface process. So despite this kind of progress and the various applications, there are still many unknown or unaddressed questions. And in UFZ, so our team is trying to better understand the water and vegetation dynamics through the integration of multi-source remote sensing data together with physical model and machine learning approach. We are also trying to understand the impacts of climate change on the water resource and the ecosystem functions. And finally, we also seeking ways to transfer our knowledge to address certain societal challenges. So in the next part of the talk, my colleagues will show you some very exciting examples how we use remote sensing to address these challenges. And with this, I will hand over to my colleague Amelina Garcia, and she will discuss a bit how remote sensing can be used to monitor the water cycle changes via model data fusion approach. So Amelina, please.
Hello everyone, my name is Almudena Garcia. I'm a postdoc scientist at USZ for the last 4 years and a half. I came to Leipzig just after finishing my PhD. And today I'm going to talk a little bit about the application of remote sensing for the water cycle. I think everyone here agrees that it's very important to understand how the water cycle changes because of human activities, like it could be irrigation or just the management of dams, but also because of climate change, because just because of having more warming in the atmosphere, we will have more evapotranspiration from just the soil and oceans, but also more transpiration from plants. That can speed up the water cycle, and depending on the topography and the characteristic of this area, this can have some impact on the water resources and on the water components of the cycle. So today I'm going to talk a bit about how to use remote sensing for monitoring and understanding these changes in the water cycle. First of all, we will need some observations. As Jan already mentioned, in situ measurements are really important and very useful for understanding how the water cycle is changing in different areas, but they are local. We have just the information in very few points, and we miss the global perspective there. If we want observations with a global perspective, it's very easy to think that remote sensing can be very useful. We also have like revisiting times of satellite data in each area quite frequently. It could be a few times in a day, or even or just a few days. But we have some information there for checking the evolution of the water components. But we have also some limitations. We cannot directly measure all the components of the water cycle, of the hydrology, from remote sensing. We can just measure the surface soil moisture, the water content just in the very few centimeters of the top of the soil, and also the water amount in an area, but without knowing from where the water comes. This is the GRACE data that Jan just mentioned. We can know, for example, in a pixel of 300 kilometers, if we have certain amount of water, but we don't know if it is in snow, in groundwater, in surface water, in plants. We cannot know that just from the measurement. So we need a solution here. Our solution, and also the one that most of the research community is using, is the combination of models with remote sensing. This combination is especially using physical models, for example, hydrological models or land surface models that are able to simulate the energy and the water exchanges at the land surface, and also how the water moves from area to area and through the soil. These kind of models, depending on the complexity of the models, can also simulate, for example, some human activities, like the management of dams, irrigation, or even urban areas. But we need information for solving all the equations that are contained in these kind of models. This information usually can come from reanalysis data, that is a mixture of another model with some observations, but we can also use just remote sensing for that. Another application where we can use remote sensing data in combination with these models is just using some assimilation schemes. That means that we are going to leave the model to find the good solution, but we are going to constrain this solution to the observation that we have. For example, if we want to use soil moisture from satellite data, we can tell the model that it should find a solution that reproduces the observation that we have. That is challenging because of the physical consistency of the model and so on, but it's possible. So that's what we do. Another option for using satellite data with these models is just to use it for finding the parameters in the model that we cannot really measure. We can provide this information in order to improve the accuracy of the models. We can also just use this information to improve the representation of some processes that cannot be resolved in the model so easily. For example, irrigation. We can provide information of when people in agricultural areas are irrigating the crops, and in this way the model can really include that process in the simulation. The same thing with the management of dams. We can get some information of how humans are moving the water from one side to the other, and in this way the model have more information and can get a better representation of the whole hydrology. Something like that, not the last part, but the first part, we are doing at USZ. In this case, we are just using remote sensing as boundary conditions for running a model. We are using the high-resolution land atmosphere parameters from space, HOLAPS frameworks, which is a combination of a radiative transfer model. That's it. We have a module that uses the measurements of radiation at the top of the atmosphere from satellite to simulate how much of this energy is really absorbed by the soil. So we need to provide information about the cloud cover, the chemistry of the atmosphere, and also how the surface is, the albedo and the emissivity. With this kind of information from satellite, we can really simulate the energy that is absorbed in the soil. Now that we have that part, we have another module that is based on a land surface model. With this module, we can use this energy to know how much of this energy is used for evaporating the water in the soil, or just if we have information also from satellite about the vegetation that is in that area, we can also calculate how much of that energy is used for transpirating the water from the soil to the atmosphere thanks to the role of vegetation there. We can also calculate how much of this energy is used for warming up the soil and therefore releasing heat to the atmosphere via sensible heat flux, or just to know how much of this energy is propagated through the soil, the ground heat flux. We can also have information about the water here, or we have information also about the water here. We can use information of precipitation from satellite to know how much water is in the soil, and how much of this water is evaporated, and also how much of this water is filtered through the soil. We have information at different soil layers, so we have this part of the soil profile, soil water profile, that is not able to, that we cannot measure from space. Only in combination with these models, we can have this profile. The last part of the framework also simulates the effect of the planetary boundary stability on the energy and water exchanges between the land surface and the atmosphere. We know that depending on the stability of the atmosphere, we can have a larger or smaller effect, so we also include that into the model. So with all of that, you can see that we have information of several variables related to water and energy, and all of them are consistent between each other and with the satellite data that we are using from different products and different institutions. Let me tell you a little bit more about how this thing works. As I said, we use as much remote sensing data as possible. We use, for example, information about radiation, leaf area index, that is an index of vegetation, albedo, emissivity, land cover, and precipitation. But we also need some information about meteorological variables that cannot be measured from space. In this case, we use also some information about reanalysis data, air temperature, surface pressure, wind speed, and the column water of vapor. We also have some information about the components of the soil. That can be obtained from other observational grid data sets. But with that, we fit the model, the framework, HOLAPS, and then we obtain our output at very high resolution comparing with the products that are available in the literature. We obtain output at 5 kilometer resolution over Europe every hour, which is really nice if we are really going to check the interaction between the land surface and the atmosphere. And yeah, we produce these data set from 2001 to 2020. So we have long-term estimate for really checking if something is changing and why. I also included here a video for you, so you can see more or less how the estimates look like. This is just latent heat flux, evapotranspiration, the water that is evaporated from soil and plants. And you can see the daily cycle here. Of course, if we don't have energy in the soil, we cannot evaporate nothing. So at night, we don't have evapotranspiration. Also, you can see the influence of clouds. If we have clouds, we get less radiation into the soil, so we cannot really evaporate, and we see this influence. The other thing that you can also see is that the areas that have more vegetation have a higher evapotranspiration, which makes sense because transpiration is a big part of this variable. And yes, and you can see many small details thanks to the high resolution of the product. This product is available at USZ, so if you are interested, you can just contact us and we will be really happy to share it. In the webpage, it's also available. And now I'm going to talk about another example. In this case, this one is like a bigger project. It's an ESA project. It was funded by the European Space Agency. and is led by UFZ. We are a main component of that, but another department is leading the project. This project is to evaluate the added value of remote sensing data for improving the simulation of hydrological models. The thing is that hydrological models are really good at a resolution of 5 or 10 kilometers. But if we go to super resolution, then the accuracy is not so high, depending on the model as well. But usually they have problems. With high resolution or super high resolution, I mean less than 1 kilometer resolution. If we want 1 kilometer resolution or a few meters, then the model has some issues. Why? Just because the parameters are not very well scaled, or just because there are some processes that are not included in the models. So in here, what we want to do is to see if by adding information from satellite data, we can really improve those simulations at that resolution. To do that, we are in collaboration with 13 European institutions. It's quite challenging to manage people from different institutions and with different interests, but we are doing that. And this is a great thing because we are collaborating two different communities. The modeling community together with the remote sensing community. And that has not happened many times. So the first thing that we did was, okay, we have many models in this consortium. And we also have many remote sensing products that we would like to test in these models. But if we test every remote sensing product with every model, we don't have enough computational resources. It's just prohibitive. So the first thing that we need to do is to choose one remote sensing product that we are going to use in the models, in all the models, to test if it really improves the simulation in every model. We do that for different variables that can be estimated from remote sensing, soil moisture, snow, precipitation, and evapotranspiration. And we just compare the products that are available. Of course, we take into account the requirements from the modeling community. High resolution, no gaps, spatial or temporal gaps, other things like long-term coverage and spatial coverage. We are in continuing conversation to at the end, recommend one product for each variable. That's what we did, and the results are already under revision in a scientific journal. And with this product, then we define some scientific cases to really check if by using this product, we are improving the accuracy of the model for different applications, because we cannot do it just for general. I mean, as well, but we were interested in certain applications. One of them is the irrigation. Usually, models are not very well simulating irrigation. So what we wanted to see is if by including this information from satellite data, we can improve the water balance in the model in areas where irrigation is present. We did that, and the results are like in there. I mean, the thing is that we are using 4 different models with the same information from remote sensing data, but the models are very different. The results differ a lot, and we are there still discussing what is going to be like the main recommendation for the future of the modeling community and remote sensing to really improve this irrigation effect on the water balance. We will have some outputs probably at the end of the year, so if you are interested, again, contact us. Another application that we just developed was to test how the remote sensing product improved the forecasting of extreme stream flow. We focus here on stream flow because usually when we have extreme stream flow, we have floods around the rivers. And what we did was to use information from soil moisture to initialize the models and then do the prediction for the next few months and see if the event is better simulated or not. Usually improves the model when we initialize with soil moisture. But again, depends on the model, and the accuracy of the model are very different. So one conclusion here is that the modeling community should talk between each other and really improve the models or choose the models or the processes that are better simulated in each model. But in this case, we kind of find a conclusion, so we were happy. More information about other science cases and this project are available in the webpage that is here for the hydro.eu. And also, very nice in this webpage, you have an open science catalog. You have all the simulation that we are providing for this project, open access. You can download them and do your own analysis. They are for Europe and then some different basins in Europe, the Rhine Basin and also the Po Basin in Italy. So, and another basin in Africa, Tugela, the Tugela River. Yeah, so if you are interested in this kind of information, just go there and use it as you want. And then now I have a question for you, because I'm talking a lot about models and remote sensing, and usually you can imagine that takes a lot of computational resources. So my question is, for my first example, the product that I said about HOLABs, combining hydrological models and remote sensing. How many computational resources do you think are really necessary for generating this HOLABs product? We mean like Europe, 5-kilometer resolution, but only 1 year of the simulation. You can raise your hand when I mention each solution. So less than 10 core hours. Okay, 1. Around 500 core hours. Okay, a few. And around 1 million core hours. A few as well. Okay, so the solution is in the middle. The strategy of choosing the middle is always the best one. Yeah, but I included some different numbers because I wanted to give you an example of the amount of that are really necessary for each application. These are totally different applications. For example, less than 10 core hours are necessary for running the forecasting of a machine learning model. Forecasting of 3 or 6 hours. But of course, this is the trick. It's just forecasting, not training the model. For training the model, you need like a lot of resources. But for forecasting, it's very quick and very cheap. Then the middle is the HOLABs product that is kind of in the middle. So we are using a lot of computational resources, but yeah, we are there. And then the last one is a global climate model. That's simulating hydrology and atmospheric processes, ocean currents, everything in the Earth system at 25-kilometer resolution. Those are a lot of pixels in the globe. So because of that, we need millions of core hours for that. And with that, I'm going to leave you with Daniel Doctor that is going to talk about the application of remote sensing for vegetation. Thank you so much.
Yeah, thanks a lot, Almudena. Yeah, we're moving on now to forests, to our forest condition monitor, as we call it, which was set up several years ago as a response to the drought in Central Europe, which started in 2018 and which lasted for several years and which affected German forests and also European forests, of course, to a large degree, such that large parts of the forest, and probably you all have seen those pictures from the Harz Mountains, were severely damaged, especially the Fichte in Germany, but also beech trees, which is substantial natural vegetation in Germany. For example, here in the Hainich were largely affected, such that forest went from a carbon sink, what it usually is, to a carbon source. And that, of course, is quite disturbing, also if you regard forest with respect to the services we expect from it in the future, also in terms of mitigating climate change. At the same time, we are wondering what information do we actually have about forests. So at the moment, there is, regarding forest damages, we have information which is quite difficult to gather, to acquire. It's quite detailed, a lot of effort is spent, and it's very personal intensive. But because it's kind of done on the ground, the information can be gathered only in fairly long time intervals and also at not so many points in space. So we get a statistical sample, as in these samples are very good information, but we lack information about space and we lack repetition time of this information. So just to give you an idea how this points out in the end. So you can see here now on the left-hand side, German forests in green. Yeah, you can see here, for example, Black Forest, the Harz Mountains, and so on. So if you get used a bit to this map, you quite well identify the forest regions. And now you can see in the middle, if you have good eyes, you can see the points where this Waldzustandserhebung is done in Germany. So that's in total 432 points. And I enlarged them already by a factor 100, and you can barely see them, right? And now by enlarging these points factor 10,000 of reality, you can see where they are and how many there are. So this is just a visual example to demonstrate how much information we've got available in space in Germany on that matter, because it's so difficult to acquire. Which doesn't speak against the colleagues who does it from the Landesforsten, but as it is so personal intensive, it's just difficult to do so. Also coming along with those Waldzustandserhebung, we have mortality rates which are given to the public. So here you can see, for example, that the mortality rates go up from about 0.5% in the preceding years, the drought, to about 2%, depending on species, in and after the drought. And the question is, it's a nice number, so how does it actually translate into space? So what does it actually mean for whole forests, this increased mortality rates? And this is something we want to answer with the Forest Monitor. So we want to combine information of satellite time series, of AI methods to complement these forest condition assessment, which is done by the BML, and of which you see, for example, the report of 2019 here. So just to back up a little bit on remote sensing of forests, so Almudena introduced a bit already, satellites, and I transfer this now to vegetation. And you can see a very prominent feature which everyone knows of you, which is forest or tree phenology. So you can see how the forest changes over time within the season. And to capture this and to capture these changes, so leaf out green, getting green in spring and then leaf coloring in autumn, to capture this at a really high temporal resolution and also spatial resolution, that's now possible with, for example, the Sentinel-2 satellites. So you can capture this ecological advancements or evolution throughout the season, and you can even capture single trees if they are large enough. As you can see here in those pictures, so you can capture tree crowns with a fairly high spatial resolution and with the different wavelengths which are retrieved by the satellite, you can then infer information on pigment content, canopy water content, or leaf area index, which are, of course, very good proxies for forest condition. Of course, there are also problems regarding to spatial resolution, for example. So sometimes, as I illustrated here, you just capture maybe a forest path, or you just capture fallen leaves, or maybe a dead tree in terms of, or maybe a combination of dead trees and trees which are still green if your resolution is not good enough. So it doesn't work always in every case, but by and large, we have now the tools at hand to do a fairly robust forest condition assessment. And we went to different interest groups before we started those projects and asked, what are you interested in? What do you expect from such a forest monitor? And they were interested, for example, in having a web-based or forest information system, which we might show later on if there's enough time, an online system which gives you all the information I will present and which Max will present later on. They asked, for example, to have information on tree species, on phenology, to have this information easy accessible and very quick, and also asked information, for example, on future tree species distribution. So how will the tree species do in climate change and under climate change? Do we can still count on the tree species which occur here also in the future? And we try to implement these requests from the interest groups, from the stakeholders into work packages, and I will give you a quick overview now and Max later then in more detail on some of the results. So first we processed all the satellite data necessary into a data cube, checked whether there's a good geolocation over time, meaning is the satellite pixel, because we take time series, always observing the same spatial unit on the ground, or does it shift back and forth such that we might see the tree next to it at one observation and then the other tree in the one after, and that's all okay. So it has a very good spatial geolocation information. The processing into a data cube worked also, but it takes a lot of computational time. So just to process 1 year of Sentinel-2 data is 400,000 core hours, for which we used our supercomputer at UFZ. So that's just processing the data, but then inferring all the products and putting this into a data cube and so on, just to give you here an idea of the workflow, how we sketched it once, takes even more time, several 100,000 up to million core hours to produce this product for several years. It takes terabytes of data as well, which you have to have mostly with live access available. And just to translate this, maybe if you would use a single laptop for this, it will take you several hundred years to do so. So that's how much power you need there for all the processing and for visualization as well in the end. And all the results you will see now have been through this process. Yeah, this is one outcome. So Max will give you later on a bit more on the methodology on how all these maps are derived. But I just show you here 2 years of forest condition of the Harz Mountains, which we've seen in the pictures at the beginning. And you can see in 2017, loads of the Harz Mountains are colored in green. Green means for our forest condition anomaly index, which we developed, it's good condition. So trees are fairly green, healthy, high vitality in those trees. And there's only one area here in the center, which is around the Brocken, which is covering the national park. So at that time, there was already the bark beetle active there. But because there's the policy not to clear forests, to cut trees, this kind of goes on, and forest was already disturbed there, but all the rest was in fairly good condition. Pink colors mean forest is already heavily damaged or pretty much dead. And now moving on to the year 2022, we can see that this heavily damaged or dead area of the forest has increased dramatically. So from around up to 80% of needle-leaf forest have died more or less over 4 years. And this is what this mortality rate we saw at the beginning actually means in space. Yeah? This mortality rate, which is, according also to our estimates, largely underestimated, at least in some parts, then pans out into this picture, what you can see here. And you can also calculate statistics from it, which we also offer from our website. So statistics on how this damaged area has changed for needle leaf forest, for deciduous forest over the years. You can have a look here. So we have then needle leaf forest 80% damaged or dead in 2022 compared to 10% in 2016. This is almost impossible to evaluate with the local forest agencies. We try to do so, but basically you have to contact every single forester almost there in the Harz Mountains, collect and process this data, and even then you would probably just come close. So that's why we call it complementary data, also additional to what we have already available from Waldzustandserhebung and different sources. Yeah, and just to give you, to finish this, an idea of how future tree distributions might look like, an example of how the Fichte is doing. So we have here now two climate scenarios, RCP 4.5 and RCP 8.5. So 4.5 is slight adjustments to climate change, which is almost what we're doing now, maybe not quite, and 8.5 is business as usual, so we just continue as we did in the last years. And you can see in green, these are areas where the Fichte will move into in the future. So future means 2080 to 2100. Roughly, yellow and red areas is where the Fichte will disappear, spruce in English. And gray are areas where the spruce was never there in past and also will not be there in the future. And you can see in the RCP 4.5, so under moderate climate adaptations measures, even then we will lose large parts of the spruce forest in Central Europe, only in the higher elevated regions in the Alps and in northern Scandinavia. There will be better conditions, but even in southern Scandinavia, spruce is mostly gone. And if you go to business as usual, so RCP 4.5, spruce is more or less entirely disappeared from Central Europe and also southern Scandinavia, except for mountain regions in Scandinavia and the highest regions in the European Alps. So not a good future for spruce forests currently. Yeah, and with this, I'm through, and I will hand over to Max. I think we have to change now to different video. Okay.
Hey, it works. Hello, my name is Maximilian Lange, and I'm also working at the Helmholtz Center for Environmental Research here in Leipzig. And I will present you the methodology behind the forest condition monitor, which was already introduced by Daniel. As Daniel already pointed out, we not only saw an increase in defoliation in the trees in the last years, but also in mortality and disturbance rates, which is also shown by the Waldzustandserhebung, the German ground condition survey. And this increasing defoliation and forest cover loss was not only driven by the drought itself, but also by subsequent bark beetle infestations, fires, and windfall. And thus, there's an increasing need for disturbance detection, vulnerability assessments, and risk management. And furthermore, also for us scientists, it's really important to assess forest condition because it's an important input for numerous ecological models, such as biodiversity, biomass models, carbon flux models, and many more. But for this, we need area-wide data, so here we use satellite data, especially the Sentinel satellites from the Copernicus program, which was also shown before. So this is a European mission, and the data is freely available, which is really valuable for us. And here in this talk, I will focus on Sentinel-2 optical satellite data. We acquired this data Germany-wide for 2016 to 2024 in 10 and 20 meter spatial resolution, and it has a spatial resolution, and it has a temporal resolution of 3 to 5 days. We downloaded the data directly as level 2A data, which means that it's already atmospherically, topographically, and cirrus corrected. So there's already a lot of work done to eliminate these atmospheric influences. And furthermore, as you can see here in these images, there are still some clouds in the images, and these can be removed using the internal scene classification which comes with the data, which is called Cent2Core. One of the first products we generated are phenological metrics, which were already also mentioned from Daniel. So we calculated them using time series analysis using our own R package Phenex, which is also freely available online. Phenological metrics mean, for example, the date of green up in spring or the date of senescence in fall. So basically the date when the plants get green and when they get colored leaves again in fall. This is shown here in the image to the right. If we think about one point in space, like a single forest pixel, then we get measurements from the satellites which reflect their greenness. This is here shown as NDVI, a normalized difference vegetation index. The higher the values, the more green is the vegetation. But these values are influenced by clouds, haze, and so on. So we have to filter for true values, so basically cloud-free observations. And these are shown as red dots here in the time series across the year. With these values, we then can model the true phenological profile, which is basically the yellow line here. And we see an increase around day 100 and then decrease again around day 200. And this is our vegetation period. So if we extract these dates, we can then look at a specific period in time to fine-tune our forest condition models. And if we look at this spatially, you can see this here as a map. We really see distinct patterns across Germany. So we can clearly see evergreen forests, which are kind of early green up because the vegetation stays green in winter. We see agricultural areas or forested areas with quite different phenology. So most of the deciduous forests in Germany show a green up around day 90 to 120, so basically end of March until early May. And we have this data now available with the Sentinel satellites from 2016 to 2024. And with this, we can get insights into long-term changes of vegetation and can also understand climatic influences and shifts in seasonal events, which of course are important when we think about forest condition and the change in each season. Then of course there are some differences simply based on phenology, which we have to think of. Another important product we used was a tree species map which we received from the Thünen Institute. They outlined the 11 most common species in Germany in 2017 and 18 with 10 meter spatial resolution, also using satellite data, environmental information, and forest inventories to train a machine learning model and then depict the location of these tree species. I aggregated this map for simplicity to the 4 most common species in Germany, which are spruce, pine, beech, and oak. So Fichte, Kiefer, Buche, Eiche, and 2 groups summing up the others into an other deciduous and other non-deciduous group. And further, we regionalized our model by using Germany's 7 major forest landscapes. These are shown here in the map to the right in different colors, which differ in their morphology, orography, and climatic conditions. So then we can do our forest condition estimation for each species and each region separately to be more precise in the end. So, but how does this work? So if we think again at the keynote in this morning from Miguel Mahecha, this is quite similar. This is also an anomaly detection. So we first generate statistics of reflectance time series for each species in a given region. This is shown here on the left side, and you can see, for example, in the upper left image, all near-infrared observations of all oaks in the northern lowlands in Germany across a year. The black line here in the middle highlights the median of these observations and the shaded areas around it, the respective quantiles. Again, we see here an increase in reflectance around day 100, so mid of April, which is related to phenology. If we now want to evaluate a single satellite observation of a specific year, we first have to correct the statistics here for the phenology of the respective year, and then we can compare our measurement to it, which is shown on the right side. Here we see, for example, an observation from the satellite which falls into the 87th percentile of the statistics, and then we can calculate its deviation from it by subtracting 50 and dividing by 50. So we simply get a deviation of 74% from a kind of a normal state. The final forest condition anomaly index, in short FCA, is then determined using a weighted mean across all the satellite bands and an average over time to get a robust value, for example, for a month, a season, or a year. And that's how we generated the maps which were shown by Daniel here. This shows the FCA value, the yearly FCA value for the region Harz in 2016, with green values reflecting inconspicuous forest condition, so basically positive FCA values, yellow colors reflecting the FCA values between 0 and minus 0.15 as slightly damaged areas, and the purple colors showing strongly damaged areas with FCA values below minus 0.15. And if we now go forward in time, we saw it already, these damages increased dramatically, especially after the drought in 2018 to 2021. So basically, nearly all of the spruce stands in the center of the Harz were severely damaged, whereas the deciduous stands at the mountain edges remained relatively healthy. But of course, we had to check if our value is correct, if we really see the truth here. So we compared it to several other state-of-the-art forest condition products. And there's, for example, the Global Forest Change Map from Hansen, which outlines forest loss in specific areas, or it outlines them all over the globe, but here we checked them for Germany. And we see that our FCA distribution is really different, or significantly different in areas with compared to areas without forest loss. We also looked at local scale data. So there's, for example, the Copernicus Emergency Management Service, where you can really see areas in Europe that were affected by windfall or forest fires. And here we also see significant different value distributions. And the same is true for insect infestations. Here we got data from the Bavarian forest, where they had a severe outbreak of bark beetles and also found differences here. Further, also the temporal evolution of our index differs between the different disturbance drivers. As you can see here, you see the FCA distribution across all the years. And we see a rapid decrease in FCA values after events like windfall or forest fires, because these events are sudden events destroying the forest at one point in time. But for insect infestations, the picture is different. These more gradual damages are also reflected in a more gradual decrease of FCA values. So it makes totally sense. And finally, we also looked at the spatial shapes or spatial patterns of these disturbances. And here we also found some significant differences. So if we look at an area which was affected by windfall, we see these more sharply delineated small disturbance patches as a result of these storm damages. In the center, we see a region in Brandenburg which was heavily damaged by forest fires, and there we have these large, sharply delineated patches of forest which were completely burned down. And on the right side, we can see these more fragmented and gradual spatial patterns as a result of insect infestations. But we not only relied on external data sources to validate our index, but we also got into the field by ourselves. So our team visited 4 different forest areas here in central Germany, which are the Harz, the Hohes Holz, the Dübener Heide, and the Auwald. The Auwald is here in Leipzig in the center. And all of these forests showed quite different disturbance patterns. Some of them showed good FCA values across all the years we observed. Some showed moderate values, and some showed a strong decrease in forest condition in the same period. And here, the strong damages occurred mainly in the Harz Mountains. And our team looked at the defoliation and the leaf coloration in these forests, and here we found a strong correlation with our index values. And at last but not least, we also compared it to the results of the German Ground Condition Survey, the Waldzustandserhebung, which we saw before. And they outlined an increase in mean defoliation across Germany from 2017 to 2020. And we see a decrease of FCA across the same period with a quite high correlation. And further, they also classified the trees into several defoliation classes, and we see a strong trend towards lower FCA values within increasing defoliation classes. So what can we do now with the index? As Daniel already pointed out, we need more spatial information to look into detail where these damages occur. So we analyzed here the frequency of low FCA values in several regions in Germany. So each pixel value here highlights, depending on the color, the frequency of forest damages, with black being nearly totally damaged and light colors being not damaged at all. And we see that in 2018 we have some minor damages in Saxony-Anhalt or Sachsen here for both deciduous and non-deciduous species. But in 2022 we have a different picture. The deciduous species showed an improvement in forest condition, whereas the non-deciduous species showed a strong worsening of forest condition across central Germany. And if you're interested in these maps and this result, you can have a look at our web application, the so-called Waldzustandsmonitor, our forest condition monitor. In this web GIS, we not only show the FCA products I've shown here, but also the phenology of the trees in Germany, some vegetation indices, and also the tree species, and also the species distribution modeling Daniel showed before, which highlight the development of tree species under a future changing climate. And we also implemented a lot of text here describing the methodology in detail that everybody can assess what we have done here in an easy way, so to really understand what these maps mean. And if you're more interested in that, we also have a scientific publication about the topic, which is available in Remote Sensing of Environment, also online. So as you have said, we are also currently working on other similar topics. So we had a master thesis and a guest scientist analyzing, for example, the relationship between these FCA values, environmental information, and biodiversity, and hope to also assess the drivers of these changing forest conditions. In our current project, Navapoca, we also use remote sensing data to assess more the structure of the forest and subsequently the nature conservation values, which are of course important for planning procedures in Germany and for policymakers. And you have said internally, we are also looking at other forest topics, for example, the relation between forest condition and wind farm locations. And with all of that, we hope to gain more insights into these interesting aspects of forest research. Thank you.
Perfect. So now we want to continue with the questions from the audience. So please feel free to come to me. It's really cold here, so I need you guys. Yeah, now it's time for questions. Feel free. Maybe we can translate some German questions also in English. Hopefully. Also es ist auch möglich, in Deutsch Fragen zu stellen, falls jemand jetzt Englisch vielleicht nicht ganz so möchte. Aktuell nicht. It was so much information, so everyone's sitting down. All right. So I have a question. Oh, surprise. Does it have any influence on the quality of data, whether it's day or night? Maybe for your specific... Do you need a microphone? Maybe this? You can use that one if you want. Yeah.
And I can start a bit. You are right. So information, in particular this flux, so the energy flux, they change a lot over daytime and night. And that's why we try to actually use different measurements techniques. But to be honest, from the flux tower, so the eddy covariance towers, because at night, the turbulence is very low, so we cannot actually measure this flux at night properly. That's why for the flux measurements and evaluation, we normally focus on daytime. But for other variables, not from our topic, for example, the air temperature is relatively easy to measure. That's why it's possible to evaluate at both night and daytime. And for soil moisture, as another example, it's a bit challenging because from satellite, they only have the kind of measurements at twice a day. So, and this kind of twice a day is mainly over daytime, in early morning and late afternoon. That's why we don't have data overnight. That's somehow from this soil moisture and the flux measurements. I guess from their part, from the trees, of course, they change very tiny for the daytime. They change it normally over different weeks or months. right? So if you want to add, you can also share some opinions.
Yeah, of course. I mean, what can change on a daily basis is productivity, but this is currently not captured as such by remote sensing. So this can be captured with fluorescence, but this is also only available at daytime. So all optical satellites, they give you information, or information of them is used daytime. Nighttime might be from radar satellites, which look more on structure of trees and vegetation. But yes, so we mostly, as humans do, just at daytime, look at vegetation.
But on daytime, you talked about, Max, there are some clouds. And how often it's difficult to get some good quality of data because of the clouds?
Yeah, so in Germany we have a quite humid climate, so it's roughly about half of the pictures is influenced by a really strong cloud cover. So, and of course we have to eliminate them, and then data is a bit more sparse than before. So if the satellite has a revisit time of 3 to 5 days, we roughly get good images every 10 days or so.
All right. We was talking about the thing that the citizen will include into the projects. How important is it for your project to have some more data from citizen? And do you need it, actually?
For their side, actually, it's very strongly involved in citizen science.
Yes, we try to include it more and more. So there are databases, for example, like Flora Incognita, you might have heard of it, or GBIF, iNaturalist. So these are both large databases where you can put photographs and descriptions of plants online with a certain location. And these are now being used also by remote sensing scientists, for example, for species detection, or plant traits, or also forest condition, maybe in the future, to include those information which is available, made by citizens. So there is some, of course, maybe the uncertainty of this information is a bit higher than this high-quality scientific measurements, but it can still be very valuable.
No, just that for our project, it's like the scales are very different and it's very challenging to really use those measurements.
All right. Any questions? Yes.
Yeah, thank you for your presentations. I have a question concerning regarding the last presentation. And did you investigate some kinds of spatial patterns, like a causal chain? If you say that is the destruction of the forest due to beetle was prevalently affected by a fire or by a drought, did you investigate it like a causal chain of spatial correlations on that? Do you know what I mean?
Yeah, I think you mean that there are multiple drivers affecting the forest condition. We did not investigate this yet, but we have some project which I also showed here. So we want to get really into detail into these relations because they might get quite complex. So in future projects, we also want to relate this to water availability, because this is of course one of the strongest impacts here. Also stressing the plants, and then these stressed plants can get more easily infected, for example, by insects. So we have this on our plan, but not done yet.
Cool, thank you. So something like soil geography and the button for something like that. Okay,
exactly.
Cool. Thank you very much.
Any other questions? I don't see the questions in the chat. Maybe I don't know if there's any question online. I don't know. Yes? No. Thumb down. All right. So yeah. Maybe we'll make some quick promo, because there's an upcoming workshop now, this day, so 2:30. So after that session, you will have a workshop option with the theme monitoring urban green spaces with satellite data. So you can make and have more information about this topic. And if you have some more questions, please feel free to ask these 4 persons outside. Maybe when you will have a coffee, because now we will have a coffee break as shortly. It's only half an hour, but you will have a short break to have a good time now, to have a cake maybe or a coffee, and we see us later. We will begin a bit earlier with the break, but if there's no more question now, we can go into the small break. Thank you for your expertise and for your time. Thank you.
to see you here, and looking forward to our session here now, where we want to give also maybe the Data Week in general a decidedly international flavor, because I think the topic of smart cities is an inherently international one. It affects really all cities and communities worldwide. Certainly there is some superstar cities for one smart city aspect or the other, but I think it's really exciting still to know that for this particular topic, for the mega trend of digitalization, actually, not to be a cliche, but everyone is sitting in the same boat in the sense that there is nobody who's completely checked out how the whole thing is supposed to be, right? So definitely we need the international perspective and exchanges on that to master this journey collectively. And with that backdrop, sort of, I just wanted to give you a few more sentences on the genesis of this session. So how did it come about even that the city of Leipzig and me from GIZ and the International Smart Cities Network decided to do this session together? I think the background is really that we already collaborated in the past a little bit. I see Sebastian Böhm there. So the International Smart Cities Network, I'll say a little more about that in a second. But we are basically tasked with precisely this international knowledge transfer and solution transfer for smart cities. And so for that, of course, we're also looking for some representatives from Germany to show the world in some ways and to find examples internationally to show communities in Germany. And Leipzig, I mean, I have many comparisons for cities all over the world, and Leipzig always seemed to me to be a very enthusiastic and very driven team. And so thankfully they presented also already in some of our formats, and we decided, well, if this collaboration works that well and if we can give such a good testimony to good collaboration, why not bring this also to the Data Week? Yeah. And
Thank
then
you.
maybe Christoph, you can lead just quickly through our plan.
Yes. Hello from me too. I'm Christoph here from Leipzig, from our Digital City Unit. And when we talked about the session and what we can do in the session, where is our connection point? We spoke about, okay, let's think about smart city and smart city use cases and how you can start a smart city use case all over the world, wherever you are, and how can we promote this, and what can we do to promote something like that? And then we thought, okay, what are we doing? What is Smart City, International Smart City Network doing? And I'm a project manager in our CUT project. It's about digital twins. I'm responsible for knowledge transfer, so we'll start that way, that Enoch will present what the International Smart City Network is doing, and then I'll present something about the knowledge transfer within our Digital Twins project. But all in all, that's only the pre-talk. Afterwards, we'll have the main event. It's a panel discussion and a small presentation about a connection between us in Leipzig, GIZ, and Lüderitz in Namibia, because it is the way that we are working together in starting smart city use cases. And I'm very glad to have Beate Ginzel from the Digital City Unit and the mayor of Lüderitz in Namibia here, and both will present what they are doing together. And afterwards, we'll have a small panel discussion to discuss how this works, how other cities can adopt it. And okay, then let's start. Enoch.
Yeah, thank you very much. Yeah, okay, so I'll just give a little keynote on maybe more broadly on this very idea. I mean, on the one hand, especially high-income countries and rich countries, of course, have discovered this big hype also around the smart city topic, right? It's also been a topic that's sometimes commercially driven and so on and so forth. So on the one extreme, we have quite a lot of resources and money dedicated to it to sort of master this big challenge of digitalization. But like Christoph already hinted at, I mean, there is also this whole other opportunity when we talk digital topics of actually having quick wins, of actually excitedly even jumping really ahead and finding sometimes even silver bullets for wicked problems and problems that we encounter. So I want to give like a general introduction to this whole notion of, in a way, resources or opportunities that already exist by now after all these big initiatives and programs that we have, that everyone can pick up regardless of the resources they have, so also really low-income communities and resources maybe the world over. I'll do that in the following order, so I'll just give you a very short introduction to our project of the International Smart Cities Network. And then I want to more generally look to development paths for data ecosystems and really digital public goods that exist already and that can be made use of. And look at a little overview, it's non-exhaustive, but of things that are already out there so that we can then maybe transition really into more concrete examples and the concrete case maybe of initial exchanges between Leipzig and Lüderitz, and maybe also some other thoughts and ideas that you have. So very briefly on the International Smart Cities Network, what is it? So I think you can say it's one of the big pillars of Germany's current federal smart city approach. You can see it here. So pillar A sort of is the big federal funding program, probably many of you have already heard of, for model project smart cities. Leipzig is also a part of this funding program, so really the federal government has invested a lot here. For a lot of smart city measures to be developed and then shared by the principle of public money, public code across the landscape of Germany, but also potentially really to international partner cities. And so that's sort of the mothership, maybe you could say, of the big smart city approach in Germany. And then to make this whole effort of scaling a little more structured and concrete, further ahead, there is the pillar B of the so-called step-by-step plan smart cities and regions, and that's really a process of further streamlining and finding new institutional frameworks and arrangements to transfer and scale the solutions around. And then the pillar C really in the red frame, that's us. So we are sort of commissioned to help in the international knowledge transfer, so to bring solutions that were developed the world over to the German ecosystem and the other way around. So maybe a little look at the rationale. I mean, I've touched upon it already, but why really does a federal level want to push and support international knowledge exchange in smart cities? Because there is a clear acknowledgement that digitalization also in urban regions is a clear challenge beyond G7 countries or beyond the club of rich countries. There is really a lot of multilateral communities that have discovered the topic. Digitalization induces paradigm shifts and really fast-paced transformations. And there is a lot of valuable lessons, notably also from very ambitious countries that maybe don't have those rather rich contexts that we are operating in. And sometimes they can give us really also a decisive idea to advance in our projects here. So in short, the International Smart Cities Network is sort of the international gateway for the German smart city dialogue and activities with the world in both directions. On the right side, you can see a report, for example, that's an example of this. We did a conference in Nairobi last year where we brought together precisely several countries and actors from the world. A little glance into our network. So these are in different shades. I won't go into details here, but the countries that we have contact with and that we're inviting over to bring an exchange on their solutions. And this is the components, the stuff that we actually do day to day. So there is an advisory component, but then the core of it, and where we had, for example, support from Leipzig and many other cities, is really to set up a lot of learning and exchange formats for practitioners on all governance levels in various ways, and to also establish other knowledge formats like studies, hackathons with universities, podcasts, you name it. Maybe on this slide, and that will mark the end of the short introduction of the Smart Cities, International Smart Cities Network. This is sort of the way ahead also for the German government, you can say, right? So you want to really now consolidate all that's been developed into maybe 3 pillars with which you can scale across the landscape in Germany and the world over. All these solutions that were created. So from left to right, you can see basically the way you want to read this table is that there is an initial informatory aspect. That's the Smart City Dialogue platform right here. You gather sort of all solutions, all things that go around. And then sort of it gets a little more complicated in terms of how you can present those solutions, but the idea is that once you have put the solutions on this pillar, on this platform, it can actually be scaled a lot more quickly because a lot of conditions have already been pre-mapped. So in the middle, the open code platform is really gathering all the open source solutions and shall streamline them and make it easier for other countries and cities to take it up. And the marketplace really invites also the commercial side to offer their solutions in, I think the ultimate vision is in sort of an app store context, so that really many communities and municipalities can pick it up very quickly. But that's just a general intro on who we are and what we do. Happy to continue the conversation on that. And now more generally, a look at development paths for data ecosystems globally. I want to start with I think the concept that many of you have heard already, and it's the concept of leapfrogging, right? The most famous example for that, maybe it's the graph on the left side, is the scenario that a lot of African countries have sort of entirely skipped the development step of introducing landline for telephones, right? Because, I mean, it's a huge continent geographically. It would take a lot of resources to establish landlines with cable and so on. And by the time that this became really an urgent challenge, we had already actually mobile technology. So naturally and excitingly, many people just realized I don't need landlines. And you can see this really here in the graph, right, with all the subscriptions. But it's not only something happening for telecommunication, it's also potentially and already happening for the energy supply. So luckily also for us rich countries that have been industrializing our communities through fossil fuels, luckily many communities in the global south have the opportunity to do so by skipping the fossil fuel age in some parts and directly commence and begin their electrification with renewable energies. And a picture for that is, of course, the solar panels here. Two more examples, maybe a little more recent, right? There is an article describing how Starlink, right, Elon Musk's internet provision, is really taking over Africa's largest Wi-Fi market in Nigeria, right? So the big sort of also private and commercial telecommunication providers, they weren't apparently, for the demand of the people, strong enough in rolling out Wi-Fi. Now there is Starlink with a very simple setup, and people en masse turn towards that solution, and we suddenly have a completely different market. And the last example also, I mean, in its early shoes, but I think also something that's very interesting is, of course, the deployment of AI. And so it looks like there might be also a dimension of leapfrogging, maybe even, where AI becomes a more effective and a more scalable teacher sometimes for very remote regions to pupils. And you see this graph, I took it from The Economist, right? But where there is first research on how, for example, AI tutors compare to schools that are deployed and teachers and tutors in such remote and lower resource contexts. And so what we want to do here, or maybe think about, is really, I mean, these are sectors of energy, of telecommunication, a very classic thing. And it's B2C markets essentially, right? So you can leapfrog in contexts where there is already clear customers and a market of sorts, and you can then jump over it and just directly address customers, often individual customers, with an offer. But is there a way of translating this notion of leapfrogging, of making really quick wins and skipping a lot of dreadful development steps for creating smart cities in between? Is there a way of doing that also for data ecosystems, of doing that also in the cities? And one of the challenges of doing so is, of course, that a common good-oriented smart city development that we are all, I think, seeking here has obviously polities or municipalities as quote-unquote customers and not individuals. So of course it's a whole different way of negotiating a supposedly skipping solution, right? Rather than just putting Starlink in the shelf and suddenly it's cheaper, more reliable. There the decision making is very quick, very easy, and that's why it's so massive in its transitional capacity. And what I also am trying to describe with this graph is that we have very different dynamics for data availability between public and private. Let me lead you through this stylized graph, really. So the idea is that throughout time, we have, of course, a big rise of available data, but there is, of course, a very different pattern for the private side, the private sector, and the public side as to how to have accessibility to this data. And probably in earlier times, the public side, the administrations, they were the ones, you know, maybe the bureaucrats also who went around and did the first recordings, but very quickly actually the private sector overtook in its capacity to amass a lot of data. And so clearly we had a little blip with the open data movement and crowdsourcing, you know, that suddenly unleashed a lot more data for the public sector as well. And we have luckily a lot of good effort to actually have more access to the public sector for data as well. But for every of those public efforts, really inspiring efforts, we have a massive velocity on behalf of the private side that is a lot faster, a lot stronger. So I try to coin it in this way. For every open data movement that we established in some cities, right, people at the same time had smartphones in their hand that were collecting a hell lot more data than open data movements could possibly do. The same is now with the EU Data Act, that really is some, you know, new legislation that finally managed to motivate more data sharing. And basically at the same time now we have AI use and AI analytics that just even more explodes the available data for the private sector. So what I only want to actually say with this slide is that we should always mind this gap that does exist, right? So why we can be ambitious on the public side, on the common good oriented side, to leverage the increasingly available data, we should also keep thinking about how we can narrow this gap through data sharing, both through regulation and through market incentives, because if this gap widens, of course, that implies also big power gaps. Yeah. And well, this brings me basically to the question, or just to a very brief association and discussion, what are data gaps, especially in low resource contexts, that do exist and that could be maybe potentially leapfrogged if we access new data sources, right? And a couple of weeks ago, I've been, for example, to Dakar in Senegal, and there you still have the situation that actually you don't have official public transport schedules for some of the means of transport. You don't have the so-called GTFS data. And in the past, I think also in German municipalities, this is something that has been done by bureaucrats, right? But now and today we have means where we can achieve that potentially a lot quicker through new technologies, and so really close this gap also between global north and global south communities in different ways. The same goes for data availability and analytics and patterns of energy consumption. The same goes on understanding household size. I think Leipzig had also an AI application that was counting floors, you know, something that prior to that was being done only by experts, and so on and so forth. So let's take this discussion here maybe also further ahead down this event today to really think about some of the data gaps that really exist, that are very banal in a way, but very important and need to be closed very quickly so that we can achieve a very good development. And then lastly, to kind of bring this together once more, I want us all to empathize basically with this evolution that happened in our data ecosystems with the example of green infrastructure management. So we all continue to have sort of the questions of how many and what trees exist in our community. And so the past way, but still also current way of answering that is through tree cadastres. We see the city of Leipzig, for example, has also put it as open data on platforms. Then we had approaches and have currently approaches that really also entertain human crowds and people as sensors, right? That can at the same time collect data and also use sort of the call to action from this data and become active on it. When they, for example, like in this app that we're showing on the bottom right corner, really educate themselves on the available trees in their city in Mexico here, or like we have in Leipzig and Berlin, take care of trees in their cities to support the strained capacities of public administrations, maybe in caring about the trees. And now really the exciting world, I mean the experts on this have already talked, so I don't want to be too long on this, but is really that also algorithms come into play in their sensory capacity, so they can very quickly do a lot more analysis and really collect data in a much more rapid way. I brought with me here a screenshot from the Bakim project on the bottom right corner. It's also a funded project in Germany from Bamberg, right? That's also using drone imagery to detect trees that became ill, that are struggling. And on the bottom left is an MIT project that actually used Google Street View, so readily available data, but to actually have another vector of understanding how much greenery there is in the city, because you simply ask the algorithm, the AI, look for me at those pictures, where do you find green? It very rapidly, translates this into raw data, and off you go, you can use it. So what this all means effectively is that we can now, in a new way, I believe, and that's also a perspective from GIZ and I think from many actors here, configure these three big blocks of, for once, using experts and devices, as a second point, human crowds and people really engage, of course, the people in our communities and algorithms in a way that can let us have data fundaments in a much more rapid way. But the caveat for this is, of course, for sometimes low-income communities in the global south, that the very left block, right, the one of experts and traditional devices, that's the one that costs a lot of money, right? So we have sensors, for example, if you want to create, say, traffic data, right, that still costs between $500 to $5,000 even, right, to count cars in a traditional way. That's a lot of money for emerging cities in those kind of contexts. Now we can achieve kind of the same thing in using an algorithm and a simpler CCTV camera that costs an order of magnitude less, maybe only $50, right, to achieve the very same thing. All this to say that there is just a lot of potential in reconfiguring these things. And what's important to say about the algorithms as well is, of course, that we can make use of the legacy base that has been created by rich or high-income communities, by which I mean the training sets sometimes for those algorithms. They indeed can come from tree cadastres, right, from maybe richer German municipalities, because luckily they did the work in the past, and we can train algorithms with that. But then for a low resource context maybe, or a lower income context, we can use the algorithms first, right, and then we have basically a full circle, and then adjust the training set for that as well. That at least would be the vision for it. And with that, I just wanted to summarize it. So I think we have an emerging coffer, or an emerging bag sort of tools to be using to achieve really smart city initiatives with a lot less resources and a lot more rapidly. If we use, for one, the records and the informational storage that exists already, and use it much more aggressively. Examples of this is Wikipedia, Wikidata, the public statistics offices. They get better and better, of course, in showing that data. Our World in Data, the project, is also an example. Then more broadly, data sets that are given in open data portals, sometimes even presented already in data spaces. And I listed here also the project from the German Federal Ministry for the Digital and Transport, DASEN, which is sort of a data space of data spaces and helps us to more rapidly research through all the data sets that lie somewhere in data spaces already. So that's a building block. And then lastly, now excitingly, the whole new toolbox of repositories for code, open source software, and of AI models. Certainly for these, the most popular ones so far are GitHub, Hugging Face, and maybe for the public side also really open code that's been established. I don't want to run you through this list. We can look at those examples maybe if we have the time, but I try to bring together. I think that's the important work of consolidation here as well, and that we need to continue to exchange on to really seek what sort of projects from the public, the civic and private side do offer us already data with which we can rapidly work, so that we don't have to do it, from zero ourselves. So we had already talks about satellite data. there is a very exciting new data set from the University of Munich, I'll get back to the list, that really amassed for the first time a data set of all the buildings that exist on the world. How exciting is that, right? To even have a precise figure of that and to be able to actually then maybe generate now rapidly digital twins, at least in level of detail 1, for every corner of the world, you know? So it's just to give you an idea of the potential velocity that we have here. And then there is also increasingly data sets from some parts of the world that can be used to train algorithms and improve algorithms for your context as well. You see one example with the TACO data set in the bottom left, right? So this is really a library where people essentially just bring pictures, right, of rubbish they see on the street, they catalog it, and that's a wonderful data set to then continue and feed with pictures from your context. And then number 8 is just an interesting example also where we see the private sector sometimes can be an ally really. So Foursquare, maybe some of you know the app, it's very popular in North America. It's like a rating app like TripAdvisor or something, I believe, for restaurants. They have open sourced their tremendous data sets of more than 100 million data points of interest. And you see one example, I just took it from a blog, right, where somebody made a heat map of a certain cafe, you know, and how it scatters around the world. But I'm very sure that there is a lot more that we can quickly find out and analyze through these type of things. So to conclude, maybe really my main messages for you and the ones that I'm gladly willing to discuss here is that we really need to keep telling ourselves that there is already a lot out there by now. So we had a lot of great efforts, notably from European countries, from many countries the world over, that were committed and are committed to a digital public good. So let's make use of that. And then there is indeed leapfrogging potential for smart city data ecosystems globally, for example, through computer vision. That means through AI looking at pictures, you know, much more rapidly than we could do. But, and that's really the very, very big and important but, we shouldn't think that this, you know, is the only way to go. We should always bind it back to crowdsourcing and local ground truth validation with public officials, because of course, if we just let the whole analytics being done by AI, we're not gonna end up where we wanna be. I think a very good example of that was the very brief discussion only in the earlier talk today, where the AI analytics, you know, from the bird view found different values of trees in distress from the, you know, greenery experts in the city. So there is a delta, but we need to bring those two into conversation. We absolutely must not, you know, now because of the whole AI hype, only follow the results of AI analytics. So it's really about combining these aspects of the toolbox. And then more practically, really, just I want to be frank here, I think there is a lot of potential to bring municipal corporations closer to code. So of course we talk about governance, about qualitative things, but I think there is a lot of potential really also in bringing the techies together and really exchange between municipalities also on the data science level of things and the code level of things. And then also with a look to, for example, my organizations and other organizations there, I think it can be even more that we collect and share data also of projects of development cooperation and international cooperation by default. I hope I haven't stressed or overstretched the time too much. Lastly, thank you very much and happy to do the conversation with you. Please join us, please connect with us so that we can continue this journey.
Thanks a lot. So I'll have to switch presentations. I'm not sure how it works.
Maybe in the meantime, is there some very urgent questions of understanding? I think those maybe, Christoph, we can take up while you transition. Otherwise, of course, we'll have the broader discussion afterwards, but
well, okay.
Okay.
Well, I take over. And thank you for your genuine international perspective. I think by design you're working for an organization which works international, which has an international scope. And now I'll say a few words about our city's perspective. which is by design not international. So we don't have the task to do something besides our own city, but we can do, and that's what I want to explain to you. I want to take the example of our digital twin project and show you on this example what we can do regarding to knowledge transfer and prototyping. We have a big project in our digital city unit and in the city of Leipzig as a whole. It's about digital twins, and I won't go too much into detail what digital twins are, because tomorrow we have a whole day where we can speak about digital twins in our smart city lab. But as you might know, we are working together as 3 cities, Leipzig, Hamburg and Munich, on different use cases about digital twins. And it's all the time regarding to processes of urban developments and integrated urban development. It's about simulation, collecting the data, bringing things together so that we as a city are able to use digital twins in different use cases. And one of these use cases I brought with me, it's one that we've done here in Leipzig. It's about interactions in urban planning regarding to childcare network planning. So our question was, where would a childcare institution be necessary? Where is the best place for a new childcare institution? And regarding to that, we had the task to collect all the necessary data to know where do the young kids live and how many kids are already in the childcare institutions we have, to generate a data model and to generate a kind of dashboard which we can use to predict where such institutions are necessary. This is one of the use cases we did within these digital twin projects, and I think I can say we are using it now productive. So we are using it in our administration to predict and to look up where childcare institutions are necessary. How do we do this in the projects? We have several sub-projects, and I don't want to explain all of them to you because it might be boring and you might hear it tomorrow, but one is important, and that's on the upper right side. It's replication and knowledge transfer. It's really a speciality of this project that we have money to do something regarding to knowledge transfer. It means to talk about what we are doing to other cities, to share our experiences, and also to promote replication. It means to promote that what we did in the project, coding, producing source code, something like that, yeah, sharing this with other cities or other communities so that they can use it. And so we have a sub-project, and in this sub-project we have a whole bunch of formats with which we do these kinds of knowledge transfer, and I only want to talk about one of these formats, and it's called the Cat Academy. Cat Academy is a format within which we are producing every month one short video. It's about half an hour, and it explains different news, but the latest news from our projects, from different people and different perspectives, whatever we have done within these projects. We are very lucky, all the videos are in German, but we are lucky that we have English subtitles, and that's why you can find the URL on the slide here, which leads you to the page where you can find the English, the videos with English subtitles. Yes, the subjects of all the Cat Academy videos are organized along these 5 sub main topics of our projects. And here is a slide, a screenshot of the Cat Academy if you like to look there. I said that we share our code with other cities. We share the things we do with other cities, not only the experiences via the CAD Academy, but also our results, the code. And we like to do it, but also we have to do it, because it's part of our funding to do it. And where do we do it? And I already mentioned it, it's open code. And open code is a platform, and you can see here a screenshot from our GitLab repository on open code, where you can find all our project resources. And what does it mean? We as a city publish there our project results, and we also are able to use the results from other cities and try to use them to make something with it. And that's not so easy, because it's not that clear how is code quality, are these really working softwares. And we had the task to find out how can we test these softwares, and that's why we created something that we call a prototyping platform. And you can see a screenshot, you can see a photo of this prototyping platform, and whoever of you will be in our Smart City Lab today or during the next days can see it in real. Of course, there is the place where it stands. And this is nothing less than, let's say, a small IT cluster. We can do everything with it, what is possible with a whole IT infrastructure of the city, but in small, to prototype and to test different solutions. And that's in several ways it's good for us. On the one hand, we can test what other cities did, but at the other side, we also can test our own products and our own code before we gave it to the rest of the world. And regarding to that, at one hand, sharing our experiences via the CAD Academy, and on the other hand, being able to give our software away over open code and to test and evaluate software of other people's. I think these are the things a city is really able to regarding to knowledge transfer, prototyping, and replication, besides the thing that it's not a genuine task of a city to promote and support other cities. And I think, if I'm right, we are also using this prototyping platform and within our collaboration between Leipzig and Lüderitz. And I don't want to speak any longer. I want to hand over to you, Beate Ginzel and Chancellor Ballau, to explain what you are doing. I think you also prepared a little presentation. Then now is the time to switch.
Okay. First of all, what?
Sorry.
Welcome. And
does it work? Please.
Yeah.
Yes, there is.
Yeah. Phil, would you like to introduce us to
Hello. Well, good afternoon, everyone. As you can see in this picture, is one of the most beautiful places in the world. It's my beloved town, Lüderitz. And as you can see there, this is the Velserkirche. It was imported by ship in the year 1908. It was first assembled here in Germany, shipped to Lüderitz, installed there. The windows are amazing. They were a gift by then the Kaiser. So that's a very significant building, and I want to invite you all to come and visit us in Lüderitz, because not only is it a beautiful place, there's a lot of excitement. And that's really how I got to be here today. So it all started out with green hydrogen, and I think you probably heard that quite a lot in recent years. The German government, in cooperation with the Namibian government, have basically done their research and found that Lüderitz is the third best place in the world for green hydrogen, because it's super windy there, very, very sandy. So the solar and wind potential is immense. And that really was the catalyst event which unlocked everything else. I don't want to go into too much detail. I don't know exactly how much you want me to share, but that's really where GIZ came in. The town is going to develop very, very rapidly. 15,000 laborers are expected to come construct this hydrogen plant, and if you consider 1 or 2 of them bringing their wives and kids along, our town's population will probably double in the next 5 to 10 years. And that really puts a lot of pressure on a very small local authority like ours to be ready and not to leave anybody behind. I think that's really what we're most afraid of, is our own inhabitants, with everybody coming and all of this excitement. How do we make sure that our people are incorporated and looked after? And that's where GIZ identified 3 different pillars that they would like to work with us or are working with us. The number 1 was the just transition, and that is making sure that people have opportunities, people are upskilled and provided opportunities to participate in all of this excitement. The second one, and that's really why again, I'm with the city of Leipzig today, is capacity. That small municipality of ours just doesn't have the capacity to do a city-scale project like this. It really is what we call a town transformation. You really have to change so much about this little town to turn it into a city. And that's where GIZ then also said, listen, we'll come to the party and we'll help build the capacity of your staff, but not just the capacity, but also the tools that we need. And the third one was the spatial planning and urban planning of this massive, massive project. And on top of the green hydrogen, there's many other projects that all happened at once. They discovered oil and gas just off our coast. There's 2 massive salmon farming projects, a huge kelp farming project, lots of aquaculture projects, manganese, beneficiation. So if you can imagine, all of a sudden, this little town is spinning on its head to be ready to accommodate all of it. And that's how we came upon Leipzig. We sat at the airport here in Leipzig one day waiting for a flight that was delayed. And I was Googling Leipzig because being curious. And that's when I stumbled onto the Leipzig Charter. And when I discovered that and I started reading through it, it really chimed with me. I thought this is exactly what we're afraid of, is urbanization, de-urbanization. How do we plan for all of this? And going through that charter and seeing, that basically the whole Europe was on board, we thought, listen, said a little silent prayer. I hope we can get somebody like this on board. Never in our wildest dreams did we think Leipzig would actually be interested in us. So I put the message out there through GIZ, Thomas Hennert, a representative who's in Namibia, and told him, listen, go and look for a partner that can help us with this. And he approached a couple places, but Leipzig was number 1 on the list. And to our amazement, and I'm still really stunned that it materialized and happened, Leipzig said, listen, we'd like to work with you. We think we can add value. And hence, this is why I'm here today. Really, really excited to tell you a little bit more about the amazing work that we're doing now with Leipzig, bringing Luderitz, and hopefully one day, when we're the big brother in the situation in our country, we can pass this knowledge on to other local authorities in our country. So, we learn so that we can teach. And I think we're really in a privileged position to have such amazing support. So without spending too much time rambling on, I'll hand over to Dr. Viate.
Yes, thank you, Phil. And of course, for us, it's a great pleasure and an honor to be able to cooperate with you, because it's every time it's a mutual learning. And I don't have to talk about the transformation process Leipzig ran through in the last 20 or 30 years. So actually, we can say the administration of Leipzig is able to coordinate, to plan, to create a transformation process under really complex circumstances. And that's why, of course, there are lot of colleagues in this town hall who are the perfect cooperation partners for Phil and Lüderitz. And there is a Stefanie Komm from our urban planning, urban development department, who is involved in this support or this cooperation team, in this joint partnership between Leipzig and Lüderitz. She's not here today, but she is from the urban development point of view the most important part in this cooperation. And the department or the digital city unit I represent today, we are somehow supporting unit and we try to support Lüderitz with the provision or with the development of a digital twin. And the mastermind of the digital twin is sitting there. It's Karl. He's a student working for us in the digital city unit, and he is our GIS expert. Of course, we have more GIS experts, but Karl is the GIS expert in the digital city unit, and of course we have project manager in our digital city unit who support us with the infrastructure. And what we have learned that the open source principle we are running or we following in our own digital city program. This is actually the point of origin for the cooperation between Lüderitz and us, and maybe we will talk about later on. But these are the main action fields we are working on. Collecting or building or developing a digital twin for Lüderitz, focusing on the development questions Lüderitz is facing in the next time or already now, and then based on this there will be different activities like participation processes in Lüderitz or supporting the urban development department of Lüderitz, which are really motivated and well experienced colleagues in Lüderitz as well, Helena and Jonas and all the other experts, and that's why we are a really good team, and it's everybody's learning. I think for us it's really nice to test our own blueprints, whether our solutions are replicable or not. It's for us, it's great to use our pop-up platform Christoph has shown, and which has been developed by Sebastian and Jan Beckert in this here today as well. So it's a big learning and cooperation process for both of us. So that's why, thank you for this possibility, Phil.
Well, thank you. I think now it's a good time to open up a bit, and I have some questions to you three, and we also can include the audience. Maybe you have questions too. But Philipp, Chancellor Ballau, what has helped you most in these cooperation? What is the main benefit for you?
That's kind of an easy one. We had many sleepless nights with this massive responsibility, and you know the impact on people's lives when you don't plan properly is disastrous. So I knew that our team just didn't have the full capacity and tools to do this massive project. And when we finally found that we have partners with a proven track record, the experience, the tools, it brought us a lot of peace of mind. I think the peace of mind is, sleeping well at night. That helps a lot. So yeah, it takes us years and years into the future. This GIS program that we're working on right now, we've made so many silly mistakes as a local authority because we were working on antiquated systems, working with hard copy documents, so double allocations, things like that really takes away from the progress we want to make. So I think once we implement this tool fully, it will not only help us as a local authority and the administration, but it really is for the stakeholders, our investors, our residents, to make sure that we have tools that really speaks to their desires. So at the end of the day, I think that's the peace of mind that really helps us sleep at night.
Okay. And you can add.
Maybe because you were asking for the benefits, I mean, we are still in the beginning, so that's why we have to fulfill the promises we made to fill. So maybe you should ask us in 1 or 2 years, then we can, it's more, then we can say more concrete what kind of benefits the project has.
Beata is forgetting it's an election year back in my country, so they must keep their promises. But no, it really, it really does help us just knowing that we're moving in the right direction. I think that has been a big fear, and finally it's not a fear anymore. It's something that we're actively working on, and it really brings a lot of peace of mind.
Well, I will take her seriously. I will ask her again. But Beata, why is it in our interest? Well, how can we benefit from such a kind of cooperation?
Maybe I already touched the answer, because for us it's really interesting, because we, as you have shown, this project of connected urban twin and replication and knowledge transfer is a very important work package for us. You are the package leader, and regarding this, for us it's quite interesting to see whether we can replicate our solutions to another city, as we already do to smaller municipalities in Saxony, to the Paterland. But this is, of course, this is a much more interesting cooperation between a city, between Lüderitz and Leipzig, and it's much more direct way, because it's a small municipality, and maybe we can see much more faster what can be the benefits of digital twins, for instance. So, and our procedures of how to develop digital twins, we tested with in an international context. It's almost run by digital meetings or online meetings. This is of course, this is a different experience for us as well, even if we are used to sit in online meetings. And just to learn whether our solutions are replicable or not. And are we able to share infrastructure like this pop-up platform? And are we able to share the drone technology? Can we provide a drone temporarily to Lüderitz, and then we can integrate the data in the Lüderitz twin here in Leipzig, provide the data to Lüderitz again. This whole transformation processes of data, or transfer processes of data, this is a big learning process for us as well.
Thank you. And what do you think about this kind of collaboration? You talked much about leapfrogging. Is this an example for you where you think, yeah, that's a way of how leapfrogging can work?
Maybe, I mean, we'll see, but I think, yeah, we need exactly those kind of scenarios, and I think it pays off between the cities already. I mean, that's maybe the most important to see, because you guys are directly engaged in it, but I think also in more or broader terms, it's very important that these sort of things happen also as a counter or as a complementary for those public good solutions to, for example, go through evolutions, right? So if solutions like the ones Leipzig developed are being only developed within 3 German cities or so, they're gonna end up in a different way compared to a scenario where they are replicated really across the board, right? I mean, the big digital titans, that's what they can benefit from, right? Because it's being deployed everywhere and everywhere. And so we, of course, need to find a more concentrated way of doing so, but then we'll have definitely payoffs of that, I think.
Okay. Philippus, maybe one more question. You said there is much where you can benefit from doing things together with us, doing things, learning from each other. Is there something what didn't work out? Is there something where you realize, oh, no?
They didn't want to give us the drone. No, I'm just kidding. No, so far, and it's again, we're really in the beginning of this long journey together, so no, there haven't really been any, I guess, disappointments at all. I think so far it's been, I think it's more challenging for Leipzig to work with us because we don't have all the data that you need. We as a country, I think catching up to the rest of the world. The rest of the world have been digital for so long. In our case, bringing in these digital tools only now means that we're really far behind. So obviously, I think it's much more challenging, and that's why I always advocate and say that I think Luderitz is an amazing case study for universities, for institutions to come, because we have a unique set of challenges there. As you can see, that little town there, the topography is not really favorable for development. It's very, very hard rock. You always have to blast. So installing services is very expensive. Then right there at the very top of the picture is Shark Island. It was the first site of the genocide that happened in our town. So you have the indigenous groups and heritage importance that really makes it significant. How do you overcome this, and how do you make it inclusive? How do you make sure people have a say in what we don't want to plan for the people, we want to plan with the people. And it is always such a cliche sort of slogan, but when you put it in practice and you go out and you engage and you make sure people have an input, they really buy into it. At first, I think there was a lot of negativity about what's going to happen. Are we all going to get left behind? These people are going to come take our jobs. But since we make sure that they have as many platforms as possible to give us their inputs, to help us plan this all, and I think me and Beate was just saying that's the next process that we're really looking forward to later this year, is to go from neighborhood to neighborhood and help, or ask the community to help us populate this GIS program with factual information that we don't have right now. So yes, no, there haven't been any disappointments yet. I think it's really been such an exciting experience so far. Looking forward to the rest of it.
And maybe I can add that, as long as you are our replication manager, you are our city for digital rights director, and you are also involved in the development of our digital participation platform, you can, you can, I would say, assess that all our important activities together with the city society, we can also replicate or provide to Luderitz as well our experiences. We, as Phil said, most people have no access to mobile internet or mobile phones. How are we able to involve the inhabitants in the informal settlements in participation processes? This is a topic we don't meet in this, let's say, in this extent in Leipzig as well, but we go out with our digital participation platform into the different settlements in Leipzig as well. So we are somehow experienced in this decentral local participation processes, and we can again we can use these experiences and this infrastructure, this digital participation platform. We can also use in Luderitz.
So what do you three think regarding open source and the development of open source software? I mean, we as a city, we often debate about open source, and is it a good thing, or does it cost us too much? Does it mean too much work? Is it worth investing in open source software? Now, with this connection in mind, is it a promoter to develop as open source and to develop more open source software? Of course, we see as a city, okay, we can create something others can use.
Yeah, I mean, the basis of the digital twin for Lüderitz is open source software, QGIS. Yeah, we wouldn't be able to provide a license of our ArcGIS system we also use here in the administration. We can use QGIS, and as I have learned, this is the open source software for urban data platform in the global south. So that's why we have it's the open source software. It's an easy access for administration in the global south, and in the same time we have a high interoperability, and we were very easy. It was very easy to start to operate it at our proper platform, to provide access to Lüderitz, and so on and so on. So that's why in this case open source is the point of origin.
Yeah, absolutely. I think that's desperately needed to kind of continue reinvigorating the motivation to continue with the open source path. I mean, it's kind of ironic, right? We had like a big hype of some like hippies, activists who were always excited about it. Now they have a little bit of their I told you moment because maybe the US administration has changed. But nonetheless, this will always remain a contested issue. So we need concrete examples where this has worked out. And on a more general note, I mean, I also wanted to stress, make no mistake, this is not a one-way road here. So for example, German municipalities, it's very important to test all this out in a context, because we may or we are ending up also sometimes now in contexts where suddenly our resources are non-existent anymore. We have a strong demographic change. We will have disasters probably through climate change and so on and so forth. So all this really will be a big win for us as well, to continue the practice of not depending, on some big only remote solutions, but really continuing with leapfrog solutions as well, learning from them, and then maybe we will be in the situation and the need of using them in the same fashion.
If I may, with us playing a catch-up game, trying to digitize now, there's obviously a little bit of fear if I speak with my team. They are sometimes worried, like, how much information should we share? Is this relevant to what we're doing? And I think it comes from a good place. It's the lack of experience, it's the lack of exposure, the lack of knowledge. But from the previous, or the first keynote that we were watching, one summary that I made from it is that, there's so much open source information out there, but there's still so much we don't know, that I think, again, in our case, sharing that information freely, 5 years down the line, we'll thank ourselves for it, because we've enabled Leipzig to help us make much better informed decisions while they try and give us advice. And I think that the fear it comes from a good place, because we're working with sensitive data, it's people's information, but I think we've also gone through it in our MOU, that the intellectual property sort of clauses and all of that. So there's ways of protecting your intellectual property, the same that Leipzig, your information is also protected. But I really feel it's an enabler, and we need to embrace the opportunity.
Maybe I can add one more question. I asked more with Leipzig in mind, if it is worth it investing in open source software and creating more open source software to offer it to other cities. I know it's the beginning of the collaboration, but what do you think? Will it be easy for you to implement open source software we provide or we advised you? Would it be easy to implement it in Lüderitz?
Yes, well, that's already been the experience. The Street View, I think it was the first open source tool that we started using, and then we moved on to QGIS, and it's sped up this process massively, and it's made it accessible to us that we don't have the funding as a little local authority. Years down the line with all these amazing projects, yes, we're going to hopefully be a little Dubai, but until then, we have to be realistic that we have serious challenges as a little town, and getting access to these tools was not within our ability, unfortunately. And thank goodness that we have people like Leipzig or institutions like Leipzig that are willing to share information that obviously costs them dearly. I again, referring to the first keynote, we have similar projects in Lüderitz. So wind farming is a big thing in Lüderitz. Again, like it's one of the windiest places I know. So now we have a company called Innovent, a French company that have had this wind farm there for the last 5-6 years, actually more. And access to that data is impossible because they've spent so much money on it and they try and protect it massively. But it's not enabling us to attract more investment because we have this big hydrogen project now, and that data would have really come in handy because now we're spending 2 years just on gathering data for the hydrogen project where the data is available and it just should have been accessible. And I think that is where we'll enable again ourselves and hopefully others to make informed decisions.
I'd like to give the audience the chance to also ask some questions. Are there any questions, ideas so far? No problem.
Maybe also more. Oh, I saw a hand was moving. Yeah.
I come to you.
I was just wondering, because you were talking about potential for solar energy, solar wind potential as well, but also about, urbanization or like people moving there, but where does the digital twin start? Because you also talk about scarcity of data there and infrastructure lacking, so now I'm thinking about what use case does where does the digital twin begin, or where does the journey begin?
Yeah. Well, like I said, the town is going through this town transformation, initiative. It's going to have to change very rapidly, and the first thing that we realized is the spatial planning. So we're applying for a lot of land right now. We're expanding our townlands to accommodate everybody and all these projects that's on its way. Because literally what you can see in this photo is almost all of our townlands. And it was really difficult without a digital tool to do proper planning of where do we put certain industries, where do we put residential areas, and how do we make that a mixed-use area. So I think that's really again the catalyst, the thing that got us thinking, listen, we need a digital guide to make sure that we can properly plan as where are the servitudes, where are the green spaces, where are the public open spaces, so without that tool, it was almost impossible for us to really plan it properly. And I think that's really the catalyst that got us thinking.
And just to add, what we identified as our focus was the urban development, not the energy transformation, not a green hydrogen project, and so on. Because as we recognized together with the stakeholder in Lüderitz, was that the first question Lüderitz has to answer: how is the city able to provide housing for the newcoming people in the already urbanized area? Because it wouldn't be a good idea to have a second settlement in somehow in the desert with a distance to the city center. So this is a kind of integrated urban development to answer questions: what potential areas do we have for densification in the city? And as you can see, it's a quite different settlement structure to what we do have here in Leipzig, and that's why there are questions focusing on the heritage areas in the city, the informal settlements you have in Lüderitz. So the focus is on urban development and not on energy transformation, what would be the focal area maybe here in Leipzig, comparison.
Ah, yes.
All right. Yes.
Good afternoon, everybody. I'm Stefania Paolazzi from the city of Bologna in Italy. And we are also developing a digital twin, also paying attention to civic matters. It means not only having like infrastructural data, but also trying to catch and model also behaviors, citizens' behaviors, and how citizens can react to public policies. So I wanted to know if you also have this dimension of local communities' participation in the development of your digital twin. This is the first question. And the other one is, how do you manage data governance? I mean, we can talk about this a lot, but one thing that I see a lot is the importance of data quality if you want to have a good and reliable digital twin. So I was wondering how you manage this issue of data quality. Thank you.
Thank you. I think I can take the first one, and then Beate can take the second one. She has the PhD. Sure. Beate, can you tackle the first one? The second one, I'll quickly just think about what I...
Okay, data governance. I mean, again, we have a data governance model here for our administration in Leipzig. We have defined roles, structures, procedures, rules, and so on and so on. And in the same time, you can't replicate it to Lüderitz in that way, because the number of staff members in Lüderitz is much more smaller than in Leipzig, and maybe there is one person responsible for urban development, for data management, for and so on and so on. So it's and that's why we are still on the beginning. And I would like to share. I try to share, if it's okay for you, our Miro board. We are just to give you a understanding of. One moment. Switch off this, and I try to. Oh yes. Oh, okay. No. Okay, but this was really. No, not this. Yes. Here you can find our Miro board, and I understand this is very complex, but you can see our path of development. We had a kickoff. We start to identify what is the current situation of land management, what are the most important questions, what are the stakeholders. Then we start to talk about the project goals of the digital twins, and as Phil already mentioned, the must targets is first of all scenarios for the infill and densification and the implementation of the new inhabitants, and then we start to build the digital twin, and we raised or identified the most important questions. We start to get an overview over the data, which data are needed. And then we checked which data are available. These are not many data which are available, but okay. And then we start to think, to anticipate what kind of technology would be the suitable technology to use, because the digital twin is just a digital twin, but sometimes you need a map, then you need a dashboard, and so on. And you were asking regarding the data governance. Of course, we start to identify the important actors in the municipality in Lüderitz, and to find out who has which responsibility and who will be involved, how in the development, in the operation of the digital twin. So. And we are still on the way. Maybe this is the most important information.
And then I had to take a little bit of time just to compose myself, because yes, The mayoral office actually have, every 4th month, I have public meetings myself with the inhabitants. But the GIZ, they haven't just gone locally, they've gone nationally to make sure the national population have an input as well. But of course, many stakeholder engagements through GIZ. But then also when Leipzig visited us, they put on a 2-day stakeholders engagement conference where people also came in, and we basically took the first step during their visit there to make sure people have a platform where they can come and ask questions, because there is valid and real concerns out there. You know, people don't understand what we're planning, and it's through engagement and information sharing where you get the buy-in from the community. And you know, I think that is paramount to our success, is making sure our community believe in what we're doing and that they support what we're doing, because without their support, I don't know who we're doing it for. Thank you.
And if I do see right, these cooperation really create some benefits. So it seems to be a good thing to collaborate in such ways. From your perspective out of the International Smart Cities Network, what do you think is needed to promote such collaborations? How can such collaborations evolve, emerge, progress better?
I mean, of course, you have to visit our events and, join us and link up with what we do. No, but I mean, more generally, I think, yeah, we need flexibility and different modes of engagement, right? I think what Lüderitz and Leipzig are doing still here is a new way of city collaborations, and I think we need to promote these, right? I mean, still many municipalities and communities with which we talk think in terms of like the traditional city partnership from the 70s and 80s and so on. And I mean, they have their wonderful benefits, but there is sometimes ways where you can collaborate on particular topics, projects, and then move on. You can engage in networks and so on. So just to say that I think we need to make municipalities and communities less shy about cooperating, just sometimes very briefly, maybe in a quick and dirty way, because still sometimes you see like the main concerns being, oh, how long is it gonna take? Is it really worth it? Can I afford, this amount of time here? And so we need to find references and really show them where quick wins do happen, where this really ripples then through your own projects and pays back. And I think we can already do that, yeah.
Okay, so then I have a final question to you three. I mean, you started in your presentation with the image of leapfrogging. So how can developments go very fast and overtake some steps and so on? And then you presented a collaboration which deals with a smart city use case, a digital twin use case. So what do you three think? Which role does a smart city development play in such kinds of urban development processes? I mean, maybe it's just the consulting between you both. You're explaining how we do things and you do them similar, but it doesn't necessarily has to be within a smart city field. It also could be anything else, yeah? So from that kind of perspective, what do you think is smart city development the important thing, or are these other things, yeah? And if other things, then which?
I think in our case as Lüderitz, when we came on board and we have all of these opportunities, it was our ambition to be a smart city, to be not just a smart city, but a green city. And that was those two were actually terms that were quite foreign to us. We weren't exposed to it before. Luckily through engagements, started learning that, listen, there's so much more that we're not even considering right now. We need to throw the net as wide as we can and see if we can get some experts on board to try and give us some more help. So in our case, I think that was our ambition, is to become a smart city, a leader in our country, but also in our region. We have everything going for us at this point, and I think if we want to have a sustainable future, this is a tool that you cannot live without.
Yeah, smart city, I mean, it's in a way the catch-all concept, right? So I think it helps in you not being the idiot that continues using the paper encyclopedia while there is something like Wikipedia already out there, right? And so that's something that happens really if you tinker around with many of those concepts and if you bring them into fruition. A smart city helps you engage with your community in a new and different way. So that's also always part of any other sectoral processes out there. So I think without, we cannot do it. And at the same time, it does help to not blindly run behind big hypes, because you can always reflect and sometimes put concrete numbers behind what the advantages are. So I think in that sense, I think you can integrate smart city really into all these movements and should still continue promoting it.
And for me, a smart city plays the same role as smart city in Leipzig. It's a supporting discipline or working area where we want to provide suitable smart city solutions like digital twins to our urban planners, to our decision maker like the mayors, to our public utilities, and so on and so on. And in the same time, I mean, I'm not originally not from the field of digitalization or from IT. I originally from the field of urban development, and this is in the field of urban development, the readiness of cities to cooperate was every time very high. So I am used to cooperate with other cities in Germany, in Europe, international, and what is the new aspect or a new dimension of smart city when smart city comes into urban development is smart digitalization has no spatial borders, and you can share a pop-up platform beyond international borders, and you can provide blueprints of digital twins to other cities and so on. And that's why for me smart city and urban development is a kind of a new level of cooperation and worldwide, and that's why it's I'm really excited about this combination.
Thank you. Already sounded like good final words. I just wanted to ask if there are any other questions. So it's your last chance. Well, if there aren't, then thanks a lot for presenting the cooperation, presenting the International Smart City Network. Thank you. Do you think there are a few more arriving? We don't know. We start. Welcome back, and hello here. We now have a session where we talk about sensors in the city, and there is a reason why we talk about it. As City of Leipzig, we are part or a member in Eurocities. It's a kind of lobby organization of the cities within Europe, and our mayor Burkhard Jung was the president of Eurocities for some time now. I think now he quit the position. But Eurocities is organized in several forums. One is a digital forum, and within these forums we worked together with other cities on the topic of sensors and how to use sensors in the city. What we want to do within this session is we have an external guest, Anna Georgieva from Eurocities, and she's connected to us remotely, and hopefully she can hear us now. Hello, Anna, because I hadn't the chance to say hello before the event. And she will talk to us and present us a bit the digital forum of Eurocities and these digital forum labs in general. So there were 4 of these labs, and we in Leipzig took part in one. After Anna spoke to us, I will present you a bit the topic of the forum about sensors, and afterwards Sebastian, my colleague, will present our Leipzig's motivation to take part in these sensor lab, and afterwards I will present the results a bit. And as you hear, it's a lot of input. Hopefully we don't need the whole time, the whole 90 minutes. My goal is to be finished or to be ready after 1 hour, so that we can go afterwards to our cities lab. It's quite nearby, it's only a 5-minute walk, and there we'd like to show you some sensors which we use in prototypes or in general in the city and explain it to you. And another thing, as for you, we have reserved a table at 8 at the marketplace. There is a restaurant that's called Augustina, and we reserved a table for you there, so hopefully we meet us there. But now, I've no idea. Anna, I see you.
Hello, Christoph. Hello, everyone.
So nice that you were here. Hopefully you have heard my explanations, so if so, then you can start if you want.
Thank you. Thank you so much for your introduction and for the brief intro you shared. I will do my best to be very, very brief, but also exhaustive. It's a real pleasure to be with you here today, albeit virtually, and to be a part of the Data Week Leipzig 2025. Really wish I could be with you in person, but with the magic of digitalization, although I'm not there, I'm with you today. And I'm very happy to introduce the Eurocities Digital Forum and the Eurocities Digital Forum Lab. My name is Anna Georgieva, and I'm a forum and project officer at the digital transformation team of Eurocities. As Christoph already mentioned, we're an international organization. We're the biggest network of large European cities, and we currently have over 210 members from 40 countries. Our goal is to facilitate the sustainable, long-term, digital, smart, and human-centered transformation in all cities in Europe. We're working on several thematic areas, one of which is digital transformation. As already mentioned, we have over 210 members currently, and we're very, very happy to have Leipzig as one of our very, very active members, and it's a real pleasure to work with the city of Leipzig. Also on the topic of digital transformation. Apart from Leipzig, around 140 other cities are also involved in the area of digital transformation, and to one degree or another, regardless of their size and regardless of the step they are on, in their digital transformation, they're involved in the activities of the Digital Forum. So what is the Digital Forum? The Digital Forum brings together cities, networks, public bodies, and experts, on one hand, to help them improve understanding of technology, on the other hand, to help monitor policy developments and voice concerns, as well as to produce tangible results and tools to support urban digital transformation for all. On one hand, we're working with cities and also providing a platform for exchange of knowledge, good practices, and experiences. One example of which is the Digital Forum Lab, which I'll present briefly very shortly. On the other hand, we're also focusing a lot on advocacy and ensuring that the voice of cities are heard on the international level, be it on the European Commission level, UN level, or other big platforms. The Digital Forum has a chair and vice chair, which are elected for a 2-year mandate. And currently, Rotterdam and Bordeaux Metropole are our chair and vice chair. But recently, we held an election, and very soon we'll announce the new chair and vice chair of the forum for the next 2 years. Of course, the Digital Forum itself has its own structure, and it focuses on different aspects of the broad field of digitalization. Apart from the Digital Forum Lab, which is led by the cities of Eindhoven and Lisbon, we have a working group that's focusing on data and AI, which is led by Barcelona and Helsinki, a working group Foresight, which is led by Ghent and Rotterdam, which focuses on the future of technology and recently also developed a methodology for scoping emerging technology, a working group that's focusing on digital citizenship and digital rights, digital inclusion, digital divide, as well as a cybersecurity community of practice. But what is the Digital Forum Lab? The Digital Forum Lab is one of our formats which offers a voluntary but committed collaboration for cities to leverage the potential of already existing good practices in European cities for common use cases. There are lots of good practices and lots of great solutions all across Europe, and often cities don't have to explore the warm water, but just need to have a more open dialogue and collaboration with other cities who have had the same experience and been on the same path as them. So the mission of the Digital Forum Lab is to drive digital transformation with tangible solutions, with the goals of, on one hand, co-create common solution from existing good practices and to provide the basis for implementation in other cities, and to use already existing solutions to urban challenges more effectively and to ensure that they're spread across all European cities. Of course, the Digital Forum Lab is also in strategic alignment with the Eurocities and the Digital Forum frameworks, and we're also working with the Living in EU movement. How does the lab work? The lab focuses on a transparent and multidisciplinary and user-centric approach, which allows for an ongoing co-creation with the receiving of lots of feedback across different iterations for the creation of standardized process and tools that could be replicated. Our focus is on co-creating tangible deliverables and solutions that would have a maximum common factor and be open source. But I mentioned lots of words. Some of them might sound a bit like buzzwords, but how does the whole process look like? It starts with cities having good practices that they would like to share. Once a year, we start a call for proposal for use cases and a call for pitches during which cities that have good practices to share can present their ideas. And later on, after a voting, they can start a lab or a group of cities based on these good practices. After the initial ideas are approved, then other cities, follower cities that are interested in further developing this topic, co-creating the topic, and developing a tangible results can apply for working together in this group to define the common requirements of the final deliverable tailored to the local context of the participating cities, create the solution, and publish the solution. The Digital Forum Lab has already had several iterations, and the process has been the same for all of them. What is it in it for cities? So for the good practice leader who has the experience and the knowledge that they want to share, they can demonstrate the experience and also contribute to the city's digital transformation through different international projects, as well as enrich already existing solutions through this interaction and exchange of good practices. For starting cities who need something, or started cities that want to improve certain processes, it's a good opportunity to adopt features of this good practice in an existing solution, or to obtain an overview of funding opportunities, to use the common good practice solution as a start for maybe other transformation projects, and also to establish a stronger connection with other cities. So just as an example, last year, the call for ideas was open to all Digital Forum members. And there were 3 key topics selected for work. Those were the guidelines for the development of a digital twin, a sensor register standard and guidelines, and an ethics board for emerging technologies. In December, the kickoff meetings and the reiterative process of co-creation began, as well as the work of the selective topics. In April, the preliminary results were presented during our annual Eurocities Digital Forum in-person event that was hosted this year by Bordeaux Metropole. And this June, very, very soon, we'll present, the groups will present the final deliverables that they have so hard and with so much inspiration worked on, and will announce also the new call for pitches. So as I mentioned, there are 3 main topics, one of which is the white paper on the transparent use of sensors in cities, with the participation of Eindhoven, Leipzig, and Lisbon. And Christoph and Sebastian will tell you more about this and the hard work from the last months a little bit later. The second topic is the development of guidelines for the development of local digital twins. And here, the city of Barcelona, together with Brussels, Köln, Eindhoven, Lisbon, Madrid, Munich, Nicosia, Oulu, Riga, and Gemeente-Utrecht, are working on developing these guidelines. Last but not least, the city of Torino, together with Eindhoven, Köln, and Helsinki, are working on the topics of ethics and innovation, and more precisely, how cities can approach this issue. Before giving the floor back to Christoph and Sebastian, this is our team, the digital transformation team of Eurocities. These are my colleagues Chiara, Gabriela, and Luca. And we remain at your disposal if you would like to learn more about the Digital Forum Lab, about the Digital Forum in general, or have any further questions. Thank you very much for your attention, and I'm giving the floor back to Christoph.
Before we continue, then Anna, thank you very much. And then if there are no questions, then I shall continue with my presentation about the Sensor Register Standards and Guidelines Lab. There it is. And I wanted to talk a bit about the topics we were covering within this lab. So what were our questions when we, as the 3 cities, Anna already mentioned us, it was Eindhoven, Lisbon, and Leipzig. We worked together for several months in weekly meetings on topics about sensors and the use of sensor data in the city. So it was about all the key phrases you can see at these slides, about a roadmap on how to implement sensors in the city, or the questions how to use sensor data. Is there a life cycle of sensor data within our cities? Shall we establish a kind of sensor register in the cities? And are there questions of maturity? That means, are there different levels in the cities, how evolved cities are in dealing with sensors and sensor data? We gave us a certain topics which we discussed. It was the question of the quality and governance of the data used for sensors, the question of transparency of sensor data. It was a strong topic of our working group that we thought about. How transparent shall we be to the citizens of our cities? How do we want to explain them how we as a city deal with sensors and sensor data? And our questions were: in which stage in the deployment of sensors should cities consider transparency measurements, or which role does the ownership of data play for sensors? You see on this list of topics that there were several aspects we tried to cover. As I said, this was done by the three cities, Eindhoven, Leipzig and Lisbon. Here you see the persons which were working together. And for that moment, I like to hand over to my colleague Sebastian to present a bit our motivation in Leipzig, what we thought we could share with our working group. I hope, yes, I'm able to start your presentation.
Yeah, thank you. My name is Sebastian, and I started 3 years ago here at the city of Leipzig, and I am some kind of data science, tech lead, project manager, and so on. When I started here, and it's still the same situation, when we talk about digitization, it's way too much politics in it. We do a lot of planning and think about what is the correct way to do things, and we like to provide you with a different approach to fasten or to speed up your project, and to collaborate, to use sensors in your real life. And we don't have that much sensors in our project, Connected Urban Twins project, but we have this other kind of approach and some examples and how it could work. Because we believe that digitization doesn't mean that we have to talk about a lot of technology aspects or programming languages. It's more about efficiency gains, the use of technology, not directly the development of technology. We have to learn new stuff. We have to be we should be able to learn new things and be bold and brave and go forward and try out some things out. And that all means that we need some kind of a growth mindset, not a fixed mindset. That means, on another way, we talk about servant leadership or female leadership or digital leadership, but not that hierarchical leadership we see every day in a normal business or normal hierarchies. And from my point of view, it's a focus on implementation. So we want to get things done. And we have an approach where we can do a sensor integration within under 2 hours. Then we see some results. Within 4 hours, we can build up an urban data platform and use it. That sounds quite fast. Or it takes 8 hours to find out if a software or like Enoch said in the session before, you can download some open code software somewhere or open source software, and it only takes 8 hours for us to test it if it works, and if it solves a problem, and if it is useful, and if it's ready to use. Because it's a difference to download some kind of software, and if I could really use it, or is it just running on that machine or on that laptop. Or another cool example was that we needed 2 days to automate a business process which lasts 2 to 3 days per month. And now it only takes 10 minutes. The people in the organization just get an email, say, download the file, drop it on some kind of web page, and then they see the results immediately. Before it was more a way like, then I have to open a spreadsheet, and then I need some converter and another spreadsheet, and copy that spreadsheet, and so on. Very cool, very crazy stuff. Yeah, my main question is, are you ready for this approach? And I'm sure you are. And you heard it before, we call it a pop-up platform. The idea of the platform had a friend of mine, Stefan Hartleib. He was born in Leipzig, and now he lives in Tübingen. And he created this idea for his diploma thesis. And you see two pictures there, the one of this box. Yeah, the whole platform is able to put in this small box, and we can send it via post or via to other cities. And if we build it up, it just takes, I think it's around about 2 square meters of tables and a lot of cables. And here you can see the whole cluster where you can work with. It only needs electricity and internet, and then we can do things like digitization. And then we can focus on the important things of our job as a project manager. It's not about technology, and nobody, in my point of view, is interested if we use a digital twin or an AI. The only important thing is, do we solve a problem? And do we deliver some value to the customers? And if it's so, then it's good. And if we don't deliver value and say it's digital twin and AI and that stuff, nobody would like to use it or pay any money for it. And the idea is nothing new, because we're just talking about prototyping. But prototyping in a different way. Because these are pictures from my career. And you know, prototyping is always that stuff that this crazy dude is doing, and it looks always very dangerous. And yeah, one picture is our pop-up platform as well. And now we have prototyping on another level. Because what we want to provide you is the idea that we do prototyping in a production level. That doesn't mean that it's a production deployment, but we always try to work with as a test-driven development, so that we only deliver code which is tested. Because in my opinion, and the last 7 years, I learned that if you don't test it in the very beginning, we will never test it again if you deploy the software. And this is always some kind of technical risk for the future, and you don't want to have it. You want to sleep at night and don't think about bugs. We like the idea of microservices, this kind of software approach where you just write small pieces of code and always can change some things and deploy the whole thing again, and don't buy any monolithic infrastructures. And we use continuous integration, continuous deployment, which is standard and state of the art. And yeah, in the core of it, it's just a Kubernetes cluster running on 4 bare metal machines deployed with metal as a service. It's Dockerized. We use some Git for version control and Ansible scripts and so on. So it's a lot of technology I'm talking about, but that's all you need. And it's a lot of things you need, and you need some people who are able to work with it and to understand it. But if you have that, then you can focus on the important things, like, is my solution helpful? Does the UI work, which I'm thinking about? Do I solve a problem? And to get back to the sensor idea, is that sensor working? And what I saw in the last 3 years of project, we wrote big plans of sensor ideas, then we made a tender and we got some offers from companies, and they were much too expensive for our budget. And then, okay, we found some more money, and then we started with some kind of prototyping with 20 or 30 assets. Yeah, and then we learned after 1 year, okay, it doesn't work as we expected. And with some kind of infrastructure in your own office, you can just do all that stuff in 1 week. Buy a sensor, call a company, buy a sensor, integrate it, see if the data flows, if your dashboard works, go to the business unit, and then go to the next step. And the nice idea of this kind of work is that if we see that the prototype is working, we only deploy it in some kind of infrastructure, data center, Azure, whatever. So we can transfer it to the very productive way and world, and then it just runs stable. And we don't have to add any fixes or test cases or some other stuff. Because if you start with at the very beginning to work in that kind of idea with test-driven development, microservices, continuous integration, continuous deployment, then it's easy to switch. And it just takes, I think, 20% more time to work with your team in that way. And on the long way, you become more efficient and effectively in your work. And that's our idea to say this platform is some kind of a game changer for your digitization projects and for the whole idea of digitization, because we don't need months to do anything, we just need some hours. And we don't have to think about who's responsible for that problem. Have I a mandate or not? Just do it. Find people who are motivated and let's start. And so we have on this platform, I will show you later a better picture. We integrated 2 sensors where you can interact with sensors. Because I saw that people think, okay, then we bring out a sensor for, kind of the soil, if we have enough water in the soil, if the trees are sound and so on. And then I expect data once a day or so. And then I get contact with a real sensor with a lot of flux data. I get every 5 seconds a new data point. I can't use Excel to analyze that kind of data or air quality data. This is so highly measured data, I need some other tools. And now we have this kind of prototyping infrastructure and people can interact with the sensors and then they see, okay, a lot of data, a bunch of data is coming up. So, and I promised you that you can test some urban data platform within under 4 hours. So in Germany, there's something that's called Civitas Core. It's an open source urban data platform. They integrated all that stuff they were able to find regarding open source. So there has some Frost server and some fireware database, so everything. And it's just an Ansible script, and we tested it within 4 hours. And that was cool because we saw it works. But then we were not able to use it because we're not a business unit. We don't have the business cases or the ideas. And the process automation I talked about before, it was for the traffic data analysis. So what we only need for this infrastructure is electricity and internet, so standard in every office, some small budget because you have to pay these 4 PCs, and some cables, and the router, and the switch, and so on. A lot of courage to get started, and I'm happy that we were able to do this here in Leipzig, because I think the public authority is more or less the hardest environment for innovation. But we were able to do this here, because Beata's not here, but she's got that mindset that she says, just do it and start. Yeah, and now we've got the courage to do it. And what you said before, the word before, transparency and the methods you're using. So I like open source, I'm an open source guy, and I have no problem to publish my code, even if I know it's not the best, and there are some errors in it. And so be transparent what you're doing, and always say it's a prototype. It's not the idea to use this in production. On the other side, we use some prototypes in production now because it just works, and this is not a success story. Yeah, and it makes a lot of fun then, because you can be curious and learn a lot of new things and technologies. And so imagine you have that and you're thinking about what is the next step. And we learned in the last, I think, 12 or 13 months that we would like to have some kind of spaces in the organization. A space for experiments and a space for the production. But these spaces have to cooperate. And for others, our point of view, you need some budget, some organizational units, the staffing and people and hardware and so on. but you find that people, because all these projects are value-driven and purpose-driven, and it's easy to integrate and interact with people. And we imagine some kind of bridge between this experimental space and the production system space, because what we now have, we have the prototypes running, and they're on a Kubernetes cluster, so like a cloud architecture, and we can ship it to Amazon or to Azure, but we can't ship it to our local service provider. That's the problem. It runs on my machine, but it doesn't run on their data center. I don't get it. So it's strange. And I hope they will learn it, and so that it's more easy to bring it to production. That's my ideas. So always look on the big companies. How is Spotify working? What does Google, what other don't do? And this is not unreachable goals, because they developed cool methods and methodologies and provides with a lot of open source solutions, and we can adapt it here, and we can do cool stuff with it. And so, just to mention a few words like agile project management, management 4.0, and so on. And yeah, we learned that diverse teams are a key factor. So it's always good to share your ideas, to get feedback on that. Every feedback is welcome, and that every person has a good idea for your project. So if you are not able to code, but so Christoph, for instance, he is not our lead developer, but he's interested in the things we're doing, and so he's the perfect match to talk about what we want to achieve. And so I think data science and digitalization we have to meet together on some points and work together and try out new ways. And this platform can be a table where we can meet. And another idea of what diverse teams can do is that my colleague Taras, he's a UI and UX genius, he said, okay, that cable infrastructure you have on a picture before, it's okay, but no one likes it and no one understands it. For my purpose, it was totally perfect. And so we built that IoT prototyping platform, so you can visit it within in the next minute, so if you follow Christoph, and then you can interact with it, and it's self-explaining, and it's perfectly built from him, and yeah, so we can do it in a beautiful way. There's all that prototyping as the perfect place for prototyping. So, thank you. Thank you very much.
Are there any questions or remarks? Yeah.
I think it's about the streaming.
Just the silly questions. If you can tell us more about this automated business process, which used to take 2-3 days. If you can elaborate on that, that's the first question.
Yeah. So it was about traffic sensor data. There were some sensors in the ground or the streets, and they were measuring the cars driving about it. And so we have, I think, 20 sensors of this kind here in Leipzig. And the data delivery way is once in a month we receive an email where there's a zip file in it, and the zip file, they're binary files. And then you download this, and then you open some VIN converter, some old tool from 2011, I think. And then you convert this data, and the result is a text file, and this text file you put on an Excel spreadsheet, an Excel spreadsheet, and so on, and then you do some calculations. And this is the way of data processing. And the people need 2 to 3 days. You can make a lot of failures in it. You have to explain other people how to do it if you're on vacation, and I think no one understands it. So our way was, we received that email, a friend of mine Dockerized the VIN converter scrap tool, and so we were able to bring it on our platform as a microservice. And yeah, we could just drop this zip file on a website, and then it was the same process. And we integrated the data from this converter, this this text file directly to an influx of Postgres. I think now it's a Postgres timescale database. Yeah, and then we put Grafana on it. And there you see the results and the traffic data.
And you give that to decision maker, like wrap in some app?
Yes, so our colleagues from the mobility office, they're using it. Of course, we said it's a prototype, it can be broken anytime, so it was broken the last month, now it's fixed. And so they plan some kind of bigger project around it, and they would like to test other softwares. So what I see here in the public space, that we have always big plans, and think of the perfect solution, but forget that we can start small and scale up. So I think they're happy that they can work with it, and they can use it, but it's not the very perfect product everyone wishes for, but we have to work for this.
Thank you. And I just wanted to ask about the TDD, if you have like period without and then after, if you like measured somehow that it's really faster developing this test-driven development.
It's just some gut feeling. So I'm project manager an agile project manager for 8 years now. And yeah, to explain my team that we should start with tests, it was always hard. And later, when the team comes to you and says, yeah, this test gives me a nice feeling when I refactor my code and I see it works as it was done before, then it gives you always a good feeling. And so I think we speeden up. And you think more about things, what are you doing? So what is the idea, what shall be done, or what job should be done? And yeah, and then later on, it's a control level. Because in every new feature, I have a risk to break the things I've done before. And this won't happen with a test-driven development. Okay, thanks.
Are there any other questions? Well then, thank you. Okay. So as promised, if you want to see this prototyping platform, just follow us in about 15 minutes, hopefully. I just have to switch presentations, and then... So what you've seen now from Sebastian was our motivation to take part in the sensor lab. It was the idea that testing sensors with these prototyping platform is a good site to gain insights on how to deal with these, how to deal with sensors. Does it fulfill the needs, what I expect from the sensor? Can I reach the goal I hope to do if I'm using the sensor? And what we've done in the working group was writing a kind of white paper about use of sensors, sensor register, and so on in Europe. And as Anna said, the paper isn't officially presented or launched yet. There will be an appointment tomorrow, but I like to present you some of our insights during our working process and explain you some topics where we think these are relevant for cities to think about if they plan or if they use sensors in their cities. So sensors in the city, what does it mean? Yeah, I think cities use increasingly digital sensors to monitor very different things like traffic, air quality. You mentioned an example about traffic measurement, I think, or crowd density, things like that. And what you see here on the picture is a sensor that counts traffic by car, by persons, by heavy cars, and I think also bicycles. And the sensor is in our smart city lab. So we have a sensor there to count the traffic of our street, yeah. And the map is part of a project where we work together with some cities around Leipzig So we thought using the same sensor technology is a good thing to gain insights about traffic between Leipzig and the areas around. So that's one of our actual smart city project, and hopefully we get some insights about persons who commute for work to Leipzig or who commute out of Leipzig. That's just one sensor, but one example of how we as a city use sensors. I think I don't have to explain to you that much what sensors are. Any kind of technical device that makes it possible in a digital way to sense something. Often it enables you to have real-time insights in urban spaces. Other examples here, parking availability, pollution levels, or crowd flow again. We also see that more and more use cases regarding to sensors are combined with high evolved forms of data analytics, also including artificial intelligence technologies. Also, one more reason why we think it's good to use these kind of pop-up platform to test sensors, or to use environments like this to analyze the data of the sensors right in the places where the sensor stands. So it's not necessary to have a big IT data center where all the data is collected. You can collect the data in the place where the sensor stands and just give away the analytics. But with sensors also challenges came abroad. Can you find a sensor on the image? There is a sensor at the image, and it's not the light. But there is the small box. Can you see the small box? It's beneath a solar panel. And this is also one of these traffic sensors I spoke about. We have one of these in our lab. It's behind a window, and this is the outdoor version of that kind of sensor. Yeah, and what kind of challenges arise with sensors? Yeah, it's about data collection and maybe privacy violations. It's the questions: do the people of the city wish that, or the citizens of the city wish that data of them is collected there? Do they know that data is collected there? It also leads to legal questions. Are we as a city allowed to do it? And so dealing with sensors as a city also means that we have to be more and more transparent, that we have to explain to our citizens what are we doing there, for what kind of purposes are we using their data. And that's why within the working group we talked about it. What's necessary is a kind of human-centered sensor use. And that means as a city we need to have a problem that we want to solve with using sensor data. It's the same approach as we do when we are developing smart city use cases in general. All the time we're talking about smart city use cases, we're talking about finding a relevant problem that we want to solve, collecting data, visualizing it, and so on. And it's the same with sensors and sensor data. You need it to have a problem. And then you can ask yourself, why and what are we measuring? What data is really needed, in what quality, in what quantity, and what outcomes do we expect? On the other side of this slide, I put EU digital decade targets. Of course, I think it's combined. Yeah, talking about collecting data shall be done in a way that it's concurrent to the principles of the EU digital decade. That means have people in the center, think about their freedom of choice, and so on. I won't go through all of them, but I think it's connected. When we talk about using sensors, it means we shall behave regarding to these EU digital decade targets. Another topic, I already spoke about it, is the question of quality over quantity or quantity over quality. So when we're talking about sensors, this means we have to get an idea of how much data is really necessary. Data hoarding, only to collect data, of course it's possible, is not very useful. It's your example of if the sensor sends the data every 5 seconds, do I really need it? Do I really need to store it? Or is it useless information for our use cases? Then we can skip the data. As written here, high-frequency real-time data isn't always needed, and we also have to think about the implications where and how data is stored. It means, where do we store the data? As I said, do we store it only near the sensor, where the sensor collects the data, or do we store all the data in our urban data platform, with any IT provider, or even in any cloud? So data minimization supports privacy, security, and system efficiency. And as I always would say, it also supports public trust. That the people of the city, the citizens, think, we as city administration personnel deals responsible with their data, and that's why I support the idea of data quality over quantity. Think about what's really necessary. Sensor data is necessary for us, because when we speak about more and more here supporting decisions with data, when we speak more and more about digital twins to support these data, then we need data for it, and often sensors provide us with these data. Here you can see a visualization from our Connected Urban Twins project, but I already told you that tomorrow we have a whole day where we can talk about digital twins and what we do in Leipzig regarding digital twins, and then I'll speak a bit more about it to you. And here you see this photo. I think you can see it the third time. Obviously, we are a bit proud of this IoT platform, but why I like the picture is because I like the idea that it enables us to decentralize data infrastructure, and decentralized alternatives mean that we have a local data control, that we have an improved transparency, and it also means, regarding to IT infrastructures, resilience and flexibility, because we haven't stored the data only in one point, we have stored it in several points. But it's a technical aspect. One other aspect is the ethics of sensor data. As Leipzig, we are part of the Cities Coalition of Digital Rights. That means in our digital agenda, we committed ourselves to follow the rules and principles of the Cities Coalition for Digital Rights. Every city can be part of this coalition and then commit themselves to some ethical principles, as you can read them here. It means transparency and explainability of what's done with data and what's done with sensors. Think about privacy and data protection. Is it really necessary to store the data? Human oversight and accountability. We don't want to use sensors, or we don't want to use IT infrastructures which we can't oversee, where we don't know what they are doing, how data is measured, where data is stored. We need to be inclusive and fair. That's also with regard to the city and the city space. Fairness also means or targets questions on where are sensors. As you can see when we go to our city lab, then you can see that the sensor there is in a really special place called, it's no big street. It's a small street with only a small amount of cars driving there. It's not a good point to measure how many traffic is in the city. But it's where our lab is located and we wanted to have a sensor there, that's why we measure it there. But fairness means to think about where to put the sensor to gain which results of, from the data. And I think one last point I wanted to, one last thing I want to point out means sensor registers, infrastructure. We also discussed in our working group whether it's necessary or good to have sensor registers in the cities. It means public registers where all the sensors that were in the public space listed and provided with some information about them. And I think it's a good thing to be more and more transparent to the citizens. And what you see on the screen, the screenshot here is an AI register provided by the city of Helsinki. There is, I think, something similar done by the city of Amsterdam, and that's their way of being transparent to their citizens regarding to their AI initiatives, how they use AI. And I really would suggest to do something similar about sensors and how to use sensors. Okay, I think I was as fast as possible with my presentation. Thanks a lot for your attention. I think we all had a long day and heard many, many presentations. Do you have any questions or remarks? I see the hand, I see some hands.
Hello, I actually have two questions. The first one is, besides kind of webcams or something like that, what are the data which a citizen can complain about to be measured? I mean, the number of cars is not a personal information, or the temperature of the air or whatever.
I think it's not only the question of what kind of data is measured, it's always the question of what am I going to do with this data? What do I use it to predict? So I can measure, I don't know, number of bicycles on a certain road, and then see, okay, it's a road where not that many bicycles drive along, and interpret the data in a way that I could stop progressing in building bicycle lanes. So it would be an unfair interpretation of the sensor data. That's my answer to my point to your question. Yeah.
Okay, and the second one is a more comment, but I'm quite strictly against data hoarding, because actually you never know what technologies will come later, and usually data which seems useless today can be used in a few years or decades. So, and also you can of course see like, oh, if we could have the time series for one more parameter, it would be great, but we have forgotten it in the beginning. So.
Mm-hmm. Yes, I'm with you. I know for us, we often have data use agreements here in the city where we allow ourselves only to use the data for the purpose we thought we want to use it, and only as long as the question is up. Yeah.
So it's about changing politics.
Yeah. I think there was another question, yeah?
More than a question, it's a remark too. I really thank you for this reflection about data, because we are listening every day that data is the new oil and so on and so forth. And also in our municipality, we are plenty of data, but we do not know what to do with them. So I really think that it is important to change our perspective, and starting from what why we need data, what do we want to do, what is our objective and our purpose for the citizens. And starting from them, building and understanding which kind of data we have to collect, and also trying to understand not only how we can collect data in an ethical way, but also how we can work with that data and make analysis with that. So also start thinking about trustworthy AI and all this kind of reflection also on the models that we are building, since in digital twins, it's very important also to decide what model to analyze data we have, and so also thinking about the bias that we can create through our analysis. So thank you very much.
Thank you. If there are no other questions, then I want to say thank you for your attention, and I want to propose that we meet in 5 minutes there, maybe there, and then Sebastian and me, we will go to our Smart City Lab, and we want to invite you to join us, and there we can show you and explain you the sensors I already talked about. So thanks a lot. And I don't know, is Anna still in the call? Then Anna, thanks a lot for being with us and for sharing the insights. Sebastian, thank you too. Anna, I hope to see you soon. There she is.
For having me.
Thank you. Bye-bye.
Bye-bye.